born and where he spent his childhood.
Hello. Yes.
For the villagers, he's like a messiah who has offered a means of livelihood to their ancestors and the one who went on to be a Bharat Ratna. Sir Mokshagundam Vishweshwaraya was also awarded the Knight Commander of the Order of the Indian Empire. His birthday is celebrated as Engineer's Day. But for a boy who lost his father when he was just 12 and who had to support his own education by giving private tuition to students, his life holds a mirror to the times. It's a place kept very well and where a lot of his memories live on.
Very good morning, ellarigu shubhodaya. So before starting today's first session, I would like to invite Mr. Bibang Gwara Basumatri on the dais, please. He will be conducting a session on risk assessment analysis. And before handing over mic to him and the podium to him, I would like to give a brief introduction about Mr. Bibang Gwara Basumatri. He is a research scholar with a specialization in unmanned aerial vehicle and GIS specialist. And he is a civil engineering researcher. And his academic background is BTech in civil engineering from Chandigarh University, MTech in building construction technology from Presidency University, Bangalore, and currently pursuing PhD in civil engineering. His areas of expertise are drone surveying and photogrammetry, GIS and remote sensing, building construction technology, unmanned aerial vehicle based disaster mitigation. His professional experience involves, as he has worked as a research scholar in working as a research scholar in Presidency University, and he has done a drone survey and GIS intern for clear water dynamics project. He has attended many workshops and conferences and delivered sessions related to his area of expertization, and he has supported most of the science DST programs including SIR, UGST and our own KSTA Academy. He is a key contributor to G20, C20 International Conference and multiple events at Academy, and as I mentioned, Department of Science and Technology, state as well as national events. He has published one international journal article and 7 book chapters on IoT, drones and infrastructure, and 10 symposium papers on UAV applications, smart cities and sustainable development. And he has received a grants of 8 lakh worth PIX4D license grant under PIX4D University Research Grant, and contributed to PG Diploma in Drone Technology Curriculum Development, which is known as KSHEC, and it is being reviewed. And his technical skills involved UAV flight operations, around 2,500 hours, SnapM PPK UAV model, and he is well versed with PIX4D suite, QGIS, ArcGIS, Revit, AutoCAD, MS Project, and he is well versed with the tools DGPS, Rebound Hammer, Ultrasonic NDT. With this brief introduction, I welcome Mr. Bibangji on behalf of KSTA and on behalf of Manage. Welcome, sir, and thank you for accepting our invitation. Over to you, sir.
Not right now. As an academy, I don't require certification for performing academic researches, so that's why I prepared stuff.
Presentation.
Yeah, last one.
This is front, back.
Good morning, everyone. I hope I'm audible. Thank you, Umesh sir, for the warm introduction. I'm Bibang, and I'm also a co-founder in BK Drone Solutions, which is incubated in Presidency University itself. As sir said, I'm also a research scholar in Presidency University in Department of Civil Engineering. So today I'm giving a talk on drone risk assessment and analysis. So in the before sessions, yesterday and day before yesterday, you have learned about drone components and drone parts and operations of drones and different schemes. So one main factor is like drone risk assessment and analysis. What are the different risk factors will be there while operating a drone, and how to analyze and how to avoid it or how to mitigate it. So this will be the agenda of today's talk. So I'll be taking why risk assessment matters, technical failures, safety measures, and threat error management, flyaway, fail-safe features, and different factors that is affecting the drone. So with the introduction, we know that drones have wide various applications, and for this workshop, the major application is in agriculture. Although it has also different applications in different fields, not only in civil engineering, in surveillance, and many disaster mitigations also. So while operating the drone, we know that there will be certain risks, or if you operate any equipments, or you are operating a car, bike, motorcycle, or anything, there will be some certain risks present. So while operating the drones also, same risks will be there. So I'll be talking about those risks and how to mitigate it. So why risk assessment matters? As I've told, the driving a car from point A to from point B, there is some certain risk. For example, some hazards might come in between the road, or brake failures will be there, speed limits, and the wearing of seat belts. So those are the different risks will be there. So to mitigate it, you'll wear a seat belt and you'll be careful while driving. So while operating of drones, also you should be careful within the like visual line of sight you should operate, and within the area of the survey you should operate, within the drone capabilities you should operate. So those things are there, and that's why the risk assessment matters. So these are the different points, the major points ensure safety of people and property. So while operating, you should be careful not to fly above the peoples or any properties. Property includes like some private lands or some buildings. You should not operate in dense area. For like some certain applications that might be there while operating in a dense area, that time you should be careful and following different procedures. And next is protect equipment and investment. Risk assessment. Assessment is nothing but assessing the risks involved. And it is important, as it is saying in the second point, protects equipments and investment. Your equipment is nothing but a drone. You have invested lakhs of rupees in the drone. It is not only in some thousands, it is in lakhs. Like professional grade drone, survey grade drone, agricultural drone itself, it costs around 4 to 10 lakhs. So that also determines if you are not assessing the risk, if you are not following the proper procedures, the risk occurs and it will damage your investments. Third point is supports regulatory compliance. After assessing the risk, you will have certain points you want to add. How does the different policy comes? After risk assessment only. How you are getting the, like in the car, how hazard lights came? Because due to some hazard came, and that's why it is implemented in car, right? So same for drone. There are certain regulatory compliance like DGCA, which gives us different limitations and different points that should be followed while operating a drone. Next is builds operational reliability and trust. Again, I will give example the car itself. In the car, global NCAP is there. They will give you safety ratings. If safety rating is there in a car, you will trust that car to drive because it has more safety features. Right? After risk assessment, you will get different safety or safety options that you will build trust and you will purchase a product. So same can be implemented in the drone. Next is different technical failures that will be involved in the drone operations or drone itself. So one is GPS failure. Nothing but you're getting error in the GPS. Drone has a GPS unit. Some drones doesn't have, but it has a GPS unit, for example, in the professional grade drones. So GPS unit fail will be there, battery malfunction will be there, motor or ESC failure will be there, flight controller error, compass or IMU malfunction, propeller damage, and loss of C2 link. I'll also go through in detail of all these technical failures in the next slides, but just to in short, GPS failures cause inaccurate positioning. When you're operating for a precise monitoring or precise surveying, GPS accuracy is very important. If it is not matching, then it will just give you the error data. For example, if you are putting maps in your phone and you want to go to a certain location, if that it is not accurate, you will end up in different locations, right? And battery malfunction lead to sudden voltage drop. What does sudden voltage drop do in a battery of the drone? It will just not operate properly. It will slow down the drone, or it will suddenly crash the drone. The motors will start like stop moving and all those things. And next is motor and ESC failure results in loss of thrust. Thrust means moving up for the drone. And next is flight controller error. Flight controller is nothing but brain of the drone. If a brain is slightly damaged also or slightly misfunctioning, then it will be performing beyond its logic. Logic in the sense like if it has to move straight, it will just move in some curved direction. And next is compass or IMU. IMU is nothing but inertial measurement unit, which contains accelerometers, gyroscopes, and everything. Compass orientation affects its orientation, its movements. Propeller damage. If a slight damage in a propeller, for example, some few chips are there, and it is moving in a high speed of rotation, it will just create an air resistance in that particular chip area, and it will reduce the performance of the drone. Next is loss of C2 link. C2 link is nothing but control and command. Controlling from a transmitter to the drone, if that link is broken, if you are not getting signal, then it will just fly away in different directions, or if you have some safety features, it will just come back to your locations. Next is safety management systems. Safety management systems is very important. It is required for a drone. Like what are different safety management you are doing while operating a drone or when the accident occurs. There are 4 major points: safety policy, risk management, safety assurance, and safety promotion. Safety policy is nothing but different policy or different rules and regulations, SOPs, statement of purpose, that will be given to you or you have to follow while operating a drone. And next is risk management. It says that the process of identifying hazards, assessing associated risk, and implementing measures to mitigate them before drone operations, which means that while you're operating a drone or before operating a drone, you have to do certain checks. There will be certain checklists that you have to follow and you have to operate. Safety assurance is nothing but while flying the drone, while in the operation, you have to see different, it has different factors or different monitoring units that you have to see and you have to operate. For example, sometimes if you are operating a drone and you see that the clouds are there and it is about to rain, then you have to call back the drone. That is also one of the safety assurance. And safety promotion is nothing but you have to promote, you have to tell the operators to take like safety measures while operation of the drone or after operation of the drone also. Next is threat and error management. How to manage the threat? Threat is nothing but risk. And if error comes or accident comes, how to manage it? So again, there are 4 points: identify threats, manage error, implementing mitigation strategies, and continuous learning. In identifying threats, here it is given as example: weather, airspace, conflicts, equipment limitations. Every equipment has certain limitations. It should not cross that limitations. For example, for your car, you have certain fuel range. You are not going past that, right? You are filling after like certain limits. So same for drone, there will be certain connection range will be there. You should not go beyond that. Identify threats is nothing but when you are flying in an area, you should identify different threats. For example, there are trees, there are terrains present in the area, there are high tension towers present in the area. So you should identify those threats and should avoid those. Managing errors, recognize and respond to human or system errors that arise during flight to prevent escalation into accidents. For example, sometimes what happens if you are operating a drone and suddenly some issue came. Sometimes it's a human nature that we are sometimes over exaggerating, or sometimes we are getting panicked in that situation. It should not arise. How it will not arise is if you do continuous training and continuous practice, then it will not arise. So, but if that problem occurs, how to manage that? How to manage that errors also is an important threat and error management. Implementing mitigation strategies. Mitigation is nothing but before an accident occurs, you should mitigate that problem or it should not occur. So here it is given as use checklist, standard operation procedures, and training to manage the threats. Because sometimes you may not have faced a certain threat and you are not aware of it, but someone had faced. So you should do some research and you should be ready for that different accidents that might occur while operating an equipment. And continuous learning. If you have faced a threat and that problem you have occurred and then you have faced, that is nothing but a learning experience, and then you should take a note of that, and in the next your flight or your operations you should not repeat that. Next is what are the different drone emergency situations that may occur while operations. So loss of control input from the pilot or ground stations, it will also occur. Sudden battery failure or low voltage. Next is disconnection of command and control. It means seat only from transmitter to drone, or from the ground station, from laptop, or from the operation unit. GPS loss or spoofing of causing navigation errors. And next is inertial measurement unit malfunction or drift. Sometimes the gyroscope might not properly function. Unexpected return to home activation. Return to home is nothing but an safety code given to the drone. If certain problems occurs, for example, sudden voltage drop is there, it will be having some backup battery to come to the home location from where you have flight the drone. And propeller or motor failure also can come in the drone emergency situations. Payload detachment or gimbal malfunction. How this occurs is because if you are not done proper checklist before flying, you have not check for like loose screws or tightening, you have not tightened the screws, then this may occur. Because drone will be revolving the propellers in very high speed RPMs, it might cause vibrations, or due to air resistance it may cause vibration. The nuts will be loose, so it will cause payload detachment, loss of video transmission, that is for FVP. And collision with birds, although it is very rare occurrence, but with trees, wires and structures, if you are not aware of your surroundings, it might cause crash. Strong wind gust or weather instability. So before every flight, you should be aware of the weather conditions of the area that you are going to fly. Software crash or firmware glitch. Software crash also happens because when I was operating in the field, many times the system got overheated and it got stuck. Or sometimes if you have not updated the software also, it will glitch out and you may miss few options. So you should be always like updating the firmware, and till the limitation of the system only you should operate the software. Compass error or magnetic interference. How it comes is because if there are high tension wires near your operation area, then it may cause you to have like magnetic errors or compass errors. If the compass error is you have not calibrated it properly and you are operating near the high tension wires, then it will cause errors in your readings. Overheating of ESC, how does it comes? Because if you are using the drones within like above the limit of the drone. Emergency landing in unauthorized zones. It might also occur if you are landing in unauthorized zones. So next is emergency handling framework. How to handle the emergency? So one is pre-flight preparation, detection of emergency, response during emergency, post-emergency actions. Pre-flight preparations is nothing but conducting comprehensive risk assessment and safety checks. Comprehensive means thorough. You have to do thorough checks of the drone. If you have purchased a drone from a certain company, they will also have some checklist. DGCA also have some checklist to operate the drone before flight. Ensure firmware, batteries, GPS and communication links are fully functional. That can be checked before the flight itself. So you have to do that. It should not be done in every flight. Maybe like if you're flying like 10 flights or 6 flights a day, after the 6 flights you can do all those checks. But checking of batteries, checking of like screws, all those should be done in every flight. Define emergency protocols. Like emergency protocols in the sense like return to home, manual override. Sometimes your drone is going in one direction and you have seen in, for example, high tension wires or high tension towers or trees that is going to like hit there. So you can do a manual override and take control of the drone, but it can be only possible in your visual line of sight. Identify safe emergency landing zones in the flight area. For example, sometimes what will happen, you have takeoff from one location and suddenly some obstacle came in that location. So you have to do manual override and you have to identify, before flying itself, you have to identify nearby somewhere safe space to land. Detection of emergency. So when you are operating beyond visual line of sight, you have nothing but in the ground station the telemetry data. For example, how much time flight it is going, how much voltage it is remaining, and how much distance it is there from drone to the home location. All those can be checked in the detection of emergency in the monitoring under your system. Detect anomalies like signal loss, power drop, abnormal altitude, or erratic flight behavior. In the system itself, you can see, you know about waypoint system, right? Like drone is operating in an automatic way, like lines. So if that drone is deviating from the line abnormally, sometimes you may not see, but sometimes it will be a little curved and it is deviating from the part of the drone. So that is an abnormal behavior and you have to rectify that one. Taking different measuring actions like return to home, all those things should be there. And erratic flight behavior is nothing but same that like deviating part. Confirm emergency via visual line of sight. If the drone is in your visual line of sight, lighted, you have to confirm. Sometimes the software might glitch and it will show lighted. So that's why you should confirm in your visual line of sight only. Response during emergency. So what different response you can give during that emergency situations. For example, flight is deviating, the drone is deviating away. Activate fail-safe functions like return to home, hover, and land. Hover is nothing but altitude hold. The drone will stop in that part itself and it will just hover around in that exact location. And RTH is nothing but return to home and landing where it has stopped. But the issue with hover and land functions is if you are flying above a certain area and that vertically down it is landing, after you give an emergency command, it will just land in a certain area where you have not confirmed that it is safe or not. So that is like you should mostly use RTH or return to home feature if you have battery remaining. In case of emergency in your visual line of sight, where the drone is going to land, you have to clear that area first and then land it. And next is switch to manual mode. As I've said already, communicate with the support crew. You will have, while operating a drone, you should always have a co-pilot. Or if you are in a controlled airspace, you can ask the ATC also, although it will be not communicated mostly. Prioritize public safety, avoid flying over people or property. We know that already. Post-emergency actions. For example, your drone has crashed and you have to do analysis. So there's a post-emergency. You have to secure the drone data and data logs. Data logs is nothing but, as in an aeroplane, there will be black box where it will have the telemetry data of that flight part. Same, the drone has data logs. Conduct root and cause analysis and incident reporting. So what caused the accident, how it came, what was the part, and what is the cause of that accident. You should do all the reporting and you should make a report and analyze it for the further use or mitigation of the accident. The next is loss of C2 link. So we'll see what is the cause of, like control to command causes issue will be there. One is RF interference, disruption for nearby wireless signals or power sources. Power lines means not the normal power lines, it won't affect the drone, and the Wi-Fi won't affect the drone itself. But the telecommunication towers and the high tension towers might affect your transmitter to the drone. Obstruct line of sight. Line of sight in the sense, for example, you are standing here and there is a tree in between and you are operating the drone that is beyond in the sky. The tree will obstruct your transmitter to the drone connection and it will lose signal. That also occurs. Low battery also is one of the factors, although it is in rare cases. It will just give you weak signal. Out of range means out of the drone communication range. Hardware malfunction. Sometimes the transmitter antenna might be loose or broken. It is not in the proper position. It also causes loss of communication link. poor orientation, as I've said already. Electromagnetic interference in the first point, same as that. Firmware and software bugs also causes C2 link loss. Sometimes your system is stuck and you want to do some emergency mitigation techniques, and then it's stuck, and then you press different options. It will also affect those drone operations. So these are the mitigation strategies for C2 link loss. Certain drones has, like, if you are lost for a signal for 1 minute, it will automatically come back to the home location. So those return to home feature is there. Maintain line of sight. For example, if you have lost a drone in, for example, your area of service in your line of sight, but still you have lost a drone or like connection, you just try to do orientation of the transmitter with the drone, then it will get connect. Use dual frequency control links. So different frequency can be used for stronger connection. If one frequency is lost, then you can connect with the other. Conduct pre-flight signal check. So before flying only, you have to do compass calibration. It also shows the interference with RF or wireless or high tension towers. Set flight range limits. You should do geofencing for a certain flight area. That is as it is. Keep antennas properly oriented. So antennas should be properly oriented to the drone direction. Again, update firmware regularly. Avoid high EMI zones. Same. So if you see this is the flight part. Drone has completed almost half of it. And so if you see here, the blue line and the red arrow is nothing but the drone. And here is the blue line is the completed part. But you can see one certain gap is there. So this is where the transmission was lost. So it has connected after a while, like orientation issue was there. So that's why it is connected. And you can see here in the compass is there, it is showing green. It means there is no wireless interference or high tension towers are there. If it is in red, then a compass calibration issue is there. So all those things are there. And next is flyaway. Flyaway is nothing but as is shown in this graphics. It is flying away, drone is flying away with connection loss. So these are the different causes of flyaways: GPS signal loss, compass calibration errors, magnetic interference again and again, firmware glitches, manual pirate error. Sometimes manual pirate error also occurs when you are giving inputs to the software. If certain sometimes you have not updated the home location, it is somewhere in the previous surveyed area, which is, for example, say 10 kilometers far away, but drone has only limit till 2 kilometers or something. If you have not done that properly, then it will just go and land there, and it cannot connect, and it doesn't have battery to go till 10 kilometers. It will just crash somewhere in between. And next is auto flight parts error due to software glitches. Sometimes auto flight also give different parts if you are not set properly. Wind drift in auto mode if it is not stabilized. For example, if you are operating in like bad weather conditions, wind drift to the side of the drone will cause it to deviate from its path. And for example, certain obstacles is there near it, then the wind gust will come and it will just hit the obstacle. Sensor failures are there. Inadequate pre-flight checklist. So you have missed some checklist. In the drone operation, every checklist is important. You should not miss any checklist. So prevention is perform accurate compass calibration before flight. Wait for strong GPS lock. If I go back to this slide, you can see here this GPS set count. This is nothing but satellite count. And this is the GPS drop. Like for this software, the minimum drone operation, if the satellite count is less than 15, that involve flight itself. So there are certain safety features integrated in different softwares. Okay. So here it is showing avoid flying near magnetic metal sources. Same again and again. Update firmware, start geofencing and max distance limits. I'll show where the max distance limits also is set in the next slide. And fly in open obstacle free areas. Although every survey area might not be open space and open areas where you can be able to keep visual line of sight, but when you are operating a drone, try to, for example, in survey drone. In survey drone, you will be operating, for example, the area of the surveying will be 2 square kilometer, and sometimes it won't be like visible in the visual line of sight. Try to go in the terrace and operate the drone. So it will give more strong signals. So next is train with manual flight skills. So when you are training or when you are practicing with a drone, you should be proper in manual control. So this is one video for it saying that it can cause so it is showing that flight path of the drone, and in between you can see there is a terrain. For example, if the drone fly from here to so let's continue. So if the drone fly from this point to this point, here I am here and it is flying from this point to this point, the drone is going like this and it went here and it went here. But as I have said, the C2 link loss also can be due to obstructed some objects will be there. This is nothing but a hill is there. So here I lose signal in this part. So as I've said, for this software, if you lose signal for 1 or 2 minutes, it will automatically come back in the like home location from where you have flight. But the issue here is, for example, I have lost a signal here and it is already 1 minute up and it is came here in this point and it is coming back. The drone will straightly come back to its shortest path without changing its like altitude. If the altitude here is like 80 meters, it will just come back from here in the straight diagonal path 80 meters. But our hill is 90 meters. So what will happen is it will just come back straight and it will just hit the hill. So that is also one of the major like while planning of the surveying, you should take notice of that or take care of this. So next is loss of power causes. So battery depletion is there, failure to monitor battery percentage during flight. So when you are operating a drone, here in the same this slide itself, here you can see the battery voltage. So the minimum battery voltage is set as 18.9 volts for this flight. This is 6S battery. So here it is 22.8 volts. In the newer version of this software, it is converted into percentage for easier user interface. So this battery malfunction is there, battery depletion is there. You should always take care and observe the battery depletion rate. And battery malfunction is nothing but damaged battery. Sometimes what happens is if you keep the batteries in sunlight, then it will deplete the battery, and although you have checked and keep it, but before the flight operation you didn't check, then you have inserted. And other, for example, 3 batteries goes in a drone, and 1 battery you have kept in sunlight and it is depleted. And if you have inserted all the 3 batteries in the drone and you have connected, but there will be some voltage difference between those 2 batteries. So what it will just deplete the performance or decrease the performance of the drone, or it may cause voltage drops also. And overloaded payload also causes power loss, as if it is past the maximum limit of the payload carrying capacity of the drone, it also causes power loss. Weather conditions also, it is given as low temperature also, and high temperature also it will cause power loss. And different wind conditions also, if your drone is going against the wind, then it will just decrease the capacity of the drone. Power distribution board failure also, it's there, electronic speed controller failure. high power maneuvers. For example, you are taking off the drone with manually and you are just maneuvering with sudden movements. It also causes loss of power because you are increasing the RPM of rotor RPM of the drone and you are directly decreasing it. It will cause sudden changes in the power. Improper charging practices. For example, you have used a drone, a battery, and it is already for that flight, one flight is done, and again you are started to charging after directly the use of the battery. It will just decrease the battery life of that battery. Power loss solutions. Conduct pre-flight battery health checkups. Inspect the different voltage, how much it has depleted. As you know, with for example, your phone battery has certain life cycle, certain charge cycle. For example, 500 charges or 1000 charges cycle will be there. So after a few charges, the battery capacity will start depleting. In the iPhone also it is there, like battery capacity percentage or something like that is there, you can see that. So all those batteries will have different life cycle. Use high quality and compatible batteries, because for high performance drone or for agriculture drone itself, it is having octacopter, like 8 propellers, and it requires more thrust to uplift it and use for the operation. So you should use the high quality batteries compatible to them. Set low battery return to home thresholds, as I have shown in that photo in the drone software. If it hits 18.9 volts, then it will automatically return to the home. So those thresholds should be saved. Here it is given as configure automatic RTH at 30 to 40% battery. Why 30 to 40? Why not 20? Why not less than that? Because from returning from point A to point B, it also take lot of battery, and while coming down also it will take battery. So those thresholds should be kept. Avoid flying in extreme temperature. Balance payload and power requirements is required. Balancing is also important, because if it tilts in one point and the wind gust is coming to the front, it will also decrease the performance. And also the balancing of the drone won't be proper. Follow proper charging and storage practices. As I've said again, charging also should be proper, and storage practice, nothing but keep in room temperature. Don't keep in sunlight or too cold. So next is control surface failure. Nothing but the motors failure will be there. So servo motor malfunction will be there, like faulty or burnt out of sensors. Sometimes it will wear out, disconnect and damaged links. A little short circuit will cause the power loss and the motor won't function properly. Signal loss to PWM, pulse width modulation channels. Controller signal interruption causes surface inoperability, means if you give input also it won't work. Debris or physical obstruction. If you're flying the drone in a certain locations, for example, for sometimes in the agricultural field there is no like a hard surface for where you want to keep and fly. Sometimes loose dirt will be there. If you're operating in that areas, then all those dust will come and enter in the motors also. So those should be avoided. It will cause damage to the motors and it will reduce, or it will create more resistance to the motors. Overstressed flight maneuvers. Extreme or abrupt control, as again I have said, you are not giving abrupt control, it will just wear the motors. For example, if you give sudden acceleration to car and sudden clutch changes, it will just break the gears, right? So like that also you should not give sudden inputs to the drone. Electrical short or power surge, it can also burn the motor. So control surface mitigation, pre-flight surface check movement checks, like before flying certain rotation movement change. The checks use redundant control system, dual servo motors, backups should be used. Although in the quadcopter, if you lose one motor, it will just crash. But in the hexacopter or octacopter, if you lose one motor also, you can do emergency landings and all those. Perform regular maintenance, fly within aircraft limits, all those points says for itself. And next is regulatory issues. What different regulatory issues will come with the law, or certain you have step out of bounds of the SOPs or different limits. Flying without DGCA permissions also has regulatory issues. Although there are different zones, red, yellow and green zones, you can only fly in the green zones without permissions. Although, but you should not, you can fly without permission in the green zones, but there will be some, you should not fly above the private properties or something like that, it will be there. You want to fly within red zones or green zones, means you should definitely get permissions from the DGCA. For yellow zones, sometimes two zones are there, like inner and outer. Outer, you can take permission from your local police stations or head office, something like that. Violating no-fly zones. If you enter that no-fly zones, sometimes in some drones itself, it won't enter the no-fly zones itself, or it won't take off itself from the, if you're flying in the red zones. Exceeding altitude limits. According to DGCA, maximum altitude is given as 120. If you exceed that, then it will be a problem for the operator. Lack of remote pilot certificate. If you are using drones for commercial purposes, definitely remote pilot license is required. For academic purposes, it's not required, but for commercial purposes, definitely remote pilot license is required. Without that, if you operate, then you will get fined. Unregistered drone use. Every drone has UIN number, unique identification number. Like a car, you will have a registration plate. If you drive a car without registration plate, what will happen? You will get fined. Same with the drone. Inadequate data privacy measures. So capturing images without consent may breach privacy laws. Failure to log flights and maintenance. So if you don't maintain your car and you're operating in like certain without about the limits, then what will happen? It will just break down. Same for the drone itself. You should do regular maintenance check. Logs also should be maintained. All those things should be there. Non-compliance with night flying or beyond visual line of sight. In the red and yellow zones, if you fly beyond visual line of sight, then it will be a problem for you. Night flying is also, so maybe in the updated rules and regulation, night flying is allowed with certain restrictions. So next is environmental hazards. So what are the different environmental hazards are there? Strong winds are there, rain and moisture, fog or low visibility, extreme temperature, bird strikes, although it will mostly happen in the without propeller drones, dust or sand, electromagnetic interference, sun glare or harsh lighting. Environmental hazards is not only the natural factors but also the man-made structures, all hazards that is coming like in your environment. Sun glare and harsh lighting, when it occurs, when you are flying FPV drone and the camera will have glare, then it will just cause eye strain and suddenly you will just give certain inputs and it will start to crash. Next is environmental hazard mitigation. Check weather forecast. There are different apps to check accurate weather forecast. For example, one is Windy app, or your Google weather app will also fine. In Windy app, you will get like wind gust speed, wind speed in meter per second, in whichever units you want also. So those weather conditions you should check before flying. Use weather resistant drone. Although there won't be exactly weather resistant drone will be there. You can put in your normal agriculture drone or your normal survey grade drone, you should put sealant in the gaps of the drone. Install propeller guards. So minimize damage from bird or object strikes. If you have propeller guards, then the guards will only be damaged. The propeller will be safe. Fly in open, clear areas. So as I've said, if you're flying for a survey grade drone, you should go to the building top where no obstructions are there, and you should fly with it. Equip drones with visual sensors. visual sensors also, ultrasonic sensors also, obstacle detection sensors also should be implemented in the drone to avoid environmental hazards. Clear and inspect after flight. Clean and inspect after flight. Remove dust or debris from motor, etc. It will mostly be done in servicing of your drone itself. So avoid EMI prone zones. As it is saying, like cell tower, power lines should be avoided while flying. So this is one of the case study happened in Gurugram in February 16, 2024, where this drone, which is a delivery drone, was operating, and while operating it detected some obstacle which it could not overcome, and it started for emergency landing procedure. But they have not checked the emergency landing site. So what happened is some issue came and loss of that C2 link came, and then it hit the satellite TV dish. Then it crashed. So here what are the legal action taken was the drone was flew during a section 144 ban. That time one BIP visited in that area, and that's why they have flown the drone. Maybe they have thought for certain actions, and they have got a FIR. And so the cause of this action was loss of C2 link. Cause of this crash was C2 link loss, or maybe without proper inspection of emergency landing. So the key takeaway from this case study is the incident highlights gaps in drone safety systems, real-time regulatory alerts, and urban drone operation protocols. In our urban operation of drones, it is very limited because they will be very closely packed, and we could not predict the layout of the urban structures. Sometimes it will be ground floor, suddenly it will be third floor. So although if we give advanced sensors also, it will have problems while operating in urban. And this is a big drone. It's not a small drone which is feasible to maneuver the urban structures. Next is human performance causes. What cause accident cause can be happen from humans? So you can see pilot fatigue. Here that person is tired. If you perform in your fatigueness, or if you are in a sick, and when you do operations, you will just reduce your alertness and quick decision making if a problem comes. Lack of training leads to poor handling and unexpected situations. In Indian scenarios, we'll say if a problem occurs, we'll do some jugaad, but that can be done because those are very high cost equipments, and it will be your loss only. Overconfidence or complacency. Say this person is overconfident, I can do it. But you know that certain times overconfidence can cause to certain accidents. Cognitive overload. Too much information or multitasking leads to errors. So you should stay to simple operations. For example, while operating a drone, you have two pilots. One, you are a main pilot and co-pilot. So you should not take up all the burden. It will just cause errors in your thinking capability. Stress and anxiety also there. Distraction, poor communication. With your co-pilot, it will cause misunderstanding to give inputs. For example, if you are telling, I want to fly the drone till this land, and you have not told him clearly, and the co-pilot misunderstands, and he has given some other inputs. Those poor communications will affect. Inadequate pre-flight preparations, missing checklist, or ignoring alerts leads to failures. In India, sometimes in certain locations, temporary red zones will be there. So you should be aware of those temporary red zones or temporary no-fly zones to operate. That is in your pilot consideration. Pilot incapacitation, what causes? When you are operating a drone, and what problems might occur to the pilot itself? Because pilot is also an important part of drone operation. Heat stroke or dehydration, prolonged exposure to sun causes physical breakdown. If you are not properly hydrated in the field and you are operating the drone, it will just cause you dizziness and dehydration. Sudden illness. While operating, While operating an FPV drone, you will put goggles in your eyes. If you operate for a longer duration, what will happen? You will just cause eye strain, and you will feel like nauseous. So all those things will be mental fatigue. If you fly for longer duration, for example, in your agriculture spraying, that will be done in minutes. You leave that. In drone surveying, if you are flying for a longer time, what will happen? You will cause you fatigueness. So proper rest is required. But sometimes certain deadlines will be there. You should not rush into that. You will just have problems in your decision making also. Disorientation or vertigo, especially in FPV flights or higher altitude missions. Sometimes if you are flying in a higher altitude, for example, you are in the top of the hill and you want to survey area, you should not have fear of heights when doing that operation. Stress-induced panic, unexpected failures or environmental issues can overwhelm the pilot. We know that a panic attack will be there. Sometimes if you are having some accidents, sometimes someone can't handle those failures. Lack of situational awareness will be there. So those factors we have to take care. Overexposure to screen time also it's there. So mitigating human errors is like regular simulator training. Every time when you want to go and get a pilot certification, they will do a simulator training before giving you the drone, right? So proper simulator training should be there before handling the real drones. Standard operating procedures should be followed throughout. Limit pilot duty hours. As we limit ourselves to our work for certain hours, for example, for office hours from 10 to 5 or 10 to 7, like that, for operating our drone, we should limit ourselves. Use checklist for every flight. They say certain regular checklists will be there for every flight. All the time, you should not do all the checklists, but certain every flight checklist will be there. Assign a safety observer or co-pilot. As I've said, co-pilot should be there with you all the times. Conduct regular briefings and rebriefings. For getting pilot license, I think it will renew after every 10 years. So, although that, but you should give a regular assessment to yourself of the updating knowledge and all the advances in the drone industry itself. Promote situational awareness trainings. Help pilots anticipate and react proactively. So if you are in an organization and you have a drone company, then you want to create awareness for your employees also by conducting regular trainings. What problems they have faced, and you also take inputs from them, what problems they have faced. Like that only they will discuss and create one SOP like this should be followed. Next is pilot technical error case study. So in this one of the case study that was in Eau Claire in USA, Wisconsin, where an operator was flying a drone and caused, due to maybe technical or pilot error, it crashed into a car where the 15-month-old baby was inside, and it caused some minor accident. It didn't harm the child. So here suspected cause was pilot reported loss of control, possible C2 link failure, or flight control malfunction. If you are flying in a low altitude, it will just crash, like without getting proper GPS signal and properly. So here they have investigated, and maybe they have found technical or pilot error also. Although if you have caused an accident, sometimes you will not accept this is my issue, like cause. So key lessons is shows there's need for strong safety protocols, pre-flight checklist, and no-fly zone near people and vehicles. So this pilot did not follow the protocols. For example, he should not fly near peoples. So other drone emergencies are IMU or barometer failure, causes instability in incorrect flight altitude data. If you have had like incorrect flight altitude, what will it cause? It will just cause, like if you want to overcome a certain obstacles and you have flight altitude error, it will just crash there because it is not giving the exact altitude. Camera gimbal malfunction affects imaging quality and payload control. Those malfunctions should be checked beforehand. Payload detachment mid-flight as I've said again, propeller damage or detachment, motor overheating, fail-safe malfunction. Sometimes your return to home also might not work due to some malfunction issues, or your technical software issue glitch will be there. Software freeze or lag. If you're operating in a system which is not incapable, for example in older system, then it will cause you the software to freeze or lag. Unexpected terrain collision caused by misconfigured altitude or obstacle avoidance failure. Before I have shown you one terrain and the flight part, right? If you have not given like follow terrain option, then it will just go through the terrain and it will hit the hill. So next is different fail-safe features here are listed. Return to home, geofencing, nothing but limiting an area of the drone to be flight. Low battery altitude, auto land. If the battery is in low battery, then it will just automatically land in that position where it has stopped vertically. Dual GPS IMU systems. So you should use dual GPS or proper IMU systems. Obstacle avoidance sensors, fail-safe hover mode, drone holds in position as I told you. Emergency propeller stop, instantly shuts down motor during crash or risk entanglement. Why it is required? Why the emergency propeller stop is required when the drone is falling? Because to reduce the damage of the propeller. For example, if the drone is falling and the propeller is still rotating, it will just cause instability and while falling also. And if it hits some obstacle, the propeller will rotate and just hits the obstacles and it will just break. If the propellers are stopped during the descent only, then it will just reduce the damage. ADVS receiver integration detects nearby manned aircraft, although it is very unlikely to integrate this because still not proper airspace is being created for drones. Although for flights there are air traffic control or air traffic management, but for drones it is not there, or it might be there, it is in like research stage. So here we can see in this RTL is there. RTL is nothing but return to launch, return to home feature. So this will be selected if you are having problem. See, in this flight it is not completed. Here some weather issues were there, it started to drizzle. So we have called back the drone. This is the home location, here somewhere it is there. So we have called back the drone. This is the integration of RTL or return home feature. So you can see here distance to home 342 meters. From this point to this point is only 342 meters distance are there. So all those parameters are there for you to check during the drone operations. And you can see the battery voltage also 21.61. Sometimes if the battery is low, it will automatically take return to home. But if you think sometimes if you take the return to home feature when the battery is low, the battery will start depleting while coming also, and it will cause instability. So before hitting the battery low mark, you can call the drone to reduce the risk. So all I have been talking about risk management, risk assessment, risk mitigation. So those are risk mitigation point, one of the point. So next is here also same. Here drone was operating somewhere, maybe high tension tower was there. So that's why this compass indication was red. So what we have to do is, even if you flight this area, it will just cause us error in the data. Next is, so here in this slide, this is the waypoint, flight waypoint, and you can see here different inputs are given. Height is given 160, although limitation is 120, it is automatically taken 160. We have to reduce this height altitude to 120 because maximum altitude for flying of drone is 120. And here takeoff altitude is nothing but from, if the drone is going vertically up, and from where it will take off. Or if this is 100 meters, from till the first point it will just go gradually increase to 120. So flight speed is given here, and grid angle is nothing but the orientation of the angle of the grids of this waypoint. And here is one of the safety features, follow terrain. This is mostly for survey grade road. So if you are operating the drone in terrain area, so you have to always keep this option. It will go along the terrain of the hill. The drone will fly along the part of the hill. If you don't give this option, what will happen? The drone is moving in the straight parts only. In certain altitude, for example 120, it will just fly in 120 like exactly for all these flight paths. Its altitude won't change. But if you have given follow terrain mode, for example there is one hill and there is 150 meter. From point 150 meter, it will just take 120 meter gap and follow the terrain of the hill. And yaw, hold, crossfly is nothing but zigzag pattern. And here it will give you different statistics. Area of this, area of the survey is 1.13. Total area of how much photo count, it will also predict and tell you. And photo interval, trigger distance. Although this is, you can't see here properly. Max distance will also be given. Max distance means from this home location till the max. For example, this is the max distance. What is the max distance? Max distance of the drone is nothing but from point A to point B, how much till when it will lose its connection. So you should not go beyond that max distance. If it is going beyond that, in this max distance, it will show red color. For example, for this drone, max distance is 2 kilometers without obstruction. So you should not go beyond that. So it is one of the fail-safe features where it is showing that warning you, if you go beyond that, it will cause problems. So this is one of the risk mitigation point. And for today's talk, what is the key takeaways is nothing but risk assessment is critical to ensure safe, reliable, and regulation compliant drone operation. Point says clearly. So we should avoid risk, we should follow the protocols and then operate the drone. Technical, environmental, human, and regulatory risk must be identified and mitigated before every flight. Different technical issues might come, so you should, before flight only, you should mitigate it, or you should avoid that problems. Emergency preparedness should be there. Human performance and SOP adherence are important as hardware and software reliability. You should be in your proper state to operate the drone. If you're feeling that you are not well, then don't operate it. You won't drive a car when you're feeling sick or dizziness, right? So same. Regular training, simulation, and post-flight analysis help build a proactive safety culture. For example, regular training, regular checks, it will just integrate it in your culture and discipline then before flying, before operating many type of drones. Fail-safe features like return to home geofence and redundancy are essential for mission continuity and recovery. Real-world cases studies shows that most accidents are preventable and with proper planning and protocols, because every accident can't be caused like unexpectedly. Sometimes unexpected might comes, but it can be avoided. So those things will be there. For example, again I'm giving you the example of car only. If you don't do proper maintenance, what will happen? You are not doing the risk mitigation. You are just giving away the risk. I will take the risk and it will break down somewhere without proper maintenance. So same for the drone itself. So concluding this talk, I'll say that risk assessment, risk mitigation is important for drone operations. You should do proper following of SOPs and everything should be done properly. Then only there will be smooth operation of the drone. Thank you. Any questions?
Specifications of the readings, the compass readings,
yes,
and the flight. So they do continuously operate during the flight also?
Yes, they will give you real-time data.
Not just the pre-flight only, right?
No.
So, so that is one thing. The second doubt was how to check the data loss from the, I mean, capture, if it, yeah, you have shown that capturing is not there.
Yeah.
So for especially like crop monitoring purpose, so because if it is like heavy hyperspectral data, what we do is like we will connect the data captured directly to the server. So how do we check that the data, there is a capturing, but it's not being going to the server also. Sometimes that link also will be there.
Although,
So,
yeah. Although like there are different types of drones, for example RTK and PPK. What I have showed you is the PPK based drone. It won't, like, even though signals are lost, it will just be storing the data in the drone itself. It won't be giving you real time. Later you have to take the data and then convert it into real time and then use for photogrammetry purposes or for mapping of map. But if you are using a RTK drone, real time kinematics drone, then what will happen is, even if the signal is lost, that time it won't take the data. So what I've showed you is, like, as you have said, you want to directly update it to the server. Maybe you are using a real-time drone. That time, if you are operating in a signal loss situation, then that will be in your own fault itself. So you should avoid, you should do in a clear survey, or use the PPK-based drone.
so one more question.
Yeah, sure.
So this micro weather condition, usually if we use the windy app or something like that, it gives the local area. But whenever we are taking the drone, we need to understand the microclimate of that particular location in that particular time. So what do you think, other than using this app also, like yesterday there was also the real time, we have to sense the wind. So how do we, is there any other precautions that to be taken?
Any other precautions will be on the pilot itself. You have to do visual, visually you have to see like if clouds are forming in that area or not. So, and wind speed is nothing what I can't predict. If the drone is flying itself in the, for example, in the where you are standing, the wind speed is maybe less, and in the higher altitude it will be more. So what will happen is, if the drone goes up, and it will automatically detect the wind speed. If it is crossing more than its limit, it will just alert you.
In that case, can we have, in the software only, can we see two different paths? So what is the flight planned actually, and whatever the drift is included, whatever the surveyed drone path. So can we get the path difference also?
Yeah. If it is drifting, then it will show, but not in the software. While you are doing the post-processing of the data, then you will be able to see. But in real-time kinematics drone, you might be able to see that path deviation.
Okay.
Yeah.
Sir, one more doubt.
Yeah.
So in usually like for cars and all, we have a regular proper health check of the car with this thing. So is there any other health checkup of the drone also before? Usually for upkeeping of the drones, is there any that sort of instrument?
Instrument are not there, but different checklist will be there.
Okay.
For example, you'll be handed a checklist from the company from where you buy a drone.
Okay.
For example, propeller check, or a loose or nut check, or like if it is rotating properly, or like before, if the camera is clicking properly or not. All those precautionary measures will be there, checklist will be there. If it is done, then you just have to tick that option.
Okay. Sir, could you just once explain about the compass error? How does it result in the data error?
Afterwards, he will be here only till lunch break. You can discuss. So thank you very much, Bivangji,
Thank you
for such a wonderful presentation. On behalf of all of us present here, thank you once again.
Thank you, sir.
So now I would like to invite Dr. S.N. Omkar sir on the dais, sir, please. Bivangji, stay here only. He will assist you. Sir, please welcome to this. Now we have with us Dr. S.N. Omkar sir. Welcome sir on the dais. So sir will be delivering session on drone computing and precision agriculture. First and foremost, I would like to thank Dr. S.N. Omkar sir for accepting our invitation. In spite of his busy schedule, he has come here today And on 9th also they have conducted the same training program in especially in Kannada language, right sir? Exclusively in Kannada language, which has been helpful for most of the rural farmers and progressive farmers as well, right? Progressive farmers, and it was open to all. I hope Dr. A.T. Kishore sir has attended that event. And now before starting the session, I would like to give a very brief introduction. Actually, sir needs don't need an introduction about his profile. Sir is I think you might have seen him in most of the TV programs. He will be conducting yoga sessions. Many celebrities also take consultation of sir's yoga expertization. Apart from that, coming to his main area of research, he is a chief research scientist in aerospace engineering at Indian Institute of Science, Bangalore, and he has obtained his BE in mechanical engineering and PhD and MSc in aerospace engineering IISc. And his research areas are helicopter dynamics, unmanned aerial vehicle autonomous navigation, satellite image processing, biomechanics, composite optimization, and structural health monitoring. And apart from that, professional highlights are he is a founder treasurer of the Automatic Control and Dynamic Optimization Society, an IFAC affiliate, and served as a research advisor to TCS and reviewer for EAV and land resource projects such as micro UAV and remote sensing initiatives. And he has most scholarly impact over 140 more than 140 journal articles and extensive conference contributions, and he holds patents on UAV based aerial image analysis, for example power line detection. In summary, sir is a researcher and mentor at IISc with decades of experience in aerospace systems, UAV autonomy, remote sensing algorithms, and biomechanical modeling, recognized for innovation in academic societies and applied research leadership. With this brief introduction, I once again welcome Dr. S.N. Omkar sir. Sir, please welcome. And thank you very much sir for accepting once again our invitation to be part of this program, sir. Over to you, sir.
Namaste. First thing, have you heard me before? Huh? I could recognize you, then I am in danger. Because this is some maybe 150 times I am fiddling with the same PPTs. So if you are new to my talk, very good. If you are already gone through this, you will see few updates. After all, how many new work can we do? So such people who are repeat, please excuse. Drone computing, the definition is that use of computers in drone driving and drone data deciphering. Flying drone today is no big deal. Everybody flies. It's now kids play. Nobody appreciates simple if something takes off. But what do you do with the data that you take with it? Our lab is one of the oldest academic lab in the country. UAV lab at IISc. It was inaugurated by Ratan Tata. And yes, this is something that I use this as the symbol for today's whatever is happening. You see the Vishnu and Garuda. Garuda represents the vehicle of Vishnu. So Garuda also represents drone. Vishnu itself, you see, is the Narayana, Naram Dadati, which means he is the one who gives knowledge. Knowledge means intelligence, AI, artificial intelligence. Today drone and AI, they go together. A lot of things are happening with drones and AI. That's why I've taken this mythological. Yeah. Why AI? Because it can give you complex insights. It can give predictive analytics. Today, in most of the things, it is there. It has become so much so that most people have stopped thinking. Anything else, they say ChatGPT. You want to write a letter, you just give that. That's all. ChatGPT will draft. You send it. You want to make presentation, ChatGPT. It will give you everything. But none of the videos that I show you are downloaded from YouTube. It is all what we have done in our lab. Let the credit in our presentation. But we should be mindful of energy consumption and computational time when we are using AI, because they are consuming a lot of resources, and their energy consumption is quite large because everybody is using AI for everything, and especially these days engineering students, all students, not engineering. Today any assignment, no need to struggle. The teacher gives the assignment, in 5 minutes the answer, including all the project report, everything is ready. They can take a printout and submit. That's how it has become. So today, for us teachers, it has become very, very painstaking, because the way we used to conduct the tests and exams have to be re-looked at. The way, because long back, we used to, not very long back, 1 decade back, we used to conduct what is called as open book exams. You can bring your notes, you can bring any textbook you want. Now it is not possible. One mobile phone is enough. Tuck, 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 it will solve everything for you. Well, this is very, very important. This, you see, on the left side is the pyramid structure, where man is at the top and all other creatures are bottom. So we thought that we are the most intelligent people and everything is our servant. But with hard lessons, we have learned that it is no longer so. Right side is the spherical structure, where man is also an element along with all. You cannot neglect. So if you want to make any development sustainable, it has to be like this. Man is also an element. Today we are talking so much about drones, but excess dependence on drone and AI, what will happen? Now today there are hardly any drones flying, not in number I am saying, but what we are envisaging is when it becomes all these delivery drones, everything they become, then the whole space will be crowded. Then what happens to birds? Already in Bangalore, birds are almost, except some crows and pigeons, not much. You don't see sparrows, etc. They are gone. What will happen to their ecology? They are already driven out. It's a serious question. And again, noise. What will happen? So all that is there. So we have to make anything that is sustainable. And even pestification today they are using left and right. And pestification, when it is done, now are you doing targeted way? Not it. Although it is possible, you instead of human, we are doing with drones. And when doing with drones, if there is any wind, sudden wind, it will be blown, and where it will go, what it will pollute, we don't know. And what is the, that whatever you spray, if that spray droplet size is more than the opening at the leaves, then it is of no use. It will simply go waste and it will spoil the soil fertility. So these things have to be done. In fact, we, myself and Kishore, both of us, I was chairing that session. We have made one committee, special committee for standardization of agri drones in India. It has been already published by Gazette of Government of India's Gazette, but still most people don't follow any standards. That is the problem. So this is it's a beautiful picture which I liked, is the dolphin at Bihar. Can you ever imagine seeing a dolphin in Bihar? Never. But during COVID it was seen because not many people went to seashore. So absence of the so-called evolved humans will bring all these natural inhabitants closer. And you see on the right side, the Wayanad disaster. Because so many people, so many guest houses, homestays were built. So many people, so much of load was put on a hillock and that whole thing got collapsed. So this is the classical example of not so sustainable developments. Sustainability, we should understand, is a survival requirement, not a charitable choice. This is very, very important. We should not think that we are helping some bird or snake. Never. If we have to survive, all of those species have to survive. So we need to look at artificial intelligence also for good, meeting the needs of the present without compromising the ability of future generations to meet their own needs. So nutrition, food and water, clean environment, well-being and security. In most of these areas in our lab we have done some work which I will highlight. So these are the various types of UAVs we do in our lab. It includes fixed wing, rotary wing, hybrid. I think we have done more than 120 different types of vehicles, all designed at our lab, fabricated, flown, everything we have done. And to tell you, most of the students involved are from not IISc or IIT thing, all from what generally people think as grade B or C colleges. They are the students who have contributed a lot for these things. So it is their work, their walk and my talk. So this is all okay, I'll skip. Yeah, this is one of the flagship projects that we did. You can drive the drone just by thoughts. You can wear a EEG headset, you can think it has to go to right, it will go to right. You can think it will go to left, it will go to left. You can think, make it to come down or go up. Some 4 commands we can implement. This is called the brain-computer interface or thought-driven drones. Of course, this involves a lot of signal analysis, etc. But we have proved that it is quite possible to do that. So I am sitting there and there is no talking or gesture, nothing. Simple thinking, thoughts. And because anything that you think can be captured by using a Bluetooth enabled EEG headset, and it can be transferred to the drone understandable command and it can obey. And this is, Bangalore, typically you can see ambulance also getting stuck in traffic, and even if it is doing any much of sound, the upstream police cannot know about it. Suppose there is a drone on the ambulance which can be triggered, it can go alert the police and police can make way, and as the ambulance moves, this can come and perch on to the ambulance top. This is based on vision based navigation. And in agriculture, this is a very common scenario. There could be situations where there is no GPS available and obstacles are there, so obstacle avoidance is very, very important. And I will not go into these details about this. So this is a just a monocular camera. This is our IAC. For people who have seen IAC, you will appreciate there's a lot of forest area in there. So the drone, autonomous, nobody is controlling. There is only one monocular camera. Right side you see what kind of computation they are going. This is called the texture features or supervised learning based on texture learning. So it finds itself and goes. And we have developed one more algorithm which is based on the optical flow approach. We call it as the reinforcement learning. In fact, I should tell you, we conducted as our good friend indicated that one workshop just this Monday, ಕನ್ನಡದಲ್ಲಿ ಕೌಶಲ್ಯ ಕೃಷಿ ಅಂತ ಮಾಡಿದ್ವಿ. ಎಲ್ಲರೂ ಕನ್ನಡ ಬರುತ್ತಾ? ಕನ್ನಡದಲ್ಲೇ ಮಾಡಿದ್ವಿ. ಇದನ್ನೆಲ್ಲ ನಾನು ಕನ್ನಡದಲ್ಲೇ ಮಾತಾಡಿದೆ. ಕೃತಕ ಬುದ್ಧಿಮತ್ತೆ ಮತ್ತು ಈ ಲರ್ನಿಂಗ್, ಸೂಪರ್ವೈಡ್, ಅನ್ಸೂಪರ್ವೈಡ್, ರೀಇನ್ಫೋರ್ಸ್ ಲರ್ನಿಂಗ್, ಇದಕ್ಕೆಲ್ಲ ಕನ್ನಡದಲ್ಲಿ ಹೇಳಲಿಕ್ಕೆ ಸಾಧ್ಯ, ಸುಲಭವಾಗಿ ಅರ್ಥವಾಗುವಂತೆ ಹೇಳೋದಕ್ಕೆ ಸಾಧ್ಯ. ಅರ್ಥ ಆಗ್ಬಿಟ್ರೆ ನನ್ನ ಪ್ರತಿಭೆ ಕಮ್ಮಿ ಆಗ್ಬಿಡುತ್ತೆ ಅಂದ್ಬಿಟ್ಟು ಅರ್ಥ ಆಗದೆ ಇರೋ ಥರ ಹೇಳ್ತೀವಿ. ಅರ್ಥ ಆಗ್ಬಿಟ್ರೆ ಇದಿಷ್ಟೇನಾ ಅಂತ. ಮಾರ್ಗದರ್ಶಿತ ಕಲಿಕೆ, ಸೂಪರ್ವೈಡ್ ಲರ್ನಿಂಗ್. ಅಮಾರ್ಗದರ್ಶಿತ ಕಲಿಕೆ, ಅನ್ಸೂಪರ್ವೈಡ್ ಲರ್ನಿಂಗ್. ಪುನರ್ಬಲನೆ ಬಳಕೆ, ರೀಇನ್ಫೋರ್ಸ್ಮೆಂಟ್ ಲರ್ನಿಂಗ್. ರೀಇನ್ಫೋರ್ಸ್ಮೆಂಟ್ ಲರ್ನಿಂಗ್ ನಮ್ಮ ಹಳ್ಳಿ ಕಡೆ ಮೊದಲಿಂದಾನೇ ಇದೆ. ಹೆಂಗೆ ಗೊತ್ತಾ? ಹೇಳ್ಬಿಡ್ತಿತ್ತು ಅವಳೆ. ಹಳ್ಳಿ ಕಡೆ ಎತ್ತು ಕಟ್ತಾರೆ ಗೊತ್ತಾ? ಎತ್ತನ್ನು ನೊಗಾಕಿ ಎತ್ತಿನ ಗಾಡಿ ಕಟ್ತಾರೆ. ಅದಕ್ಕೊಂದು ಮುಹೂರ್ತ ಇಡ್ತಾರೆ ಹೊಸ ಎತ್ತು ಕಟ್ಟಬೇಕಾದ್ರೆ. ಆ ಎತ್ತು ಇಂದ ಒಗ್ಗಿರಲ್ಲ, ಅದು ಬರೋಲ್ಲ, ಎಳ್ಕೊಂಡು ಬರಬೇಕು, ಎಳ್ಕೊಂಡು ಕಟ್ಟಿ ನೊಗಕ್ಕೆ ಕಟ್ಟಬೇಕು, 2 ಚಾಟಿಲಿ ಬಿಗಿತಾರೆ. ಈ ಕಡೆ ಎತ್ತು ಸ್ವಲ್ಪ ಪಳಗಿರೋದು ಇಟ್ಟಿರ್ತಾರೆ, ಇದು ಟ್ರೈನಿಂಗ್ ಕೊಡೋಕ್ಕೆ ಅಂತ. ಆಮೇಲೆ ಏರಿ ಮೇಲೆ ನಡ್ಕೊಂಡು ಹೋಗ್ಬೇಕು. ಇದು ಎಲ್ಲೆಲ್ಲ ಎಳಿತಾ ಇರುತ್ತೆ. ಅವನ ಯಜಮಾನ ಬಿಗಿದು 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 ಇದು ಮಾಡ್ತಾನೆ, ಎಲ್ಲ ಬರುತ್ತೆ. ಬಂದು ಹಂಗೆ ಮನೆಯಿಂದ ಜಮೀನು ಕರ್ಕೊಂಡು ಹೋಗ್ತಾರೆ. ಇದು ಈ ಕಡೆ ಎಳಿತಾ ಇರುತ್ತೆ, ಬಿಡಲ್ಲ, ದೊಡ್ಡ ಸರಿ ಮಾಡ್ತಾನೆ. ಒಂದು 10-15 ದಿವಸ ಇದು ನಡೆಯುತ್ತೆ ಪ್ರಾಸೆಸ್. ಆಮೇಲೆ ಅದು ಕಲಿಯುತ್ತೆ. ಆಮೇಲೆ ಅಲ್ಲಿ ಕಟ್ಟಾಗಿ ಕೂತಿರ್ತಾನೆ, ಅಲ್ಲಿ ಕೂತಿರುತ್ತೆ ಹಸು ಎರಡೂ ಎತ್ತು. ಆಮೇಲೆ ಏನಿಲ್ಲ, ಒಂದು ತಿಂಗಳಾದಮೇಲೆ ಸುಮ್ಮನೆ ರೈತ ಬರ್ತಾನೆ ಅಂತಾನೆ, ಅಷ್ಟೇ ಬಂದು ಆಟೋಮೆಟಿಕಾಗಿ ನಿಂತ್ಕೊಂಡ್ಬಿಡುತ್ತೆ, ನಡಿ ಅಂತ ಹೋಗ್ಬಿಡುತ್ತೆ. ಇನ್ನು ಹಂಗೆ ಬಳಕೆ ಮಾಡಿ 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 ಏನಾಗ್ಬಿಡುತ್ತೆ, ಒಂದು ಸರ್ತಿ ಅಕಸ್ಮಾತ್ ಅವನೇನು ಜಮೀನಿನಿಂದ ಮನೆಗೆ ಏನಾದ್ರು ತೊಗೊಂಬರೋಕೆ ಕಳಿಸ್ಬೇಕಾದ್ರೆ ಸುಮ್ಮನೆ ಅಂತಾನೆ ಕಟ್ತಾನೆ. ಅವ್ನು ಕೂರದೇ ಇದ್ರೂ ಸೀದಾ ಮನೆಗೆ ಬಂದ್ಬಿಡುತ್ತೆ. ಯಾವ ಟೆಸ್ಲಾನೂ ಇಲ್ಲ, ಏನೂ ಇಲ್ಲ. ನಾವು ನೋಡಿದ್ದೀವಿ, ಅದು ನೋಡಿದ್ದೀರಾ ಹಳ್ಳಿ ಕಡೆ? ಯಾರೂ ಬೇಕಾಗಿಲ್ಲ, ಕಟ್ ಬಿಟ್ಬಿಟ್ರೆ ಆರಾಮ ಮನೆಗೆ ಬಂದುಬಿಟ್ಟು ಮುದ್ದೆಗಿದ್ದೆ ತಗೊಂಡು ವಾಪಸ್ ಬಂದ್ಬಿಡುತ್ತೆ. ಅಂದರೆ ಇದೆಲ್ಲ ಕನ್ನಡದಲ್ಲಿ ಸಾಧ್ಯ ಇದೆ ಅನ್ನೋದಕ್ಕಷ್ಟೇ. ಅದಕ್ಕೆ ಈ ಪ್ರಯತ್ನ ಸಾಕಷ್ಟು ಯಶಸ್ವಿ ಆಯಿತು. ಕಿಶೋರ್ ಅವರು ಇದ್ದರು ಸಾಕ್ಷಿಯಾಗಿ. ಅದೇಂಗೋ ನೀನು ಬಿಟ್ಟೋಗ್ಬಿಟ್ಟೆ ಮದುವೆಯ, ನಂಗೆ ಗೊತ್ತಾಗಲ್ಲ, ಈಗ ಅನ್ಕೋತಾ ಇದ್ದೀನಿ ನಾನು. ನಿನಗೆ ಹೇಳಿದ್ದೆ ಅನಿಸುತ್ತೆ ನಾನು. ಇರಲಿ. ಇದು ಕರೆಕ್ಟ್. ಇದು ಆಪ್ಟಿಕಲ್ ಫ್ಲೋ ಬೇಸ್ಡ್ ಅಲ್ಗಾರಿದಮ್. This also with just one camera, monocular camera, nothing else. One Android computing platform. Very simple algorithm. So even this can work very well. Amele, whenever you have pathways like this, it can be agricultural application, it can be military application. For example, they go to a forest where there is a pathway like this, but they don't know whether to proceed or not, because there could be some landmines, whatever. So now suppose you have a drone which can detect the pathways and go and send a feedback. You can put camera or some other sensors to give feedback to the ground control station. That will be. So we have developed this algorithm, and this is called as imitation learning. It's one of the part of the deep learning architectures. You can train in multivarious ways. I will not spend time on that. You can see the result. Of course, we have published all these things. You can get it. Because of all these algorithms, because of all these hard work of our students, yesterday I got a mail from GPS Scholar that I have been recognized as one of the top scholars in this area. Okay, so this can move like this. And of course, this is of importance. We did a work on monitoring the paddy health. This was done at Palakkad, Kerala. We did about more than 2,500 hectares. So we used a fixed wing UAV and a multispectral camera. You all know what is multispectral camera. This is RGB. Apart from the regular RGB, this is NIR and red edge. These two are extra. Using that information, lot of these parameters of the agriculture can be computed. We have not gone into so much of details except that we computed one thing called NDVI. So this is the study area, Palakkad. We do all these waypoint and flight plan, everything sitting in the lab. And then when you go there, you simply launch and it will execute and come. This is the autonomous navigation that we do. This is the RGB image and multispectral 5-band image that you get for a particular area. See, these are various things that you can compute. And what we have computed is only the normalized difference vegetation index, NDVI. That's what we did. And several other indices we have computed. I think agricultural experts can easily decode what each of these means. We just did for NDVI, and in one spot we saw that NDVI is 0.569. When it is NDVI is above 0.5, it is generally healthy, and if it is less than 0.5, it is unhealthy. And as you can see in this region, it is unhealthy, and the experts went there and verified that yes, it is unhealthy. So that proves that the algorithm. Then we also work on what is called a low altitude remote sensing. What you saw is that as opposed to high altitude remote sensing. High altitude in sense satellite images. In fact, we did start with satellite images. In fact, we have a lot of work on that. And we took tomato because, in India, this top, TOP, is important. Tomatoes, onions, potatoes. They are very important crops. And first we worked with neural network based approach, self-organizing feature map. Top right you will see the image from the drone, and then we did a lot of image processing and then classification, and you see the bottom right is the overlaid, the actual image and what we have found. They agree to a great extent, so we were able to do. But later we worked with deep learning where you can do the object detection. So the boxes you see are put from our algorithm, and the number of boxes is equal to number of tomatoes. Simple. Size of the box is proportional to the size of the tomato, and the RGB information is available. Therefore, you can, in principle, grade the tomato. So one can fly and grade the tomato, upload it onto a cloud, and any purchaser can know, okay, at this with this farmer, so much of tomato of this grade is available, and they can fix the price. And tomorrow a possibility is, because that of logistic drones we are working on, and the consumer can get it from a drone. 100 kg delivery drone can go there, collect 100 kgs and bring it, if it is implemented properly in spirit.
So how does the overlapping regions take care?
Oh yeah, we use what is called as Pix4D algorithm. We fly with the overlap of 70%. When we fly, that's how the path planning is done. Then there is a Pix4D software which will mosaic everything and give an image like this. We feed that image to our algorithm that will put the box and detect how many tomatoes are there. Pix4D is not open source. Unfortunately, it is expensive. In fact, we tried to, it's a good question, we tried to develop something like Pix4D, but we were not successful. That needs, I think, more intense, but now it is quite possible because, I have that, I'll show you one more because you asked this question, how ChatGPT can be effectively used. I'll show you towards the end, where you don't need extraordinary knowledge for doing all these things. You don't need to even know what this AI does, except that you should know what tool to use. In fact, ChatGPT, because we called our Vice Chancellor for our Monday program, Vice Chancellor Professor Suresha, when I went to invite him, he did suggest one problem about 15-20 days back. So I told our students, can you solve this? They did it, and just Monday I presented. I was wondering, earlier days, something it used to take at least 1 year to do that. Now in 10 days you can do. You should know what tool to use. That's it. So powerful. I think AI is something, I think you should organize one workshop AI for beginners, simply how to use. You don't need to know anything extraordinarily, and you can start using. It is a great use. Good. Thanks for bringing. I will show you that. There is in a different slide. Oh, I don't know whether that slide is here. Where you took it? I don't. Let me see. Yeah. Then we published in one leading journal. Then Deccan Herald published about us. This dialogue I have been saying everywhere. Now also I will say. Repeat. When Deccan Herald published this, one of the principal secretaries in Vidhan Soda called us. ಏನಪ್ಪ ಅವ್ರ ಹೆಸರು ನಿಮಗೆ ಗೊತ್ತು, ನಾನು ಹೇಳೋಣ. So they called us and 2 hours discussion. All the same present and everything. He said it is very, very interesting. Government needs this. We need to predict everything. Farmers are suffering. Where were you sitting all these days? Why did you not to come? How much money you want? Everything. And although I don't like coffee, 2 cups of coffee I had to drink with him. And we never met again. So you can also do, for example, what type of crops are there. You can fly a UAV. This is very easy classification. Of course, we have used several algorithms, including nature-inspired technique, neural networks, deep learning, everything. But now, if you have this image, in 10 minutes, ChatGPT can give better classification than this. It has become so simple. These are all some marketing slides, so bear with it. We got some award from Government of Karnataka, etc. And several people visited us. Kasturi Rangan visited us several times. Then this is Ahmedabad. Because of our image processing, I was awarded the Lifetime Award, Satish Dhawan Award for work in our image processing. Then on mangoes also we have done similar work, similar to whatever you saw in tomato. This is the proposed architecture. And this is all. One highlight of these, please look at second row, first and second column. In the second row, first column, you see a mango covered with a leaf. And you see the subsequent processing, the leaf is removed, mango is only picked up. So this is the advantage of these techniques. They will learn from the features, and even under camouflage, you can find out what the object is. So this is the thing. You can see the boxes put there, so you can detect that. Then once you do for one canopy, you can detect several canopies, and then you can generalize what is the likely yield. Okay. Then we have done for pomegranate farm. Pomegranate, as you know, is most pesticide prone crop. They put 50 different types of pesticides on this. So we went, we were honest, we had a good team, we sent them. The farmers were very nice in terms of allowing us to take photograph. They told us beforehand that please come, fly, we will also give you whatever food, etc. to eat, but don't suggest anything. We are not ready to listen. We have one one doctor here. Doctor means they call them as doctor. That doctor is not MBBS doctor, plant. He will give a list, what time, what pesticides to put. That's all. They simply, mercilessly put that. Nobody wants to listen. But anyway, we did our experiments, and you see, you can pick up beautifully, you can get all the features and to a very great accuracy, height and diameter, crop segmentation you can do. You can predict number of trees, total yield. You see, in terms of number of fruits, for this, for each tree while plucking, our students were there to note down, because we need to train the algorithm. And several things are possible, but we need to really, I'm not blaming the farming community. It is that the government, other interested people like you, all of us should work together. Then only some solution is possible. We cannot do anything independently, that's what I would love to say. So there is something that we need to, all of us have to wake up, because Specification is not necessary. As you can see, healthy crops 287. Vulnerable crops, you see, is only 23. What does that mean? Only 23 crops need to be pesticided. Other you don't have to, but they mercilessly do for everything. You can imagine on the cost and what is the pollution, and putting petrification, you may save from some bacteria or virus, I don't know, whatever it is, but you are still putting some chemical into it which we all consume. So this is the danger.
Sorry, since you have counted the number of roots and everything, what is accuracy?
Accuracy, yeah, I think I mentioned. It's very, very accurate, I think. Model accuracy 92%.
Can it also be used for counting the number of vehicles to be,
Oh yeah, easily.
it's done for such a complex?
We can do. Lot of things can be done. In fact, we have done, I think, I don't know whether that slide is also here, for human violence detection in mob. You can do using, if it is there, you will see that also. Although it is not something to do with agriculture. See, weeds can be automatically detected. You see, all these things, weeds, they are automatically picked up from the plantation. And now you can have a UGV, unmanned ground vehicle, uninhabited ground vehicle. That ground vehicle can go in all these places and clear it, automatize. So all this is possible, but we need to work a lot. Oh, I think you asked and it is there. This is about, we did a work on how using the drone image. Sorry, this is not related to agriculture. 15 minutes, okay. So this is what, because we saw recently in Bangalore, we could have found out, we could have studied the mob behavior. Cameras are already there. If there is an automatic way of knowing how many people are coming from where, what is the crowd density, etc., it could have alerted the law officers to stop much earlier than they converge. Very easy. In fact, we have done more sophisticated thing. For all these things, we can help. So we trained an algorithm. This is our airstrip, and all these students are our interns. In our lab, there are at least about 100 interns at any given point of time. So many people, they did a mock drill because we need to create a data set about what is violence, like kicking, hitting, snatching. We did a database, we studied all that. We were the first to create what is called as violence activity data set. Okay? And then we trained the algorithms. This is based on machine learning. First is the human detection. We have to see all the joints we have to detect and confirm that it is human. Because if two dogs are fighting, we cannot flag that it is violence. Let them fight. But we should not fight. And so that is the first thing. Then second step is pose estimation. This is the crux of the algorithm. How do you detect that this pose, what is the pose, whether they are engaged in kicking or hitting or snatching? Because if someone fellow is putting his arms on somebody's shoulders, it should not be flagged. Okay? So all that we have done. Then orientation. This is the crux of the thing. Then you have to classify it as violent or not. Lat long location of the camera is known. You can pick up and indicate, so law enforcers can take action. This is something. In fact, this gave us, we published this in a very leading internationally #1 conference on pattern recognition. And when we did that, lot of international magazines covered this on their front page. More than 50 scientific magazines covered this, and yeah, multiple things can be picked up. Multiple violence activities can be picked up, and BBC interviewed us for our work. No sound, no problem. Just asking. My photo will come, then I will proceed. Don't worry, sir. Next, 10 ನಿಮಿಷ ಆಯ್ತು ಅಷ್ಟೇ ಬಿಡಿ. Okay, so this is my student Dr. Amarjot Singh, who is now heading a company, and we did this work together at IASC. This is one of the unique work. And next we have also done one thing where disguised face identification. Even if you wear a mask, mustache, beard, even when the girl wears a mustache or a mask, beard, she can be detected. That is another, this is basically another machine learning technique that also was covered in BBC. That's what you see next. Okay, this is what we did, we could have used. Okay, so this is another thing, that's what we did on disguised face identification. So, see, we use 14-point marking system where we can develop this algorithm. So why I am showing this is, if we can pick up as subtle features as this, for agriculture you can do lot using image processing. So that is the potential. See, girl wearing a helmet and a beard and a mustache, still we could pick up who she is. So that is the power of these deep learning architectures. Okay. And for detection of flood victims, we have done, you can detect the flood. You can identify how many people are caught up where, on rooftop or in water, including the cattle or any other animal we could pick up, alert the rescue operators so they can mobilize how much of help is needed where, that can be done. Then road extraction you can do. Today a lot of road construction etc. is going on. We can do the road extraction and do. We have done things on power line monitoring. In fact, we have applied for a patent on this. You can track the power line using a drone, because power lines goes in all hills and valleys. You can just leave a drone, it will simply follow it, go with a thermal camera and indicate the hot spots, so that maintenance becomes easier. So don't worry about this. We are able to pick up all the power lines there. You can see the result here. So all the power lines we are able to pick up. So the drone can go trace for kilometer after kilometers depending upon its endurance and report. So we do go to a lot of places to explain kids. In fact, we have a lot of visitors to our lab. We encourage students to come and see, learn, get encouraged. We do that quite often. So this is something even agriculture you can use, a fixed wing. Why struggle with rotary wing? This is just made out of foam. You can assemble in less than 42 seconds. Weighs only 1.4 kg. Easy to launch. You can see how easily it will be launched. You can put a camera and get the information. And because it is 1.4 kg, even if it falls down, there is no big danger, because its kinetic energy is very, very less. And it glides well. You see how easily it goes. And in fact, we have made much lighter aircraft, but that is technically it is difficult. That is the all composite. This is 800 grams only, including, you see how the launching, you see, jet, if you leave it will go, so light, but very strong. But this has lot of carbon filaments, etc., expensive. The previous one is hardly about 5,000 rupees, not much. That's all. A drone would cost you much, much more than that, a quadcopter. But this is where you want to explore, that's easier. Then in agricultural ground, there is no huge land. It can take off vertically and go. Then this is another thing that we have done. It can simply take off vertically and then descend vertically. This is a drone of the future. It can take off vertically up, go, scan any area, then come back, vertically descend. This is quadcopter plus fixed wing. That's all, simple. Easy to use, easy to fly, easy to control. Of course, a lot of variants of this have come now in the market, and most of these drones have a lot of limitations in terms of endurance. So next idea we were thought was, if you can send the power from the ground, either for generator or AC power, you can fly the drone for 24 hours, 48 hours, and you can fly it at a height of about 400 meter with a 360-degree camera, and you can monitor large area. It is like a mini satellite. So we tried that. That is called the tethered drone. So next one is I am going to show you that. Okay, this will go forward and then land, and this is called tethered drone, and is very useful in monitoring any critical area also, even agriculture lands. A lot of today we see that lot of elephants come, monkeys come, donkeys come, etc. You can monitor and take action. A drone can be flying at 400 meters high, and it can fly for more than 24 hours. We have tested. This is our airspace quadrangle, where our students have tested throughout, in and through the night. They have sat and continuously ran it for 24 hours. Then no problem, it can take. And you can run a fiber optic cable and get the video feedback onto your ground control station. All that is possible. So this is something you can take off from water and land on water. Fisheries, etc. This can be of great use. Even water pollution monitoring, this can be of great use. So here you see we have the side hulls. They have to be aerodynamically and hydrodynamically designed, glides smoothly, lands. And for ISRO we have developed one more similar thing for Northeastern Space Application Center. So this one is slightly different, because here we have modified the fuselage itself as a floating hull, and two side floaters are there. This is a lake in the Mogdi, and it can take off smoothly.
This must have involved a lot of modeling, simulation.
Oh yeah, definitely, yeah. This is both hydrodynamic and aerodynamic. We do a lot of CFD simulations and also X-foil simulations to both aerodynamically and hydrodynamically, and see how smoothly it takes off. So that is possible only if you have proper design. And then for agricultural drones, today one of the serious problems with agricultural drones is there is a lot of lacuna in training the pilots, because of which lot of drones are getting crashed, especially whatever is done through government schemes. We hear lot of accidents because they don't know how to control it. Will go and hit something, finished. So we did, our next talk is about that, how to sense and avoid. So we have used the 360-degree radar, and it can avoid. So that also we have filed a patent. And after this lands, I'll show you. So these are a lot of uses. You can put a lot of sensors for water pollution monitoring, or in fisheries also, if you want to. In ಇದು ಮಾಗಡಿ ಕೆರೆ. Very smooth it lands. That's it. So sense and avoid for agri drones, we have used this omnidirectional radar. We have done a lot of training based on machine learning, and this is what it is. There's a video. You can see when it goes to that obstacle, that blue wall, even if it gives the pitch input, it will not go. So which means you cannot crash this. So this we have filed for a patent. See, braking target, when drone is 2 meters away from obstacle, despite giving forward pitch input. If you give forward pitch, it should go forward, but it won't. You can see that it will stop. So So this is very, very useful. It can save the drone, which is about 5 lakhs. And it is 360 degree. In any direction it will help. Well, this, I don't know, I'll let it go. This is about radiation monitoring. We did long back, is self-explanatory. If there is radiation explosion, you see, human cannot go. We can put a radiation measuring equipment called Giger-Muller counter, and UAV can happily do that. We have proved this technology, and we have to test it. We have to go to Chavra coast, Kerala, because there the natural radiation level is 12 times higher than Bangalore. So this is our aerospace department. So our team has to go to Kerala. We did that. We first mounted it on a quadcopter because it is easy to measure, control, etc. So mounting is very, very important mechanically, because this Giger-Muller counter, see that glass tube, very critical. Any impact it will break. So mechanical mounting is very, very crucial in doing this. And we have to verify whether the readings are reliable. So what we had done is we had measured at Bangalore, and we knew theoretically that there it is 12 times higher. So we plotted it. I'll show you the plot. See, this is bottom line is Bangalore, 12 times higher is Chavra coast. So then we mounted it on a fixed wing, and we do what is called as bungi launch, because there it is all sand, seashore. So that is the elastic tube through which we mount, and this is also very specifically designed for slow flight, because you need to collect data. Now you can survey the whole area like that. Flight plan, everything is done. This waypoint navigation is accomplished. It will do, and then come back. Then when it comes back, it has to do what is called as belly landing with minimal impact. That is what it does, because equipment has to be saved. So that's it. So it will smoothly land, and it will give all the readings, lat long locations, and the radiation values. You can put, this is onboard video, how it looks. See the water all around from the onboard video, and you get the distribution of the radiation level as shown in the figure. Well, all experimentalists will know that sometimes things can go bad. That's how we learn. So in one of the, I think, third or fourth trial, they launched the vehicle, it went missing. Communication was lost. And all around it is sea, so we thought it has got drowned in the sea. And it costed about 8 lakhs. Losing 8 lakhs for academic institute is big. So this is after recovery, it is showing. I'll show you the onboard camera and later what happened, because Kerala is supposed to be land of gods. So God smiled on us. See onboard, see, we thought it went to water, but it has hit the Kerala's favorite tree, coconut tree. And there was one savior. This was about 11 kilometers away from where we launched. And this fellow picked up, and he didn't know what it is. He did his own test and carried it on his cycle. And our students had to search throughout night for about 7 hours. Locals, WhatsApp, everything helped. Police also helped, and we could get this intact. Nothing happened.
This is from the video, is it? You could recognize.
Yeah, there is the camera is still recording, that fellow doesn't know. Yeah, so then we got it. So this is one of the successful projects. Yes. Oh, this I'll skip, this is all composite vehicle. And we can do for road accidents also, it can help. Because in India, even today, the statistics is that on roads, every day 400 people die. And in that, 13-14 people died because improper shifting. What is improper shifting? If the blood is oozing out also, they don't know, they'll simply put it. if the drone can detect where the blood is oozing, and if it can drop one anti-blood clotting tape, which somebody can simply put it, they can be saved. And seed dropping, conventional way is this. They do a lot of these things. And even after planting, today a lot of people claim that we have planted 5 lakhs, 10 lakhs, 20 lakhs. We don't know how many. Nobody will go and count. What is the effect on the ecology also we don't know. Suppose if we do it, the drone is going to drop, and every 6 months you follow the same path and record the video and then get the impact on ecology, it would be good. That's when myself and my colleague Professor K.B.J. Reddy long back decided we will use the drones to do seed dropping. We did it on Gauri Bidnoor, and we were the first to do this in the world. We deserve. You have to clap. So this is what we did in Gauri Bidnoor. So we built a huge bird. It can carry 10 kg seed. Main road was blocked because we knew the local MLA. They stopped all the buses, everything. So we have designed all dropping mechanism, and we can see from the camera which area we have to drop, and there the pilot has to simply press a trigger, it will open and drop. The drop mechanism I have not included here, but it is possible. We represent quite strongly in all Aero Indias. In the Innovate India we are there. I think other things are there. Let me not go into all these things because I may be again invited to talk and some common people will be there. Let me save some PPTs for future. Okay, then I think our good friend asked one question. Let me see something.
Your PPT, sir.
Huh?
This is your PPT from that day.
Is there? Put.
Is this this one, sir? Which slide is it?
Correct. You put it, we will run through that Kannada quickly to tell them that Kannada is very good. I think he has, so I'll show you. You go to number 1 slide itself. ನೀನು 5 ನಿಮಿಷ ತೊಗೊಂಡ್ಬಿಡ್ತೀನಿ. ಇದೇನಪ್ಪ ಅಂದರೆ ಊಟ ಹಾಕಲ್ವೇನಪ್ಪ? ಹೌದಾ? ನಾ ಮನೆ ಡಬ್ಬ ಬೇರೆ ತರಲಿಲ್ಲ ರೀ. ನೋಡಿ, ಎಲ್ಲವನ್ನ ಕನ್ನಡದಲ್ಲಿ ಹೇಳಲಿಕ್ಕೆ ಸಾಧ್ಯ ಅನ್ನೋದಕ್ಕೆ ಮೊನ್ನೆ ಪ್ರಯತ್ನ ಪಟ್ವಿ ನಾವು. ಮಾನವರಹಿತ ವಿಮಾನ ಮತ್ತು ಕೃತಕ ಬುದ್ಧಿಮತ್ತೆ. ಬಿಕಾಸ್ ಇದು ಬಿಡಿ, ನಮ್ಮ ಭಾರತೀಯ ವಿಜ್ಞಾನ ಮಂದಿರ ಸ್ಥಾಪನೆಗೆ ಇವರು 3 ಕನ್ನಡಿಗರು ಕಾರಣ ಅಂತ ಹೇಳೋದಕ್ಕೆ. ಯಾರ್ಯಾರು ಒಂದು ಗೊತ್ತಾ? ಕರೆಕ್ಟ್, ನಾಲ್ವಡಿ ಕೃಷ್ಣರಾಜ ಒಡೆಯರು, ವಿಶ್ವೇಶ್ವರಯ್ಯ, ಮಧ್ಯ ಮಹಾರಾಣಿ. ಕರೆಕ್ಟ್. ಇದು ಬಿಡಿ, ಇದೆಲ್ಲ ಬಿಡಿ. ನೋಡಿ, ಇದು ತಿರುಗು ತಳ್ಳುಕ ಮಾನವರಹಿತ ವಿಮಾನ. ಗೊತ್ತಾಯ್ತಾ ಏನು ಅಂತ? ಕ್ವಾಡ್ಕಾಪ್ಟರ್ ಆರ್ ಎನಿ ಎಕ್ಸಾಕಾಪ್ಟರ್ ವಾಟ್ ಎವರ್. ತಳ್ಳುಕ ಅಂದರೆ ಪ್ರೊಪೆಲ್ಲರ್, ತಿರುಗಿ ತಳ್ಳುಕ, ಪ್ರೊಪೆಲ್ಲಿಂಗ್ ಮೆಕ್ಯಾನಿಸಮಿಂದಾನೇ ಹೋಗೋದು ಅಂತ. ಸ್ಥಿರರಕ್ಕೆ ಮಾನವರಹಿತ ವಿಮಾನ. ಮತ್ತು ಎಲ್ಲವನ್ನ ಮಾಡಲಿಕ್ಕೆ ಸಾಧ್ಯ. ಚೌಕಟ್ಟು, ಫ್ರೇಮ್, ವಿದ್ಯುತ್ ಸಂಗ್ರಹ ಸಾಧನ, ಬ್ಯಾಟ್ರಿ, ದೂರಸ್ಥ ಗ್ರಾಹಕ, ಏನೋ ರಿಸೀವರ್, ದೂರಸ್ಥ ಪ್ರಸಾರಕ, ಟ್ರಾನ್ಸ್ಮಿಟರ್, ಚಾಲನ ಯಂತ್ರ, ಮೋಟಾರ್, ಶಕ್ತಿ ವಿತರಣಾ ಹಲಗೆ, ಪವರ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಬೋರ್ಡ್, ಹಾರಾಟ ನಿಯಂತ್ರಕ, ಫ್ಲೈಟ್ ಕಂಟ್ರೋಲರ್, ವಿದ್ಯುನ್ಮಾನ ವೇಗ ನಿಯಂತ್ರಕ, ESC ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಸ್ಪೀಡ್ ಕಂಟ್ರೋಲರ್, ಛಾಯಾಚಿತ್ರ ಸಾಧನ, ಕ್ಯಾಮ್ರಾ. ಆಯಿತಾ? ಎಲ್ಲವನ್ನು ಕನ್ನಡದಲ್ಲಿ ಹೇಳಲಿಕ್ಕೆ ಸಾಧ್ಯ. ಇದೆಲ್ಲ ಆಗಿದೆ. ಇದು ಎಲ್ಲ ಬೇಡ. ನೋಡಿ, ಯಂತ್ರ ಕಲಿಕೆ, ಮಿಷಿನ್ ಲರ್ನಿಂಗ್, ಇದರಲ್ಲಿ ಏನೇನು ವಿಚಾರಗಳು ನೋಡಿ. ಮಾರ್ಗದರ್ಶಿತ ಕಲಿಕೆ, ಅಮಾರ್ಗದರ್ಶಿತ ಕಲಿಕೆ, ಪುನರ್ಬಲನ ಕಲಿಕೆ, ಎಲ್ಲವನ್ನ ಹೇಳ್ಬೋದು ಕನ್ನಡದಲ್ಲಿ ಆರಾಮಾಗಿ. ಇದೆಲ್ಲ ಏನು ಅಂತ ಈಗ ಸದ್ಯಕ್ಕೆ ಪಾಪ ಸಾಕಷ್ಟು ಸಮಯ ಕೊಟ್ಬಿಟ್ಟಿದ್ದೀರಾ, ಬೇಡ ಇನ್ನು ನೋಡಿ. ಇದು ಏನೇನಕ್ಕೆ ಬಳಸ್ಬೋದು ಅಂತಲೂ ಅಲ್ಲೇ ಹೇಳಿದ್ವಿ. ಮತ್ತು ಪುನರ್ಬಲನ ಬಳಕೆ ಅಂದರೆ ರೀಇನ್ಫೋರ್ಸ್ಮೆಂಟ್ ಲರ್ನಿಂಗ್, ಇದಕ್ಕೆ ಈ ಉದಾಹರಣೆ ಕೊಟ್ಟಿದ್ದು ನಾನು. ಈ ಟೆಸ್ಲಾ ಅಂತಿರಲ್ಲ, ಅವೆಲ್ಲ ನಮ್ಮಲ್ಲಿ ಇತ್ತು ನೋಡಿ ನೋಡಿ ನೋಡಿ, ಆರಾಮ ಹೋಗ್ತಾ ಇರುತ್ತೆ. ಅದಕ್ಕೆ ಸ್ವಾಯತ್ತ ಎತ್ತಿನ ಬಂಡಿ ಅಂತೇಳಿ, ಆಟೋನಮಸ್ ಬುಲ್ ಕಾರ್ಟ್. ಆಳ ಕಲಿಕೆ ಡೀಪ್ ಲರ್ನಿಂಗ್, ಆಯಿತಾ? ಇದು ಆಯಿತು, ಇದು ಆಯಿತು, ಇದೆಲ್ಲ ಬಿಡ್ಬೋಣ. ಇದು ಒಂದು ಏನಕ್ಕೆ ತಂದೆ ಅಂದರೆ ನೋಡಿ, NDVI ಸಾಮಾನ್ಯೀಕರಿಸಿದ ವ್ಯತ್ಯಾಸ ಸಸ್ಯ ಸೂಚಂಕ ನಕ್ಷೆ. ಇದೆಲ್ಲ ಅಲ್ಲಿದೆ. ಇದು ನೀವು ಕೇಳಿದ್ರಲ್ಲ, ಇದನ್ನು ನೋಡಿ ನಾವು 10 ಡೇಸಲ್ಲಿ ಮಾಡಿದ್ವಿ ಕೌಶಲ್ಯ ವೃದ್ಧಿ. ನೋಡಿ, ಸ್ಯಾಟಲೈಟ್ ಇಮೇಜ್ ಉಪಯೋಗಿಸ್ಕೊಂಡು ಟೊಮೊಟೊದು ನೋಡೋಕ್ಕಾಗತ್ತಾ ಅಂತ ಅವ್ರು ಕೇಳಿದರು. ಟೊಮೊಟೊ ಎಷ್ಟೆಷ್ಟು ಎಲ್ಲೆಲ್ಲಿ ಬೆಳೀತಾ ಇದ್ದಾರೆ, ಕ್ಯಾನ್ ಯು ಗೆಟ್ ಕ್ವಿಕ್ಲಿ ಅಂತ ನೋಡಿ ಸಾಧ್ಯ. ಇಟ್ಕೊಂಡು ಎಲ್ಲವನ್ನು ಬೆಳವಣಿಗೆ ಹಂತ ಯಾವ ಹಂತದಲ್ಲಿದೆ ಟೊಮೊಟೊ. ಇದೇನಪ್ಪ ಅಂದರೆ ನಾವು ನೋಡಿ, ದೃಶ್ಯ ಭಾಷಾ ಮಾದರಿ, ವಿಜುವಲ್ ಲಾರ್ಜ್ ಲ್ಯಾಂಗ್ವೇಜ್ ಮಾಡೆಲ್ಸ್, ಅದನ್ನು ಬಳಸಿ ಮಾಡಬೇಕು. ಭಾಳ ಸುಲಭವಾಗಿ ಮಾಡ್ಬೋದು ಅನ್ನೋದಕ್ಕೆ ಇದೊಂದು ಉದಾಹರಣೆ ಅಷ್ಟೆ. ಮಾನವಿ ಮತ್ತು ಕ್ರಬು ಅಂದ್ರೆ ಗೊತ್ತಾಯ್ತಲ್ಲ ಈಗ. ಮಾನವರಹಿತ ವಿಮಾನ. UAV ಅಂದರೆ ಗೊತ್ತಾಗ್ಬಿಡ್ತದೆ, ಮಾನವಿ ಅಂದ್ರೆ ಗೊತ್ತಾಗಬೇಕು. ಕ್ರಬು ಅಂದರೆ ಕೃತಕ ಬುದ್ಧಿಮತ್ತೆ. ನಾವು ಬಳಸಲ್ಲ ಅಷ್ಟೆ, ಬಳಸಿದ್ರೆ ಎಲ್ಲರಿಗೂ ಬಳಕೆಗೆ ಬಂದ್ಬಿಡುತ್ತೆ. ಜೈ ಭಾರತ್, ಜೈ ಕಿಸಾನ್, ಜೈ ವಿಜ್ಞಾನ. ಏನೇ ನಮಸ್ತೆ. ಯಾವ ಪ್ರಶ್ನೆಗಳಿದ್ರೆ ಏನಪ್ಪ? ಬೇಕಾಷ್ಟು ಅಪ್ಲಿಕೇಶನ್ಸ್ ಇದೆ ರೀ.
ಒಂದೇ ಸಲ ಮಾರ್ಕೆಟ್ ಗ್ಲಟ್ ಆಗುತ್ತೆ ಸರ್. ಎಲ್ಲ ಫಾರ್ಮರ್ಸ್ ಏನು ಮಾಡ್ತಾರೆ, ಒಂದೇ ಬೆಳೆ, ಈಗ ಸಪೋಸ್ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಹೇಳ್ಬೇಕಂದ್ರೆ ಟೊಮೊಟೊ,
ಹೌದು,
ಹಾಕಿದ್ರೆ ಟೊಮೊಟೊ ರೇಟ್ ಇದ್ರೆ ಅದನ್ನೇ ಹಾಕ್ಬಿಡ್ತಾರೆ.
ಅದಕ್ಕೆ ನಾವು ತೋರಿಸಿದ ರಿಸಲ್ಟು ಇದನ್ನೇ ನಾವು ವೈಸ್ ಚಾನ್ಸಲರ್ ಜೊತೆ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ದಾಗ ಬಂತಿದ್ದು.
ಸರ್,
ನೀವು ಟೊಮೊಟೊ ಎಲ್ಲಿ ಬೆಳೆದಿದೆ ಏನು ಅಂತ ಗ್ರೇಡ್ ಮಾಡೋದು ಒಂದು ಓಕೆ, ಬಟ್ ಎಷ್ಟು ಬೆಳೀತಾ ಇದ್ದಾರೆ ಈಗ ಅದಕ್ಕೆ ನಾವು ಯಾವ ಸ್ಟೇಜಲ್ಲಿ ಕ್ರಾಪ್ ಎಲ್ಲೆಲ್ಲಿ ಹಾಕಿದ್ದಾರೆ ಇಮ್ಮಿಡಿಯೇಟ್ಲಿ ಥ್ರೂ ಸೆಂಟಿನಲ್ ಸ್ಯಾಟಲೈಟ್ ಯಾಕೆ ಅಂತ ಹೇಳಿದ್ರೆ ಪುಕ್ಕಟೆ ಸಿಗುತ್ತೆ, ನ್ಯಾಯ ಪೈಸಾ ಖರ್ಚಿಲ್ಲ. ಎವ್ರಿ ವೀಕ್ ಅಪ್ಡೇಟ್ ಕೊಡ್ತಾರೆ. ಆ್ಯಂಡ್ ನೀವು ನಿಮ್ಮ ಏರಿಯಾ ಲ್ಯಾಟ್ಲೈನ್ ಕೊಟ್ಬಿಟ್ರೆ ಕರೆಕ್ಟಾಗಿ ತೆಕ್ಕೊಟ್ಬಿಡುತ್ತೆ. ಅದನ್ನು ತೊಗೊಂಡು ನೀವು ChatGPT ಹಾಕ್ಬಿಟ್ರೆ ಯಾವ್ಯಾವ ಥರ ಬೆಳೆ ಇದೆ ಕೊಟ್ಬಿಡುತ್ತೆ. ಅಷ್ಟು ಸುಲಭ.
ಸೊ ಅದನ್ನು ನೋಡ್ಕೊಂಡು ಕ್ರಾಪಿಂಗ್ ಪ್ಯಾಟರ್ನ್
ನೋಡ್ಕೊಂಡು ನೀವು ತೀರ್ಮಾನ ಮಾಡ್ಬೋದು. ಈಗಾಗಲೇ ನೋಡಪ್ಪ 50 ಎಕರೆಯಲ್ಲಿ ಹಾಕ್ಬಿಟ್ಟಿದ್ದಾರೆ ಟೊಮೊಟೊ, ಡಿಮ್ಯಾಂಡ್ ಇರೋದೇ 50 ಎಕರೆಗೆ, ನೀನು ಬೆಳೆದ್ರೆ ನಿನಗೂ ಬೆಲೆ ಸಿಗಲ್ಲ, ಅವನಿಗೂ ಸಿಗಲ್ಲ ಅಂತ ಹೇಳ್ಬಿಡು. ಅಷ್ಟೇ ಅಲ್ಲ, ಬೇರೆ ಇನ್ಯಾವ ತರಕಾರಿ ಏನು ಕೋಸು ಹಾಕ್ಬೋದೋ, ಎಲೆಕೋಸು ಹಾಕ್ಬೋದು, ಅದನ್ನೂ ಅವ್ರಿಗೆ ಹೇಳಲಿಕ್ಕೆ ಸಾಧ್ಯ.
ಅಲ್ಲಿ ಇನ್ನೊಂದು ಹೇಳಿದ್ರಿ ಸರ್, ಅದು ಪೆಸ್ಟ್ ಆ್ಯಂಡ್ ಡಿಸೀಸ್ದು ಮತ್ತು ಕ್ವಾಲಿಟಿ ಹೆಂಗಿದೆ ಅಂತ ಡಿಸೈಡ್ ಮಾಡ್ಬೋದು ಅಂತ. ಅದು ತುಂಬ ಯೂಸ್ಫುಲ್ ಆಗುತ್ತೆ ಸರ್. ಅದು ಎಸ್ಪೆಷಲಿ ಪೆಸ್ಟಿಸೈಡ್ಸ್ ಯೂಸೇಜು ಕಡಿಮೆ ಆಗುತ್ತೆ.
ಹೌದು ಹೌದು. ಇದು ಏನಾಗ್ಬಿಟ್ಟಿದೆ, ಒಂದು ಸಾಂಪ್ರದಾಯಿಕ ಪದ್ಧತಿ ಏನು ಬೆಳೆದ್ಬಿಟ್ಟಿದೆ, ಅದರಿಂದ ಹೊರಗೆ ಬರಲಿಕ್ಕೆ ಅಷ್ಟು ಸುಲಭವಾಗಿ ಒಪ್ಪಲ್ಲ. ಸಹಜ, ತಪ್ಪು ಅಂತ ಹೇಳಲ್ಲ ನಾನು. ಅದಕ್ಕೇನಂತ ಹೇಳಿದ್ರೆ ಎಲ್ಲರೂ ಸೇರಬೇಕು, ಎಲ್ಲರೂ ಸೇರಿ ಎಲ್ಲರೂ ಇದನ್ನು ಮಾತಾಡ್ತಾ ಹೋದ್ರು, ಇದು ಸಾಧ್ಯತೆ ಇದೆ ರೀ, ಇದರಿಂದ ಒಳ್ಳೆಯದಾಗುತ್ತೆ ಅನ್ನೋದು ಬಂದರೆ ಕ್ರಮೇಣ ನಿಧಾನಕ್ಕೆ ಬದಲಾವಣೆ ಬರುತ್ತೆ. ಸ್ವಲ್ಪ ಸಮಯ ಬೇಕು. ಅದಕ್ಕೆ ಎಲ್ಲ ರೀತಿಯ ಇಂಜಿನಿಯರ್ಸು, ಈ ವ್ಯವಸಾಯದಲ್ಲಿರ್ತಕ್ಕಂಥವ್ರು, ಅಗ್ರಿಕಲ್ಚರಲಿಸ್ಟು ಎಲ್ಲರೂ ಬರಬೇಕು ಒಟ್ಟಿಗೆ.
ಸರ್, ಇನ್ನೊಂದು ಸರ್, ಈಗ ನಮ್ಮಲ್ಲಿ ಎಸ್ಪೆಷಲಿ ನಾವು ಹಾರ್ಟಿಕಲ್ಚರ್ ಡಿಪಾರ್ಟ್ಮೆಂಟಿಂದ ಸರ್, ನಮಗೇನೆಂದರೆ ಒಂದು ಈಗ ಎಸ್ಪೆಷಲಿ ಅರಕನಟ್ಟು ಮತ್ತು ಕೋಕೋನಟ್ ಅದೇನೆಂದರೆ 30 to 40 feet ಲೆಂತ್ ಹೋಗುತ್ತೆ ಸರ್. ಅದರಲ್ಲಿ ಸ್ವಲ್ಪ ಏರ್ ಡ್ರಿಫ್ಟ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ ಅಂತಾರಲ್ಲ, ಅಂಥ ಕಡೆ ಹೆಂಗೆ ಯೂಸ್ ಮಾಡ್ಬೋದು ಸರ್?
ನಾವು ಈಗ ಇದು ಮಾಡಿದ್ದೀವಲ್ಲ, ಅದು ನಾನು ತರಲಿಲ್ಲ. ಈಗ ಒಂದು ಇಷ್ಟು ಎತ್ತರ ಇರುತ್ತೆ, ಇನ್ನೊಂದು ಇಷ್ಟು ಎತ್ತರ ಇರುತ್ತೆ. ಹಿಂಗೆ ಟೆರೈನ್ ಫಾಲೋಯಿಂಗ್ ಅಲ್ಗಾರಿದಮ್ ಡೆವಲಪ್ ಮಾಡಿದ್ದೀವಿ ಒಂದು. ಇನ್ನೊಂದು ಅರ್ಕಾನಟ್ಗೆ ಕೆಳಗಡೆಯಿಂದಾನು ಯು ಕ್ಯಾನ್ ಪೆಸ್ಟಿಫಿಕೇಶನ್ ಮಾಡ್ಬೋದು.
ಕೆಳಗಡೆಯಿಂದ ಮಾಡ್ಬೋದು ಸರ್?
ಮಾಡ್ಬೋದು.
ಡ್ರೋನ್ಸ್ ಇದೆಯಾ ಸರ್?
ವಾಯಸ್
ಯಾಕೆಂದರೆ ನಮ್ಗೆ ಏನಾಗುತ್ತೆ ಅಂದರೆ ಸರ್
ಡ್ರೋನ್ಸ್ ಒಂದೇ ನೋಡಿ, ಇದಕ್ಕೆ ಯಾವ ಡ್ರೋನ್ಸ್ ಒಂದೇ ಸೊಲ್ಯೂಷನ್ ಅಂತ ನೋಡಬಾರ್ದು.
ಓಕೆ ಸರ್,
ಸಮಸ್ಯೆ ಏನು ಅಂತ ಹೇಳಿದ್ರೆ ಪರಿಹಾರ ಕೊಡ್ಬೋದು
ಸರ್. ಈಗ ಅದಕ್ಕೆ ನಾವು ಕೇಳ್ತಾರೆ ಸರ್, ಈಗ ಇತ್ತೀಚೆಗೆ ಏನಾಗಿದೆ ಅಂದರೆ ಕೋಕೋನಟಲ್ಲಿ ವೈಟ್ ಫ್ಲೈಸ್ ಅಂತ ಒಂದು ಪೆಸ್ಟ್ ಇದೆ ಸರ್. ಅದು ಏನು ಮಾಡುತ್ತೆ ಅಂದರೆ ಎಲೆ ತಳಭಾಗದಲ್ಲೇ ಅದು ಅಟ್ಯಾಕ್ ಮಾಡುತ್ತೆ.
ಹೌದು
ಹೌದು ಸರ್. ಈಗ ನಾವೇನಂದ್ರೆ ನಾವು ಡ್ರೋನ್ಸ್ ಅಂದರೆ ಏನಂದರೆ ಮೇಲಿಂದ ಮಾತ್ರ ಸ್ಪ್ರೇ ಆಗುತ್ತೆ ಅಂತ
ಪ್ರಯೋಜನಕ್ಕೆ ಬರಲ್ಲ.
ಸೊ ಅದಕ್ಕೆ
ಬೇರೆ ಬೇರೆ ಥರದ್ದಿದೆ. ಈಗ ನಾವೇನು ಮಾಡಿದ್ದೀವಿ, ಒಂದು ಡ್ರೋನ್ ಡೆವಲಪ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಎಂಥ ಡ್ರೋನ್ ಅಂದರೆ ಅದು ಫಾರ್ ಪೇಂಟಿಂಗ್ ವಿತ್ ಸ್ಪೆಷಲ್ ನಾಸಲ್ಸ್. ಇಟ್ ಕ್ಯಾನ್ ಪೇಂಟ್ ದಿ ವಾಲ್. ಎಲ್ಲ ಕಡೆ ಎಲ್ಲ ಮೂಲೆನೂ ಪೇಂಟ್ ಹೊಡಿದೆ. ಆ ಥರ ಮಾಡ್ತಾ ಇರೋದ್ರಿಂದ ಇದು ಏನು ಕಷ್ಟ ಏನಿಲ್ಲ. ದೇ ವಿಲ್ ಡೆವಲಪ್ ಒನ್ ಮೋರ್ ಆರ್ಮ್ ಆ್ಯಂಡ್ ಪೆಸ್ಟಿಫೈಯಿಂಗ್. ಇಟ್ ಈಸ್ ಕ್ವೈಟ್ ಪಾಸಿಬಲ್. ಮತ್ತು ಈ ಸೆನ್ಸ್ ಆ್ಯಂಡ್ ಅವಾಯ್ಡ್, ಯಾವುದೇ ಮರಕ್ಕೆ ಡಿಕ್ಕಿ ಹೊಡೆದು ಬಿಡಲ್ಲ. ಈ ಸೆನ್ಸ್ ಆ್ಯಂಡ್ ಅವಾಯ್ಡ್ ಎಲ್ಲ ಇದ್ದರೆ, ಹಾಗಾಗಿ ಇದು ಖಂಡಿತ ಸಾಧ್ಯ. ಮತ್ತು ಬಳಸೋದು ಕಲಿಬೇಕು. ಇವತ್ತು ಇದು ಯಾವ ಮಟ್ಟಕ್ಕೆ ಬಂದಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಈ ChatGPT, ಡೀಪ್ ಸೀಕ್, ನಮ್ಮಲ್ಲಿ ಏನೋ ಕೆಲವರಲ್ಲಿ ಯಾರಿಗೆ ಅದು ಮುಖ್ಯವೋ, ಇದು ಯಾತಕ್ಕೆ ತುಂಬ ಬಳಕೆ ಯಾತಕ್ಕೆ ಆಗ್ತಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ, ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ ಅಲ್ಲಿ ಕ್ವಶನ್ ಏನೋ ಅಸೈನ್ಮೆಂಟು ಅದು ಇದು ಕೊಟ್ಟರೆ, ಪ್ರಾಜೆಕ್ಟ್ ವರ್ಕು ಕೊಟ್ಟರೆ 2 ನಿಮಿಷಕ್ಕೆ ಟಕ್ಕಂದು ಕೊಟ್ಟು ಹೊಡೆದು ಪ್ರಿಂಟೌಟ್ ತೆಗೆದು ಕೊಟ್ಬಿಡ್ತಾರೆ. ಅದು ಓದೂ ಇರಲ್ಲ ಅವರು. ಆ ಮಟ್ಟಕ್ಕೆ ಬಂದಿದೆ. ಆದರೆ ಯಾರು ನಿಜವಾದ ನಿಮ್ಮಂಥ ವ್ಯವಸಾಯಸ್ಥರು ಇವರೆಲ್ಲ ಬಳಸ್ಬೋದು. ಭಾಳ ಸುಲಭ ಇದೆ ಇದು. ಅದಕ್ಕೆ ಇವರು ಈ KSTN ಅವರು ಒಂದು ಎಲ್ಲ ಹೇಳಬೇಕು, ಇದ್ರದ್ದು ಒಂದು ವರ್ಕ್ಶಾಪ್ ಆರ್ಗನೈಸ್ ಮಾಡಬೇಕು. ಹೇಗೆ ಎಲ್ಲರೂ ಬಳಸ್ಬೋದು, ಸುಲಭವಾಗಿ ಅರ್ಥ ಮಾಡ್ಕೋಬೋದು, ಏನು ಹೆಚ್ಚಿಗೆ ಕಷ್ಟ ಏನಿಲ್ಲ
ಸರ್. ಇದು ಸದ್ಯ ಮಾರ್ಕೆಟಲ್ಲಿ ಅವೈಲೇಬಲ್ ಇದೆಯಾ ಸರ್? ಇದು
ಯಾವುದು
ಅಂದರೆ ಕೆಳಗಡೆಯಿಂದ ಸ್ಪ್ರೇ ಮಾಡೋದಕ್ಕೆ?
ಅದೇ ನಾವು ಏನು ಮಾಡ್ತೀವಿ, ನಾವು ಪ್ರೂಫ್ ಆಫ್ ಕಾನ್ಸೆಪ್ಟ್ ಮಾಡ್ತೀವಿ. ಅಂದರೆ ಸಾಧ್ಯತೆ ಇದೆ ಅನ್ನೋದನ್ನ ಎಲ್ಲ ಒಂದು ತೋರಿಸ್ತೀವಿ. ಅದನ್ನು ಏಕಾಏಕಿ ಅದನ್ನು ಹಾಗೇ ಯಥಾವತ್ತು ಬಳಸಲಿಕ್ಕೆ ಆಗಲ್ಲ. ಕಾರಣ ಏನಪ್ಪ ಅಂತ ಹೇಳಿದ್ರೆ, ನಾವು ಹಲವಾರು ಪ್ರಯೋಗಗಳು ಮಾಡ್ತಾಯಿರ್ತೀವಿ. ನಾವು ಇದ್ರ ಮೋಟ್ರ್ ತೆಗೆದು ಅದಕ್ಕೆ ಹಾಕಿ ಇನ್ನೇನೋ ಮಾಡ್ತೀವಿ, ತೆಗೆದು ಯಾಕೆ ಕಾಸಿಲ್ಲ. ಹಾಗಾಗಿ ಇದು ಮಾಡ್ಕೊಂಡು ಹೇಗೋ ಮ್ಯಾನೇಜ್ ಮಾಡ್ತಿರ್ತೀವಿ. ಮತ್ತು ಭಾಳ ಕಡಿಮೆ ಬೆಲೆಯಲ್ಲಿ ಸಿಗತಕ್ಕಂಥ ಸೆನ್ಸಾರ್ಸ್ ಅದೆಲ್ಲ ಹಾಕಿ ಮಾಡಿರ್ತೀವಿ. ಹಾಗಾಗಿ ಲ್ಯಾಬಿಂದ ಮಾರ್ಕೆಟ್ಗೆ ಹೋಗಬೇಕಾದ್ರೆ ಅದಕ್ಕೆ ಇನ್ನೂ ಹೆಚ್ಚಿನ ಹಣಕಾಸಿನ ಅಗತ್ಯ ಇರುತ್ತೆ. ಪಾಸಿಬಲ್. ಅದಕ್ಕೆ ನಾವು ಹೇಳಲ್ಲ, ಕೂತು ಯೋಚನೆ ಮಾಡಿ ಎಲ್ಲರೂ ಒಂದು ಸಂಪನ್ಮೂಲವನ್ನು ಕ್ರೋಢೀಕರಿಸಿ ಮಾಡಬೇಕು.
ಥ್ಯಾಂಕ್ ಯು ಸರ್.
ಸರ್, ಈಗ ನಾವು 3 ಡೇಸಿಂದನೂ ಡ್ರೋನು ಪ್ಲಸ್ ಅದರ ಅಪ್ಲಿಕೇಶನ್ ಬಗ್ಗೆ ಮಾತಾಡ್ತಿದ್ದೀವಿ. ಪ್ಲಸ್ ಈಗ ಆ್ಯಸ್ ಎ ಅಗ್ರಿಕಲ್ಚರಲ್ಲಿ ನಾವು ಮಾತಾಡೋದಾದರೆ, ಸೊ ವಿ ಆರ್ ಯೂಸಿಂಗ್ ದೀಸ್ ಡ್ರೋನ್ಸ್ ಫಾರ್ ಸ್ಪ್ರೇಯಿಂಗ್ ಪರ್ಪಸ್.
ಹೌದೌದು.
ಸೊ ಈಗ ತಾವು ಆಗಲೇ ನಿಮ್ಮ ಸ್ಲೈಡಲ್ಲಿ ಹೇಳಿದಾಗೆ, ಸೊ ವಿ ಆರ್ ಆಲ್ಸೋ ಮೋರ್ ಕನ್ಸರ್ನ್ ಟುವರ್ಡ್ಸ್ ಎಕಾಲಜಿ ಆ್ಯಂಡ್ ಬಯೋಡೈವರ್ಸಿಟಿ. ಹಾಗಿದ್ದಾಗ ನಾವು ಡ್ರೋನ್ ಅದರಲ್ಲಿ ನಾವು ಸ್ಪ್ರೇ ಎಲ್ಲ ಆಕ್ಟಿವಿಟೀಸ್ ತಗೊಂಡಾಗ ವಾಟ್ ಈಸ್ ಇಟ್ಸ್ ಇಂಪ್ಯಾಕ್ಟ್ ಆನ್ ನ್ಯಾಚುರಲ್ ಎನಿಮೀಸ್ ಆಸ್ ವೆಲ್ ಆಸ್ ನಾನ್ ಟಾರ್ಗೆಟ್ ಆರ್ಗನಿಸಮ್ಸ್? ಮತ್ತೇನಾದ್ರು ಈ ಡ್ರೋನ್ ಯೂಸೇಜಿಂದ ಮತ್ತೆ ಏನು ಎಂಡೋಸಲ್ಫಾನ್ ಇನ್ಸಿಡೆನ್ಸ್ ಇನ್ ಕೇರಳ, ಆ ಥರ ಚಾನ್ಸಸ್ ಏನಾದ್ರು ಇದೆಯಾ ಅಂತ ಈಗ?
ವೆರಿ ಗುಡ್ ಕ್ವಶನ್. ನೀವು ಕೇಳಿದ ಭಾರಿ ಸಂತೋಷ ಆಯಿತು. ಖಂಡಿತ ಯಾವುದನ್ನೇ ಸರಿಯಾಗಿ ಅರಿಯದೆ ಈಗೇನಾಗುತ್ತೆ, ಒಂದು ಡ್ರೋನ್ ತಿರುಗ್ತಾ ಇರುತ್ತೆ. ನಾವು ಅದಕ್ಕೆ ಕೆಲವು ಸ್ಟ್ಯಾಂಡರ್ಡ್ಸ್ ಮಾಡಿದ್ದೀವಿ, ಅನೇಕ ಕಡೆ ಅದು ಫಾಲೋ ಮಾಡಲ್ಲ. ಡ್ರೋನ್ ಜೋರಾಗಿ ತಿರುಗ್ತಾ ಇರಬೇಕಾದ್ರೆ ಆ ಕೆಳ ಒತ್ತಡ ಗಿಡಗಳ ಮೇಲೆ ಬೀಳ್ತಾ ಇರುತ್ತೆ. ನಮ್ಮಲ್ಲಿ ಮೊದಲೇ ನಮ್ಮ ಜಗದೀಶ್ ಚಂದ್ರ ಬೋಸ್ ಅವರೇ ಕಂಡುಹಿಡಿದಿದ್ದಾರೆ. ಏನು ಕಂಡುಹಿಡಿದ್ರು? ಈ ಒಂದು ಗಿಡಕ್ಕೂ ಭಾವನೆ ಅನ್ನೋದಿದೆ. ಈಗ ಇಷ್ಟು ಜೋರಾಗಿ ನೀವು ಗಾಳಿ ಬೀಸ್ತಾ ಇದ್ರೆ ಅದ್ರ ಮೇಲೆ ಏನಾಗುತ್ತೆ ಪರಿಣಾಮ? ದ ಡೌನ್ ವಾಶ್ ಆಫ್ ದಿ ರೋಟಾರ್ಸ್, ಇದನ್ನೆಲ್ಲ ನೋಡಬೇಕು. ಮತ್ತು ಆ ಡೌನ್ ವಾಶ್ ಕೆಳಗಡೆ ಇವತ್ತು ಸ್ಪ್ರೇ ಮಾಡ್ತಾರೆ ಕೆಲವರು. ಅಂದರೆ ಇದು ಎಲ್ಲೋ ಇಲ್ಲಿ ಹೊಡಿಬೇಕಾದ್ರೆ ಆ ಕಡೆನೇ ಹೋಗ್ತಾ ಇದೆ ಪೆಸ್ಟಿಸೈಡ್ಸ್. ಅದು ಹೋಗ್ತಾ ಇದ್ರೆ ಆ ಪೆಸ್ಟಿಸೈಡ್ಸ್ ಎಷ್ಟು ಆಚೆ ಹೋಗ್ತಾ ಇದೆ ಡೇಂಜರ್. ಎಷ್ಟು ಪೆಸ್ಟಿಸೈಡ್ಸ್ ಗಿಡದ ಬದಲಾಗಿ ಆ ಗಾಳಿ ಒತ್ತಡಕ್ಕೆ ಸೀದಾ ಮಣ್ಣಿಗೆ ಹೊರಟೋಗ್ತಾ ಇದೆ, ಡೇಂಜರಸ್. ಇದನ್ನೆಲ್ಲ ಖಂಡಿತವಾಗಿ ನೋಡಬೇಕು. ಅದನ್ನು ಅತಿ ಜಾಗ್ರತೆಯಾಗಿ ಇದನ್ನು ನಾವೆಲ್ಲರೂ ನೋಡಬೇಕು. ಇದಕ್ಕೆ ಸಾಕಷ್ಟು ಪ್ರಯೋಗಗಳನ್ನು ಮಾಡುವ ಅಗತ್ಯ ಇದೆ. ಖಂಡಿತ ಇದು ಭಾಳ ಒಳ್ಳೆಯ ಕಾಳಜಿ. ಇದನ್ನು ಮತ್ತಷ್ಟು ಸೂಕ್ಷ್ಮವಾಗಿ ಗಮನಿಸೋದು ಎಲ್ಲ ರೀತಿಯಲ್ಲೂ ಅಗತ್ಯ. ಇದನ್ನು ನಾವು ಹೋದ ಕಡೆ ಎಲ್ಲ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. ಏನಾದ್ರು ಒಂದು ನಾವು ಅದಕ್ಕೇ ಒಂದು ಡ್ರೋನ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ಸ್ ಅಂತಲೇ ಮಾಡಿ ಇಟ್ಟಿದ್ದೀವಿ. ಆದರೆ ಆ ಸ್ಟ್ಯಾಂಡರ್ಡ್ಸ್ ಫಾಲೋ ಮಾಡಲ್ಲ. ಈ ನಾಸಲ್ ಇದೆಯಲ್ಲ, ಅದು ಹನಿಗಳೇ ಬರುತ್ತಲ್ಲ, ಹನಿಗಳ ಗಾತ್ರ ಎಷ್ಟಿರಬೇಕು ಅಂತಲೂ ಹೇಳಿದ್ದೀವಿ. ಆದರೆ ಕೆಲವರು ಅದನ್ನು ಪಾಲಿಸೋದು ಕಮ್ಮಿ, ಅದರಿಂದ ಅಪಾಯ ಖಂಡಿತ ಇದೆ.
ಸರ್, KC ವ್ಯಾಲಿ ಬಗ್ಗೆ ನಿಮಗೆ ಗೊತ್ತಿರುತ್ತೆ.
ಹಾಂ,
ಇಂಪ್ಯಾಕ್ಟ್ ಆಫ್ ದಿ ಸಿವೇಜ್ ವಾಟರ್ ಅದು ಡಿಟೆಕ್ಟ್ ಮಾಡೋಕ್ಕಾಗುತ್ತಾ? ಈಗ KC ವ್ಯಾಲಿ ನೀರು ಕೋಲಾರ್ಗೆ ಹೋಗ್ತಾ ಇದೆ.
ಹಾಂ ಹಾಂ
ಸೊ ಪಲ್ಯೂಟೆಡ್ ವಾಟರ್ ವರ್ಸಸ್ ದಿ ನ್ಯಾಚುರಲ್ ವಾಟರ್ ಏನಾದರೂ ಮಾಡ್ಬೋದಾ, ಸರ್ವೆ ಮಾಡಿ?
ಖಂಡಿತ, ಪ್ರಾಯಶಃ ನನ್ನ ಅಂದಾಜಲ್ಲಿ ಸ್ಯಾಟಲೈಟ್ ಇಮೇಜ್ ಉಪಯೋಗಿಸ್ಕೊಂಡೇ ಮಾಡ್ಬೋದು.
ಹೌದು,
ಅದಕ್ಕೆ ನೀವು ಬಂದರೆ ಖಂಡಿತ
ಖಂಡಿತ ಸರ್. ಥ್ಯಾಂಕ್ ಯು ಫಾರ್ ದ ಆಫರ್. ಐ ವುಡ್ ಲೈಕ್ ಟು ವರ್ಕ್ ಆನ್ ದ್ಯಾಟ್.
ನಮಗೆ ನಮ್ಮಲ್ಲಿ ಬೇಕಾದ ಜನ ಕೆಲವರು ವಿದ್ಯಾರ್ಥಿಗಳಿದ್ದಾರೆ.
ಓಕೆ ಸರ್,
ಅವ್ರಿಗೆ ಹೇಳೋಣ, ಹೇಳಿ ಮಾಡಿಸೋಣ. ಖಂಡಿತ,
ಶೋರ್ ಸರ್, ಖಂಡಿತ.
ಸಮಾಜಕ್ಕೆ ಒಳಿತಾಗೋದು ಏನಾದ್ರು ಇದ್ರಲ್ಲಿ ಬನ್ನಿ ಮಾಡೋಣ.
ಥ್ಯಾಂಕ್ ಯು ಸರ್.
ಸರ್, ಈಗ ಯಾವುದಾದ್ರೂ ಒಂದು ಕ್ರಾಪ್ ತೊಗೊಂಡ್ರೆ ಒಂದು ಹೈ ಈಲ್ಡಿಂಗ್ ಅಥವಾ ಆಪ್ಟಿಮಮ್ ಈಲ್ಡಿಂಗ್ ಇರೋದು ಒಂದು ಪ್ಲಾಟ್ ಇರುತ್ತೆ ಸರ್. ಸೊ ಆ ಪ್ಲಾಟ್ದು ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಸೆಟ್ ಆಫ್ ಡಾಟಾ ಇಟ್ಕೊಂಡು, ಲೈಕ್ ಇಮೇಜ್ ಲೀಫ್ ಕಲರ್ ಇಮೇಜು, ಬೇರೆ ಒಂದು ಡಾಟಾಬೇಸ್ ಇಟ್ಕೊಂಡ್ಬಿಟ್ಟು ಮಿಕ್ಕಿದ ಫೀಲ್ಡನ್ನ ಫಾರ್ ನ್ಯೂಟ್ರಿಷನಲ್ ಡಿಫಿಷಿಯನ್ಸಿ ಎಷ್ಟಿದೆ, ಅದು ಬ್ಯಾಲೆನ್ಸ್ ಎಷ್ಟು ರೆಕಮೆಂಡ್ ಮಾಡಬೇಕು, ಎಷ್ಟು ಫರ್ಟಿಲೈಸರ್ ಯೂಸ್ ಮಾಡಬೇಕು, ಅದನ್ನು ಡಾಟಾ ಆರ್ಟಿಫಿಷಿಯಲ್ ಇಂಟೆಲಿಜೆನ್ಸ್ ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ರೆಡಿ ಮಾಡಲಿಕ್ಕೆ ಅವಕಾಶ ಇದೆಯಾ ಸರ್?
ಇದಕ್ಕೆಲ್ಲ ಏನಂದರೆ ಆರ್ಟಿಫಿಷಿಯಲ್ ಇಂಟೆಲಿಜೆನ್ಸ್ಗೆ ಮುಖ್ಯವಾಗಿ ದತ್ತಾಂಶ, ಡಾಟಾ ಬೇಕು.
ಹಾಂ ಸರ್.
ಈ ನೀವು ಕೇಳಿದ ಪ್ರಶ್ನೆಗೆ ನಿಖರವಾಗಿ ನಮಗೆ ದತ್ತಾಂಶ ಬೇಕು ಅಂದರೆ ಇದಕ್ಕೆ ಬಹುರಂಗಿನ ಚಿತ್ರಣ ಬೇಕು. ಏನು ಬಹುರಂಗಿನ ಚಿತ್ರಣ ಅಂದರೆ ಹೈಪರ್ ಸ್ಪೆಕ್ಟ್ರಲ್ ಇಮೇಜರಿ ಬೇಕು. ಹೈಪರ್ ಸ್ಪೆಕ್ಟ್ರಲ್ ಕ್ಯಾಮ್ರಾ ಇವತ್ತಿಗೂ ನಮ್ಮಲ್ಲಿ ಭಾಳ ದುಬಾರಿ, ಸುಮಾರು 30-40 ಲಕ್ಷ ಆಗುತ್ತೆ. ಹಾಗಾಗಿ ಅದಕ್ಕೆ ಯಾರು ಒಂದು ಪ್ರಯತ್ನಪಟ್ಟು ಆ ಥರದನ್ನು ಮಾಡಬೇಕು. ಅದಕ್ಕೆ ಹಣಕಾಸಿನ ವ್ಯವಸ್ಥೆ ಮಾಡಿದ್ರೆ ನಮ್ಮಲ್ಲಿ ಖಂಡಿತವಾಗಿ ಸಾಧ್ಯ ಇದೆ. ನಾವು ನೀವು ಹೇಳ್ದಂಗೆ ಕೇವಲ ಈ ಹೈಪರ್ ಸ್ಪೆಕ್ಟ್ರಲ್ ಕ್ಯಾಮ್ರಾಯಿಂದ ಕೇವಲ ಗಿಡದ ಒಂದು ಆರೋಗ್ಯ ಅಷ್ಟೇ ಅಲ್ಲ, ಅಲ್ಲಿರ್ತಕ್ಕಂಥ ಮಣ್ಣಿನ ಆರೋಗ್ಯವನ್ನು ಸರಿಯಾಗಿ ತಿಳ್ಕೊಬೋದು, ಅದನ್ನೂ ಸರಿಯಾಗಿ ಇದು ಮಾಡ್ಬೋದು. ಆ ನೀರಿನ ಮಟ್ಟ ಎಷ್ಟೆಷ್ಟು ಇರಬೇಕು, ಯಾಕೆ ಈಗ ಅನಗತ್ಯವಾಗಿ ನೀರು ಕಟ್ಬಿಡ್ತೀವಿ ನಾವು. ಇವು ಭತ್ತ ಬೆಳೆಯೋಕ್ಕೂ ಅಷ್ಟೇ, ಎಷ್ಟು ನೀರು ಬೇಕೋ ಅಷ್ಟು ನೀರಿದೆ ಅಂದ್ಬಿಟ್ಟು ನೀರು ನಿಲ್ಲಿಸ್ಬಿಡ್ತಾರೆ. ನೀರು ನಿಲ್ಲಿಸ್ಬಿಡೋದ್ರಿಂದ ಮೀಥೇನ್ ಲೆವೆಲ್ಲು ನಮ್ಮ ವಾತಾವರಣದಲ್ಲಿ ಜಾಸ್ತಿ ಆಗ್ತಾಯಿದೆ. ಅದರಿಂದ ಭತ್ತ ಬೆಳೆಯೋದ್ರಿಂದ ಕೆಲವು ಸರಿಯಾಗಿ ಬೆಳೀಲಿಲ್ಲ ಅಂದರೆ ಅದರಿಂದನೂ ಅಪಾಯ ಉಂಟು. ಇದನ್ನೆಲ್ಲ ತಿಳ್ಕೋಬೇಕು ಅಂದರೆ ಹೈಪರ್ ಸ್ಪೆಕ್ಟ್ರಲ್ ಇಮೇಜರಿ ಈಸ್ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಸಾಧ್ಯ ಇದೆ,
ಯಾಕೆಂದರೆ ಪ್ಲಾಂಟ್ ನ್ಯೂಟ್ರಿಯೆಂಟು ಪ್ಲಾಂಟ್ಸ್ಗೆ ಎಷ್ಟು ರಿಕ್ವೈರ್ಮೆಂಟ್ ಇದೆ ಅನ್ನೋದು ಅವಶ್ಯಕತೆ ಇದೆ, ಯಾರು ಅರ್ಥ ಮಾಡ್ಕೊಂಡು ಮಾರ್ಕೆಟ್ ಡ್ರಿವನ್ ಫರ್ಟಿಲೈಸರ್ ರೆಕಮೆಂಡೇಶನ್ ಆಗ್ತಿದೆ ಸರ್.
ಅದನ್ನು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕಾದ್ರೆ ಹೈಪರ್ ಸ್ಪೆಕ್ಟ್ರಲ್ದು ನಾವೆಲ್ಲರೂ ಪ್ರಯತ್ನ ಪಡಬೇಕು. ಈಗ ಪ್ರಪಂಚದಾದ್ಯಂತ ಅದು ನಡೀತಾ ಇದೆ, ನಾವು ತೊಗೊಂಡು ಮಾಡಬೇಕು. ಅದೇನಂತ 30-40 ಲಕ್ಷ ಸರ್ಕಾರದವ್ರು ಮನಸ್ಸು ಮಾಡಿದ್ರೆ ಏನು ತೊಂದರೆ ಇಲ್ಲ, ಬಟ್ ಯಾರು ಮಾಡಬೇಕು. ನಮ್ಮ ಆತ್ಮೀಯರು ಬೈಕ್ ಎತ್ಕೊಂಡು ಬಂದ್ಬಿಟ್ರು ಅಂದರೆ ಸಾಕು ಅಂತ. ಆಯಿತು, ನಮಸ್ತೆ. ಈಗ ಒಂದು ಪ್ರಶ್ನೆ ಮಾಧವಿಂದಿದೆ, ಒಂದು ನಿಮಿಷ ಇದೆ. ನಮ್ಮ ಕ್ಲಾಸ್ಮೇಟು ಮೈ ಕೊಟ್ಬಿಡಿ ಬಾ.
ಇಲ್ಲಿವರೆಗೂ 3 ದಿವಸದಿಂದನೂ ಎಲ್ಲ ಸೆಷನ್ಸು ಅಟೆಂಡ್ ಮಾಡಿದ್ದೀನಿ. ಈ ಸೆಷನ್ಗೂ ಉಳಿದ ಸೆಷನ್ಗೂ ಕಂಪೇರ್ ಮಾಡ್ತಾ ಇಲ್ಲ ನಾನು. ನಾರ್ಮಲಿ IAS ಇವ್ರು ಅಂತ ಹೇಳಿದ್ರೆ ನೀನೇ ಹೇಳ್ದಂಗೆ ಎಲ್ರಿಗೂ ಅರ್ಥ ಆಗೋ ಥರ ಯಾರೂ ಹೇಳಲ್ಲ. ಸೊ ಈ ಸೆಷನ್ನು ಅದಕ್ಕೆ ಭಿನ್ನವಾಗಿ ಇತ್ತು ಅಂತ ನಾನು ಅಭಿಪ್ರಾಯ ವ್ಯಕ್ತಪಡಿಸ್ತೀನಿ. ಯಾವಾಗಲೂ ಇನ್ಫಾರ್ಮಲ್ಲಾಗೇ ಇರಬೇಕು ಯಾವುದೇ ಒಂದು ಸೆಷನ್ಸು. ಅದು ಎಷ್ಟೇ ಡೀಪ್ ಇರ್ಬೋದು, ಆಳವಾಗಿರ್ಬೋದು, ಗಹನವಾಗಿರ್ಬೋದು ವಿಚಾರ, ಅದು ಸಾಮಾನ್ಯರಿಗೆ ತಲುಪೋಂಗೆ ಹೇಳೋದೇ ಆ ಪರ್ಸನ್ ಕೆಪಾಸಿಟಿ. ಪ್ರಾಬ್ಲಿ ಯು ಆರ್ ಮೂವಿಂಗ್ ಟುವರ್ಡ್ಸ್ ದಟ್. ಐನ್ಸ್ಟೈನ್ ಹೇಳೋಂಗೆ ಇಫ್ ವಿ ಕ್ಯಾನ್ ಟೆಲ್ ಇಟ್ ಟು ಆರ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಇಟ್ ಟು ಎನಿ ಕಿಡ್ ದೆನ್ ವಿ ಆರ್ ಡನ್ ವಿತ್ ದ ಟಾಪಿಕ್ ಅಂತ. ಸೊ ಹಾಗಾಗಿ ಈ AI ಯೂಸೇಜು ಡ್ರೋನ್ನ ಒಂದು ಮಲ್ಟಿ ಫೇಸೆಟ್ಸ್, ವಿಭಿನ್ನ ಮುಖಗಳನ್ನು ಇವತ್ತು ನಾವು ಈ ಸೆಷನ್ನಲ್ಲಿ ನೋಡೋದು. ಪ್ರಾಯಶಃ ಬರೀ ಅಗ್ರಿಕಲ್ಚರ್ ಅನ್ನೋದು ಒಂದು ಟಾಪಿಕ್ ಆದ್ರೂ ಆದರೆ ಎಷ್ಟು ಫೇಸೆಟ್ಸ್ ಇದೆ, ಯಾವ್ಯಾವ ಕ್ಷೇತ್ರದಲ್ಲಿ ಸಮಾಜದಲ್ಲಿ ಅದನ್ನು ಬಳಸ್ಬೋದು ಅನ್ನೋದು ಎಲ್ರಿಗೂ ಒಂದು ತಿಳುವಳಿಕೆ. ಸೊ ಹಾಗಾಗಿ ಏಕೆಂದರೆ ಒಂದು ಯಾವುದೋ ಒಂದು ಡೊಮೈನಲ್ಲಿ ಪ್ರಾಯಶಃ ನಮ್ಮ ಒಂದು ಜೀವನ ವೃತ್ತಿಗೋಸ್ಕರ ನಾವು ಸೇರ್ಕೊಂಡ್ಬಿಟ್ಟಿರ್ತೀವಿ, ಆದರೆ ಅವ್ರ ಕೆಪಾಸಿಟಿಗಳು ಬೇರೆ ಬೇರೆಯೇ ಇರುತ್ತೆ, ಅವ್ರ ಕ್ಷೇತ್ರದ್ದು ಆಲೋಚನೆಗಳು ಬೇರೆ ಬೇರೆಯೇ ಇರುತ್ತೆ. ಆ ಒಂದು ದಿಕ್ಕಿನಲ್ಲಿ ಎಕ್ಸ್ಪ್ಲೋರ್ ಮಾಡೋದಕ್ಕೆ ಪ್ರಾಯಶಃ ಈ ಒಂದು ಸೆಷನ್ನು ತುಂಬ ಅನುಕೂಲಕಾರಿ. ಎನಿವೇ ಐ ಆಮ್ ವೆರಿ ಪ್ರೌಡ್, ವಿ ಆರ್ ಆಲ್ ಪ್ರೌಡ್ ಆಫ್ ಓಂಕಾರ್ಸ್ ವರ್ಕ್ in the different facets of society, and being a friend, probably classmate also, I am really feeling very great about your work, and taking this kind of work is very very much important to the next generation. So and I am for that because we work in that segment. So definitely we will take it forward to the next generation kids, because so many Omkars will come out probably in the future and do great things for the nation. Thank you, Omkar. All the best.
Thanks for your best wishes. Namaste.
ಥ್ಯಾಂಕ್ ಯು ವೆರಿ ಮಚ್ ಸರ್. ಕನ್ನಡದಲ್ಲಿ ಹಾಗೂ ಇಂಗ್ಲೀಷಲ್ಲಿ ಎರಡೂ ಭಾಷೆಗಳಲ್ಲಿ ತುಂಬ ಸರಳವಾಗಿ ಅತ್ಯಂತ ಕ್ಲಿಷ್ಟಕರವಾದ, ವೆರಿ ಡಿಫಿಕಲ್ಟ್ ಆ್ಯಂಡ್ ಆ್ಯಸ್ ರಿಸರ್ಚರ್ಸ್ ಇನ್ಫಾರ್ಮ್ ಆ್ಯಂಡ್ ಗಿವ್ ಇನ್ಫಾರ್ಮೇಷನ್ ಅಬೌಟ್ ದೇರ್ ರಿಸರ್ಚ್ ಆ್ಯಂಡ್ ವರ್ಕ್ ಇನ್ ಡಿಫ್ರೆಂಟ್ ಮ್ಯಾನರ್. ಬಟ್ ಇಲ್ಲಿ ಆ ಥರ ಆಗಲಿಲ್ಲ ಸರ್. ತುಂಬ ಸರಳವಾಗಿ ಎಲ್ಲರಿಗೂ ಅರ್ಥ ಆಗೋ ರೀತಿಯಲ್ಲಿ ಅವರು ವಿಡಿಯೋ ಹಾಗೂ ಅವರು ಇಮೇಜ್, ಫೋಟೋಸ್ ಮತ್ತು ಇಮೇಜಸ್ ಜೊತೆಗೆ ಎಲ್ಲ ತೋರಿಸಿ ಎಲ್ಲರಿಗೂ ಅರ್ಥ ಆಗೋ ಥರ ಮಾಡಿದ್ದಾರೆ. ಅವ್ರನ್ನ ಜೋರಾದ ಚಪ್ಪಾಳೆಯೊಂದಿಗೆ ಅಭಿನಂದಿಸೋಣ, ಆಗ ಗೌರವಿಸೋಣ. ಸರ್ ತುಂಬ ಥ್ಯಾಂಕ್ ಯು ವೆರಿ ಮಚ್ ಸರ್. ಕೊಡಿ ಸರ್, ನೆಕ್ಸ್ಟ್ ಟೈಮಿಂದ ವಿಲ್ ರಿಪ್ಲೇಸ್ ಇಟ್. ಎಸ್ ಸರ್, ಶ್ಯೂರ್ ಸರ್, ಥ್ಯಾಂಕ್ ಯು ಸರ್. ಸೊ ನಾವು ವಿಲ್ ಹ್ಯಾವ್ ಅ ಟೀ ಬ್ರೇಕ್. ಆಮೇಲೆ ಸ್ವಲ್ಪ ಇಲ್ಲಿ ಒಂದು 15 ಮಿನಿಟ್ಸ್ ಕೆಲಸ ಇದೆ ಎಲ್ಲರಿಗೂ. ಆಡಿಟೋರಿಯಮ್ಗೆ ಬನ್ನಿ. ಆಫ್ಟರ್ ದ್ಯಾಟ್ ವಿಲ್ ಗಿವ್ ಲಂಚ್ ಬ್ರೇಕ್. ಆಮೇಲೆ 2 ಸೆಷನ್ ಇರುತ್ತೆ, ಫಾಲೋಡ್ ಬೈ ವ್ಯಾಲಿಡಿಕ್ಟರಿ. ಓಕೆ, ವಿಲ್ ಹ್ಯಾವ್ ಟೀ ಬ್ರೇಕ್ ನೌ. ಥ್ಯಾಂಕ್ ಯು, ಥ್ಯಾಂಕ್ ಯು. ನೀವು 4 ಜನ ಈ ರೋಗೆ ಬನ್ನಿ, ಸೆಕೆಂಡ್ ರೋಗೆ. ಸೆಕೆಂಡ್ ರೋ. ಸ್ವಲ್ಪ ಹಿಂದೆ ಇರೋರು ಮುಂದೆ ಬಂದರೆ ಅನುಕೂಲ ಆಗುತ್ತೆ ಸರ್. ಅಂದರೆ ಒಂದು ಸಾರಿ ನಾವು ಕ್ಯಾಮ್ರಾದಲ್ಲಿ ಕವರ್ ಮಾಡಿಬಿಡೋಣ ಅಂತ. ಸೊ ಫಾರ್ ದ್ಯಾಟ್ ರೀಸನ್. ಲೋಬೋ ಒಂದು ಸಾರಿ ಆ್ಯಂಟನಿ. Very good afternoon. Without much ado, we are already running late and we have 2 sessions post lunch. Now we have with us Shri Shreyas Naik from Skylark Drones. I welcome Shreyas on the dais. Please welcome and thank you for accepting our invitation. And thanks to your team, Mr. Mrinal, and convey our thanks to Shri Mugilan Thiruramaswamy. In spite of your busy schedule, they have sent you. They have supposed to come here to deliver this session, but due to some unavoidable circumstances, they have deputed their team member, Shri Shreyas Naik, here. And before starting his session, I would like to just brief about his academics and his work experience. He is graduated from engineering, RVCE College, with the mainstream of being electronics and communication, and currently he looks after developing enterprise solutions at Skylark Drones with particular focus on the mining and railway sectors. Apart from this, I request Shri Shreyas ji to how to integrate the same thing to agriculture and allied sectors. So, okay. Thank you. Over to you, Shreyas, and welcome once again on behalf of all of us here. Thank you. Over to you.
Very good afternoon, everyone. Thank you for making it. Right. So today I'm going to talk about the hype surrounding the drones and what exactly drones can be used for across multiple sectors. Because today everyone would have heard of drones being used in the defense sector. There's talk about like Pakistan using drones for mainly military purposes. So the company where I come from, Skylark Drones, we believe that drones have a lot of economic value beyond just defense, right? So if we are talking about sectors like construction, mining, railways, all of these civilian use cases can be enhanced through drones, and that is what I want to walk you through today, right? So first of all, we are today in an inflection point when it comes to the use of drones. Essentially, this is where we are, right? Daily, there's more than 1 lakh drone flights happening every day in India, right? And this is just expected to go on and increase 7x by the end of this decade. Now, this, is basically taken care of through the enterprise adoption of drones, It's, of course, we are all used to seeing drones being used in the marriage ceremonies, in our, any other events. But there are more to drones than just that, right? So if we were to just look at a couple of applications, there's more than 30 applications across the enterprise sectors, whether it is in the renewable sector for solar, whether it is in mining, whether it is wind energy, whether it is railways, transmission towers, so on and so forth, right? And if we talk about the markets where drones are being adopted, India is in the top 5. We are basically the fastest growing drone adopter in the world currently, right? The 6 industries where these are mainly being used, the first would be the infrastructure and the construction sectors, followed by mining, followed by energy. Then there's agriculture. This is more of a worldwide view. In India, this entire thing would be flipped slightly, because agriculture would be at second and mining would be at third, right? And there's a lot of money chasing drones, right? In terms of investments or capital that's going into drone. More than $7 billion have been invested into this. Now, clearly, there's a lot of value people see. So what exactly is it, right? What sets drones apart? So when we talk about drones, drones can be either remote sensors or they can be remote actuators, right? So when I say a remote sensor, it is essentially something like a camera or an eye in the sky, right? The only difference being that it's not just a camera. You can have a LiDAR payload, you can have a multispectral payload, you can have a hyperspectral, right? Depending on the use case, depending on what exactly you want to see, you can have the drone as a platform which is going to carry this, right? Now, for today's thing, I just want to focus on the remote sensing part and how that is adding value, right? Remote actuation is something which you might have seen in terms of the drone sprayers in agriculture, those window washing drones which you might have come across, or those drones which are used to, say, drop bombs, drop packages in Amazon, right? So that is something which is not that well developed in the Indian industry as of today. That's something we hope we can change, right? But remote sensing is something where a lot of value has been seen. So how exactly do drones help in remote sensing, right? So whenever we are talking about remote sensing for any proper application, there's 3 dimensions, right? One is the accuracy or the resolution. The second is the cost of the deployment. And the final is how scalable or how fast can you use this, right? So traditional methods like a laser scanner, they are highly accurate and they can work pretty fast, but they are very expensive. An IoT sensor, which you can install anywhere, is going to be very cheap, right? But it is not very scalable. So at the point you try to scale it, the cost really becomes very high. And at that point, the accuracy is again very dependent on the sort of device that is being deployed, right? Of course, satellites are the most classic example of remote sensing. These are out there in orbit and they can capture huge swaths of data with very little incremental cost, right? But if you see, at the center of this Venn diagram of these 3 dimensions is the drone. You have a drone which is able to capture extremely high resolution data. The data that a drone captures is going to be around 2 centimeter per pixel, right? That is the resolution order we are talking about. While a satellite typically operates in like 50 centimeter, the top of the line, right? Whatever satellites we currently have for weather or anything else is going to be in the meter level. So that is a quantum shift in terms of resolution that a drone can offer. In terms of speed, a drone can basically cover a 100-acre site in the matter of an hour, right? That is something which cannot be done with a laser sensor or any of these traditional total stations or anything. So combine all of these together and you have a very flexible solution which is being adopted more and more by enterprises, right? So a drone basically gives an enterprise a complete visual access to the work site, right? Whether it is a small 10-acre quarry or a 400-hectare mine, using a drone, any lease owner or a regulator can see what exactly is going on, right, at any resolution of their choice. And a drone does not require specific infrastructure for you to use it. If you say, I want to see this area, you please deploy your drone. It is as simple as me going there and just clicking 2 sticks together, the drone will take off. I don't need to give it any more infrastructure more than that. So that's why like the cost necessary and the flexibility becomes very high. And since a drone is such a cheap platform, it is easily scalable, right? So if we were to just talk, a ballpark comparison of how much per image costs or how much per unit data costs, for a terrestrial laser scanner, the entire equipment itself costs near to 1 crore, while a drone costs less than 10 lakhs, right? And over there, a drone can capture around 100 acres in an hour. A TLS will require someone to actually go and physically replace it, and that will take more than 3 hours for the entire operation. So a drone gives enterprises that sweet spot where you are not really compromising much, right? While you are getting it at a way cheaper price. And that is why drones are basically taking over the world, so to speak. Now, how exactly does a drone help if we are talking just from a data perspective, right? So a drone is essentially, you can think of it as a pre-programmable robot which can operate in 3 dimensions. So you can program its flight however you want and ensure that every time when it moves, it is following the same path, right? Now this is very important because whether it is a mine, whether it is say an agricultural field, whether it is a road, you need to ensure that whatever data you are taking is reusable, it is comparable across surveys. So for that, you need to ensure human error does not creep into the equation. So that is where we have like flight automation and data verification to ensure that there is no error that has crept into the system during the stage of data acquisition. Once you have actually acquired the data, that's when you go ahead and you create a 3D digital twin, right? So the digital twin, as the name implies, it's a recreation of ground reality as a digital format, which is available for someone to actually interact with and analyze. So that actually helps save the data processing problem. Now, if all of this is stored in one centralized cloud location, right? So you'll have one central repository of data, whether it is you who's looking at it as a, let's say the GM of department, or it is the government, or it is your stakeholder. Right? Everyone is looking at the same data, and therefore there is absolute transparency in the way data can be used. Right? So there is no longer someone coming and pulling the wool over another stakeholder's eyes, because the ground data is there for you to see. Right? And once we have everything as a digital representation, it is very it is very normal that you would want to bring AI into it, and that's what we are also doing. Right? So we have AI powered analytics on the worksite, whether it is in terms of the performance of the work site, how much has been excavated, whether it is in terms of how much inefficiency is there in terms of fuel, whether it is understanding how much solar power can be harvested from a given area, right? So that's what the entire like drone solution stack brings to the table, right? So now let's look at a couple of sectors where drones and drone data is being used, right? So the first one I'd like to bring your attention is surveillance, right? So this is a very logical extension of the simple videography that we are all used to seeing. Essentially, drones have cameras in the sky, which can be captured from different angles, different vantage points, right? So this is very important when we are talking about security or surveillance. So drones also have thermal cameras. So in the pitch black of night, you can actually see whether there are people coming in, right? So to just give one small example, or rather a small incident that happened to my colleague. So he was in a mine where he was essentially helping with the surveys, but the mine manager got to know that there is some local issue that is happening. The locals are not happy, and some Naxal elements are going to be coming to the site. So what we were able to do, or rather my colleague was able to do, he actually flew the drone. He conducted a perimeter search, realized where they are. Because they thought they can approach in the dark of night, but using a thermal camera payload, basically you can see people like that, right? So he was able to recognize where people are. So the security team was deployed to essentially keep the stakeholders safe, while another team was deployed to go and stop the nefarious elements in their track, right? So because of this, this has been adopted by a lot of mining companies, a lot of renewable companies, where they acquire the land under the belief, under the good faith that, you know, it has no issues. But obviously there is always something which is hidden by the powers that be. So how do they deal with that? They use drones to ensure that there are no casualties, right? Same thing if you were to extend to a different scenario. Same thing can be used by our police to understand, what are the movements of, let's say, vehicles, what is causing traffic jams in case there's a jam. Essentially use it to take care of like man-animal conflicts that can happen. Every now and then we keep hearing reports, you know, one leopard entered someone's house. So nobody is able to track where these leopards are. The current conventional wisdom is you need to tag these leopards in case you want to actually track them, right? And that's when you can track it in real time. A sensible solution or an alternative would be use a drone with a thermal camera, keep flying it in the night, right? Understand which are these typical paths that these migration paths or these hunting tracks that these animals take, and put more focus on those areas so that man-animal conflict doesn't happen. So that is one way we can use drones, right? So moving on. Next is solar, right? So we are all very aware that solar energy is basically the future. We are looking at decarbonization and all of that. So solar is very important in that context. Now, when we talk about solar, there are going to be two sorts of solar projects, right? One is the utility scale solar projects. One is the rooftop scale solar projects. So the rooftop is something which most of us would be aware of. But in utility scale, you are essentially looking at from a few megawatts to a few hundreds of megawatts, right? So it is a huge area, and in these in this entire industry, time is of the essence. If they have been commissioned to install this in, let's say, March, and they are not able to get it done by, say, September, after that, essentially, it's the rainy season, all right? I mean, for at least this particular site, it was that way, right? So how do you ensure that such a huge area, how do you ensure such a huge project is taken care of? You need a very accurate data at a very fast pace. So that's what drones can do. You essentially fly the drones every week or every 2 days, depending on how granular the data you want. You can see, you know, like right now you can see on the right side where some holes are dug versus the left side where panels are placed. So all of this data is available at a centimeter scale accuracy, and we can just run an AI to tell, you know what, today there are X number of panels that are installed. According to the plan, it was supposed to be Y. So the X minus Y, this is the gap, right? So as a project manager, he will get to know what needs to happen, where exactly it needs to happen, right? So that is on the construction monitoring side. Similarly, on the rooftop solar, you would want to know, is my house actually capable of giving me all these returns that whoever is trying to sell solar to me is purporting? Right? So for that, essentially what you can do is you can use a drone, you can create a 3D digital twin, and then estimate what is the solar radiation falling on it every day. Right? So you'll have atmospheric solar models which will tell what is the irradiation coming in, and we can estimate again at a sub-meter level accuracy within 2% error what is the solar irradiation a house can expect. Right? So that is a very important input for anyone making a decision whether they need to opt for solar or not. Now, so this particular thing, we have actually gone ahead and we are working with the Ministry of New and Renewable Energy to help them fast forward the PM Surya Ghar Yojana, right? Apart from that, we can help on climate proofing. So I'll come to the climate proofing in the next slides, right? Now coming to mining, I think it would not be an exaggeration for me to say that mining, especially in Karnataka, doesn't have the best reputation. Every now and then we hear about issues, right? Now, it is very easy to just point fingers and say people are corrupt, but where exactly is the corruption creeping in? How much is the corruption creeping in? That is very hard for people to actually estimate. Right? So using a drone and a digital twin, you are getting a centimeter scale model of the entire site, right? So as it happens, many times the leaseholder, who is like, let's say, the owner of the mine, so to speak, he is not the one who's actually going and excavating. He has subcontracted it out to a MDO, basically a mining development operator. The underreporting from the mining development operator basically flows upwards from the on-ground field right to the government. And at every level, if there's underreporting and there's no way for us to actually validate that or verify that, it is causing losses of crores and crores for the state exchequer. So what we say is, you know what, fly the drone, get the model, do it at every quarter, right? See how the site is actually evolving between 3 months or 1 month, depending on how you want to see. So you'll get a non-fungible way to see what has happened on the ground. Now nobody can come and modify this, right? So if someone is coming and reporting to you, I have excavated only 10 tons, when the data clearly shows he has excavated 20 tons, right? It is very easy to call them out on this and actually take corrective action, right? Now what happens is 10 tons every time if it keeps increasing, right? Like a small percentage, right? That's where these people basically play, right? It's like legacy survey instruments have not been able to give accuracy beyond say 10% or 12% of uncertainty. Now this 10% or 12% is enough for people to pull the wool and make a lot of profit out of it. So what drones bring is, drones can get you an accurate estimate up to 2%, right? Or 1.5% depending on the way you are capturing the data. So now there is a lot less space for these people to actually pull the wool over anyone's eyes, right? So that's the most, I would say, well-known use case of drones in India. Basically, the Indian Bureau of Mines has now made it mandatory for every mine to actually get this done every year, so that whatever the mines are reporting to the government, they can cross-verify and see whether it is correct or not, right? But this is from a regulator perspective. From a mine operator perspective, do I know whether all these benches that I'm seeing, right, those blue lines which I'm seeing in the image, are they safe or not? Tomorrow if one vehicle is going next to it, is there a possibility that it will just collapse and probably kill a couple of people, right? The human cost is also something they would be interested in. And using a drone, I can tell, you know what, that entire thing is at a slope of say 60 degrees. The safe zone for this would be less than 45 degrees. If I'm able to identify that and take corrective action before any incident happens, then I can minimize loss. I can ensure safety for everyone who's working there, right? As a employer in the mine, I would be thinking of lesser costs for compensation to my workers, a better working environment, and for the workers themselves, it is a better working environment. They are secure, right? They can do their work without being scared. So things like this, have been, I would say, recognized, and they're being used by companies like Ultratech, Vedanta, Tata Steel, Adani, right? So the idea is get very accurate information about the entire mine. So the final thing which drone surveys can help is, if you are doing it regularly, one of the things mining people want to check is whether their output is of the same grade that they're expecting or not, right? Now this grade is essentially a very hard thing for someone to quantify without doing chemical tests on it. So the way they operate is, they will have an ore body model. Essentially it's a 3D reconstruction of the underlying ore, and they get that as a 2D projection on the map. They say, okay, at this area I'm getting a 10% grade, at this area I'm getting a 15% grade. Now if they are always excavating the higher grade first, then that means lesser work for getting the same amount of material out to sell, right? So that is what the mine plan is all about. That is what they submit to the regulators. That is what gets approved. Now if the on-ground people are not able to actually deliver on that plan, right, for whatever reason, on the ground it might be that terrain is challenging, on the ground somehow excavation started in one area and it is just continuing there, there's no corrective action coming in, right? So that mine plan versus actual tracking is also very important. Sometimes the plan might be that they are supposed to excavate only say 1 lakh cubic meters. That's what would be the approved plan by the regulator. But for whatever reason they have gone ahead and excavated 1 lakh 10. Right? Now if it is not caught, then they'll go and keep excavating more. So at the end of the year, they have to go and pay a bigger royalty, a bigger fine also. So capturing this information in a timely manner is important, and that's where drones can help. Right? So now, moving on. in the power transmission sector. Now, you might have heard news reports every now and then that some person was injured while trying to do a inspection of these towers, right? These are high tension towers. Some in Karnataka, I believe it would be 220 kV, right? Depending on like the type of line it is, it might be even higher. So here, essentially any defect that comes in will have a huge downstream effect, right? If there's any power losses happening there because of a faulty component, then it needs to be tracked as soon as possible, as safely as possible, right? So this is where drones can basically help. Essentially, the drones have very high resolution sensors. You can also have LiDAR sensors, right? So using that, you can essentially like zoom in to the extent where I can see what is written on all of those insulators as well, right? So if there's anything, any crack which is coming in, anywhere where some nuts have fallen off, I can actually identify that using my drone data and tell, what, these are potential areas where there are structural defects. Please take care of this, right? And all of this I can do without sending one guy on top of there, right? That is a very risky proposition. Anything can happen when he is there. But with a drone, for this particular purpose, you can deploy a drone that costs maybe like 4.5 to 5 lakhs and identify where power loss is happening using a thermal camera through the hotspots. And then you can also look at everything as an RGB image, as a normal visual image, and then understand what is the status of this drone without anyone ever setting foot on that tower, right? So that can help increase the speed of this. It can help reduce the unsafeness. That can help also see what a normal guy cannot see, right? Power loss or hotspots. I'm so sorry. Right. So for this, we are building AI models based on training data, and more we are building. So the more data that comes in, the more we can automate this. The next is for linear infrastructure. So when I say linear infrastructure, we are basically looking at roads, railways, pipelines, and things like that. Essentially, assets that stretch on for kilometers on end, right? So the first challenge with all of these things is getting the right of way, right? If you want to increase a road from 20 feet to 30 feet, first you need to understand, okay, you know what, I am expanding it by 5 feet on each side. How many buildings are going to get affected? How many transmission towers or telephone lines do I need to relocate? How much money should I allocate for this, right? So that is a very important thing that everyone does in the DPR stage. So they have to actually go and check that, and so all of that, earlier it used to be done manually. So today, using drones and GIS technology, you can essentially survey the entire track you want, get like very high resolution imagery of what exactly is there on the ground. That will help you understand what are the buildings, what are the electric poles, how many trees you need to cut. All of that through the AI, it can automatically tell, right? Going one step forward, since we have a very high resolution 3D reconstruction of the area, we can go ahead and calculate how much earthwork needs to happen, how much land needs to be cut, how much aggregate or anything needs to be brought in and placed on those roads, right? So that's something we have helped multiple EPC companies with. We have helped Kalpataru, Alstom, so on and so forth, right? So finally, I'd like to talk about disaster preparedness and climate proofing. So I think it goes without saying that the monsoon patterns seem to be slightly shifting, and because of that, there's always unexpected flooding and things like that. So one thing we can do is, using high resolution drone data, we can estimate what is the nature of flooding that can happen based on historical weather data, based on other alternate scenarios, and tell, what, these are the low-lying areas at a rainfall of say 75 centimeters. This is the flood depth you can expect, and the water is going to flow northeast to southwest. So all of that we can estimate using drones, right? So we actually had a small use case here. Like last year, you might be aware that in Vijayawada there were some floods, right? So Vijayawada was also one of the cities where we kind of had half of the city mapped out for a different project with the government. So we just decided to make a flood estimation model and when the floods actually happened, we compared. So we were there within a 10 centimeter variation, right? So that's the sort of data accuracy you can expect. All of this without really going into too much depth. It just requires like you fly the drone, get the 3D model of the entire site, and use historical data, right? So this has been mainly adopted by solar people, because in the utility scale you have a large area. If any place starts getting pooled with water and there are solar panels that are placed there, then those panels are going to short circuit, that entire block or that string is going to go offline, and this entire solar business, it's very dependent on people being able to supply power continuously. So they need to ensure that such things do not happen. So every solar utility solar player is basically taking our help to estimate where floods can happen, how badly it can get, and what are the mitigation measures they need to take considering those scenarios, right? So that's where like we have Bosch, Renew, Spring, all of these guys, right? Yeah, so that's just a look at all of the sectors, right? So we have in Skylark drones. So this is a little bit about us, right? That's all. Yeah, thank you. If there's any questions, I'd be very happy to take them. Not necessarily only at night, sir. So thermal sensors, we can use them for detecting intruders at the night, right? That is one use case. Second use case is you actually point the thermal sensor at the solar panels. Now the solar panels, if they are defective or for whatever reason they are not generating energy, they will heat up, and that heating up is not visible to the naked eye. So I can actually identify whether a panel is defective, what defect also it has taken, I can estimate based on the heat signatures I am seeing, right? In transmission towers, essentially if there is a insulator defect or somewhere a short circuit or something might be happening, that starts heating up first before the dielectric breakdown happens, right? So that again can be seen on a thermal sensor. That doesn't, so that can be done either in the day or the night, right? Because the temperature increase is independent of whether there is sunlight or not. Yes, sir. Not necessary, sir. For buildings, we don't. Thermal scanning is used for
thermal sensors.
Typically not used, sir. At least like so far we haven't gotten to that use case.
For laser scanning purpose, any special purpose drones are there? Or?
Yes, sir. So if we want to do laser, so when we are doing building survey, no, sir, there are two ways we can do this. One is using an RGB camera itself, and you capture images from multiple angles, then use software to reconstruct the entire thing in 3D. That is a cheaper way of doing it, but the accuracy might be slightly lesser, right? So the accuracy there you will be looking at is going to be some plus or minus 10 centimeter variation. Now, in certain cases, you might want very accurate as-built diagrams for a building. In those cases, what we do is we go with a LiDAR sensor, right? So that is very similar to a radar, sir. Essentially, instead of sound waves, you are sending out a beam of light. That light gets reflected, and depending on the time of light, I will get to know, you know what, I have a surface there. So that is highly accurate, and that you can get a plus or minus 2.5 to plus or minus 3 centimeter accuracy there. So that is very useful for all of these engineering measurements. When you need to create as-built diagrams, when you need to go ahead and say, you know what, this is as it is today, I have only X amount of clearance for me to create a new corridor, things like that. Right? So that is a separate payload, sir. That is again on the drone itself. It's attached to the drone. Only thing is the underlying technology is different.
The LiDAR camera, that is a change.
Yes, sir.
The drone remains same.
Drone remains the same. Okay. Now actually, sir, that's a half truth. The drone might slightly vary because the LiDAR payload is typically heavier. Right? If I take one typical LiDAR camera, it is going to be around 1.5 to 2 kilos in weight. So the smaller drones that you might have seen flying for these marriages and all, those cannot take this weight, right? So for that, slightly more robust drones will be there. But that more robust drone can be having a normal RGB camera as well, right? So depending on the use case, like there are pre-built drones where everything is integrated, Or you can have a drone where you can swap out, right? Instead of one normal camera, put one thermal camera. Instead of thermal camera, you put one laser camera. Things like that, sir.
For as-built creation and all, we will be requiring in millimeter-wise accuracy.
Yes, sir.
Not
Yes, sir.
in centimeters.
So for that purpose, sir, like there are those terrestrial laser scanners, right? The issue is, sir, like those will take a lot of time. So if you are looking at sub-centimeter accuracy, then drone-based LiDAR is not the solution for that, sir, right? So drone-based LiDAR is going to be useful for, let's say, like talking about railways or roadways, what is the as-built, where plus or minus 2 centimeters is acceptable to them, right? In a building where you want to get sub-centimeter accuracy, because then all the architectural plans are going to vary, there still the terrestrial laser scanners make sense, sir.
Terrestrial laser scanners.
Yes, sir. Or those handheld laser scanners are also available. But the most accurate one for getting sub-centimeter is going to be a terrestrial one, sir. It's basically like you set it up with a tripod and you let it scan. The handheld ones, because they are moving, the system accuracy slightly reduces. Again, it becomes more.
Both are not applicable for high-rise buildings. Both are stationed at the ground level.
Yes, sir.
But if you want to take high-rise building, the terrace
Yes,
scanning and all, facade and all.
Yes, sir. Yes, sir. So there, I mean, there is a trade-off, sir, in terms of accuracy, in terms of this. There are drone payloads which can get you sub-centimeter, but our experience has been, sir, that the cost it brings, because it's very, I would say, state-of-the-art payloads, right? You need to import it from some company in Switzerland. So there, the cost basically starts overriding the acceptable accuracy. So most people at that point say, you know what, plus or minus 2 centimeters, okay, you please scan this and give it to us if it is that, right? Like same thing we had done for a company where they have a conveyor belt, sir. The conveyor belt is basically feeding material into their coal processing plant, right? So the conveyor belt is at a height of some 15-20 meters. Now they wanted to understand what exactly is happening there, how much space or how much clearance do I have if I want to create another pipeline below it, right? So their handheld scanner or a terrestrial scanner could not work, similar to how in a high-rise building we can't do, right? So we used a drone scanner, right? And of course, we said the trade-off is you're going to get plus or minus 2 centimeter accuracy, 2.5. And they were okay with it. So that's an engineering tolerance they decided to take in terms of the pipeline they're actually designing.
One last question, do you provide a rental basis, these drones?
Sir, since these are like quite expensive, instead of a rental, we can provide a service, sir. Our guy will come and scan whatever area.
Technician.
Yeah.
Technician.
Yes, yes, sir. We can send our people there and we can do that.
How much it charges per day or per hour basis?
That I'll actually have to speak to a commercial team, sir.
We'll contact you.
Yes, yes, sir. I think, yeah, our numbers are available here, sir. You can just get in touch with us. Yes, sir. So in terms of the ore, we are not able to this thing, sir. Issue is, yeah. Yes, sir. We can estimate the volume of excavation. We can also tell a mine manager, you know what, like this is the ore body model you have given us. Currently, your mining is progressing in this grade, right? So it is more of a interpolated value because the drone by itself is not able to see what the ore body is. Yes, sir. Yes, sir. That is you know, that is a limitation of the technology currently. Today there is no way for anyone to actually peer under the earth very accurately. So the aerial solutions today, right? They are called aeromagnetic and multispectral, hyperspectral sensors. Now these are very, very specific as to the type of ore they can actually sense, right? But again, they don't do it with a centimeter level accuracy. Rather, they are able to do it at like some 10 or 20 meter accuracy, right? So that is the reason these are used when we are talking about the prospecting side, sir. When before you break the earth, before you decide to actually bid for an area, you do that survey and understand, okay, this might have it, and therefore I'm going to go for it. But the way today everyone is doing an ore body modeling is you need to drill through the earth, get that column out and send it out for lab sampling. You do it at spaced intervals and then you can create an interpolated surface which tells an estimate of where the grades are changing, right? In the earth, like you rightly mentioned, sir. So if I say like from here to here, it's going like this. In between, if it is suddenly having a intrusion, that cannot be detected today.
We wanted to record the transportation activity that's happening within the neighborhood in an urban area. So we want to, we want the drones to be kept in the flight mode only, like at one stationary location, and then we want to observe the traffic, how it is being segregated also within the different roads also.
Yeah.
So in that particular case, what is the complexities that we face while stitching the videos? Suppose because one drone, and if you want a good clarity, we can't, one drone can't be possible. So we wanted to also record it in the peak hours and non-peak hours. So what are the complexities I will be facing while stitching the videos or something like that?
Yeah. So for this particular use case, right, ma'am, one of the things is you can't have just one drone doing this because you are looking at multiple things, right? A drone has a fixed field of view, and the higher you go, like basically more area you are covering, similar to the satellites, right? So now coming to your use case, right? If you want a drone to always be flying, right? That's the first complexity, because all of these drones typically have like 45-minute to 1 hour flight time, right? So if you want something in the air for a longer time, there is something called a tethered drone. Essentially, there's a wire that actually goes up there, and it is feeding the drone at all times, right? So that is like the first complexity which you'll need to overcome in the system design. The second complexity is what exactly are you trying to track, right? You are trying to track what is the
traffic densities.
Traffic densities.
Yeah, how much of the traffic is incoming and how it is segregated within the interior roads.
Correct.
So
for this, right, you essentially need to have a time series data, right? So here you can either do a video or a photo, right? The issue is you don't really need to stitch this, right? Because when you're stitching all of these things, it relies on something called tie points or key points, the commonalities which are present in one image or one frame with the next one. In a densely trafficked area, things are always moving. So when you try to stitch something, wherever there is high movement, you'll see holes, because common points software is not able to capture, right? So the approach to this would not be like stitching. Rather, the approach to this would have to be something like, you know what, I'm having a drone, I'm pointing it at so and so area, and since I want to look at multiple areas, let's say like entrance or roads that are feeding into one junction, and how it is coming out from one junction, right? So you can potentially have like multiple drones, multiple tethered drones, so that you are looking from the top continuously and you are feeding it out, right? So that's where the third complexity comes in. How much data can the onboard drone actually, onboard storage on the drone hold, right? So that's where you essentially need to keep streaming it out onto a network storage, maybe a network storage, maybe a server, whatever, right? And essentially keep it in a way where you can use it later to understand what exactly is happening at any given time frame, any given, like everything has to be geotagged, so you know exactly where it is. Everything needs to be having a timestamp, so you know when it was, right? So these are like some 3 high-level challenges I can anticipate. As we go deeper and deeper, there's going to be more and more, right? Like,
I was just talking about that gap that you have mentioned.
Yeah.
So in case if there is some algorithm or something that could
this currently, some change detection algorithms are mainly used. These are generic change detection algorithms where it's just looking at an image. It kind of understands like whether it is the same scene or not across multiple things, and says like from time X to time Y, or between frame 1 to frame 2, so and so has been the change, right? So you'll have to have one more level of algorithm on it. When something has changed, what are the objects that entered the frame or exited the frame, right? So you'll need to merge like
maybe
a scene change detection.
Features, I think we could put it as the stationary if for the change, and that would suffer.
Correct. So this is not something like which is, I would say, commercially available today, very much in the research domain. The way I see it is you will have to have multiple levels of computer vision, looking at scene change detection, pattern recognition, object detection. Yes. Right. Maybe have some level of segmentation so that the object detection can be better.
Yeah, that's what.
Yeah. Is that something you're working on?
Yes, sir.
Oh, nice. Oh, I'd love to know more.
Sure, sir.
Yeah.
Actually, we wanted to integrate that with the pollution, I mean the carbon sequestration also, which has been done in the neighborhood. So we want to see what is the carbon, I mean that is not sequestered and emitted like that only because of the transportation and all.
So I think one thing which can potentially help you there are these payloads, they're called like e-sniffers, right? They actually tell like what is the level of pollution for particular pollutants, say SO2, say CH4, things like this, right? So you can potentially mount it on a drone, have it like fly across different regions at different times.
What is the weight? I mean that sensor you are taking, I mean that could sense the pollution.
It can sense like ppm levels of particular chemicals.
So those sensors are currently available with Skylark?
I mean, we don't have it. We have like, we know a guy who has like, we were working on something for methane detection.
Yeah. Okay.
Yeah. I mean, we can like possibly check with our guy there and
sure, so that would be great to know.
Yeah.
Thank you so much, sir.
Thank you very much, Shreyas Naikji. On behalf of all of us present here, big round of applause to Shreyas for delivering such a presentation, wonderful presentation. Thank you. So now we have the last session of this workshop. So now I invite our Professor Chandrasekhar Biradar sir to dais. Sir, please. Welcome, sir, on behalf of KSTA and on behalf of Manage and all the delegates. Before starting this last session, I would like to give a brief introduction about Professor Dr. Chandrasekhar M. Biradar, sir, who is a CMD of Earth System Scientist and CMD of Global Green Growth Corporate. Sir is a distinguished Earth System Scientist, founder and green growth leader with over 3 decades of experience in ecosystem research, development and outreach. His walk the talk work spans diverse landscapes across Asia, Middle East, Eurasia, Africa and the Americas, emphasizing inclusive system approach, regenerative agroecosystems, drylands and rain-fed areas, agroforestry, forgotten foods and food forests, land restoration, and spring sheds, digital augmentation, agroforestry, and artificial intelligence, green energy, carbon sequestration, climate resilience, with a multidisciplinary background in agriculture, forestry, environmental sciences, biodiversity, big data, AI, and space applications. Dr. Biradar sir has held a scientific and leadership positions in various global and international organizations, including several CGIAR centers, US universities, and global institutions. His expertise encompasses system modeling, functional production, and harnessing nature's infinite potential for improving the land, water, food, and environment, which eradicate rural poverty and hunger, off-the-grid living, farm as resorts, and resilient livelihood towards net zero transition. Dr. Biradar sir has published over 450 research articles, tools, products, and trailblazer impacts, garnering numerous national and international awards as a scientific advisor and board member for prestigious foundations, institutions, and governments. He champions regenerative landscapes and sustainable livelihoods for green economic growth towards achieving One Health and net zero. And sir is also nominated a KSTA member. With this brief introduction, I welcome you once again, sir, to deliver this session. Thank you, sir.
Put this way. Okay. There. Okay. Okay. ಹಿಂಗೆ ಇರ್ಬೇಕಿದೆ
ಅಂದರೆ ಇದು ಆಗ್ತಾ ಈಗ ಟ್ರೈ ಮಾಡಿ ಸರ್ ಸೆಕೆಂಡ್ ಒಂದು ಬಟನ್
ನೋಡಿ
ಆಯ್ತು ಪ್ರಾಬ್ಲಮ್ ಆಗ್ತದೆ ಅದಕ್ಕೆ ಹಿಂಗೆ ಮಾಡಿದೆ
ಹಂಗೆ ಓಕೆ ಸರಿ ಪರವಾಗಿಲ್ಲ ನಾನು ಆಗುತ್ತಲ್ಲ
ಆಗ್ತಾಯಿಲ್ಲ ಸೆಕೆಂಡ್ ಒನ್
ಅಥವಾ ಐ ಕ್ಯಾನ್ ಯೂಸ್ ದಿಸ್ ಒನ್ ಸೊ ಐ ಕ್ಯಾನ್ ಯೂಸ್ ದಿಸ್ ಬೆಟರ್ ಐ ಕ್ಯಾನ್ ಯೂಸ್ ದಿಸ್ ಒನ್ ಇಟ್ಸ್ ಈಸಿ So good afternoon. I am sure last 3 days, I am about a 3-day, third day now. I'm sure you come across the most of the drone technology platform applications. You're not hearing? How about now better? Okay. And yeah, good afternoon again. So you have a good lunch looks like. So, I know it's always after, so I'm Shreyas managed to keep you wake up after the lunch, and it's good presentation. And I know it's, how was the last 3 days, all the presentations? Very useful, informative? Yeah?
We will invite them for feedback during validation.
I'm sure, like, so just making sure that I'm going to speak, so it shouldn't be like, I'm not going to touch all the basics of the drone. Instead of that, I just go through some of the key aspects what we are doing, and definitely you know much better than me now on the drone side. We're going through the context. I'll put it that the drone is are more than just sprayers, because when I came to India, I heard the drone is mostly the sprayers, and drone viewpoints and get the better choices in different decision making, from agriculture research to the reforestations to the impact assessment, carbon sequestrations. And inclusive development is very necessary. Often we look into the end user application segment. If there's a large number of the drone sprays, and most of the industry look into the spray drones, and often neglecting the other uses of the drones. And also we need to link into the lot of the schemes going across the India, whether state level or the central level, and how best these drones really fit into that landscape. And then the drone supports for the high fives. I always call it that any sustainable landscape and sustainable development is going to happen. It's around the biodiversity, the diversity of the everything. There are people, culture, traditions, agriculture, nature. So diversity leads to more what called environmental sustainability, carbon sequestrations. That in turn really add a value to the what we call a hydrology, water cycle, climate regulations. That leads to what called natural productivity and inclusiveness. That's what I call a 5 highs. And working the different landscape of the world, nearly about 68 countries, and those are landscape I covered during the, not just visiting the place, but going to the field, done the field work and understand the landscape, what is happening there. It's very clear that India heading towards the 3rd or 4th largest economy of the world. And of course, we have a lot of challenges. We are nearly about 16 to 17% of the world populations, with only the 4% of the land area and natural resources. So that is a tremendous pressure on our landscape, our future, where we're heading on that direction. So in that sense, the government is very clearly put that one, what would be the transition pathway. Okay. So I use the mouse better. So it's very clear that the industrial revolutions, what happened in the, it's okay. It's fine, otherwise I can use the mouse, no issue. It's fine, no problem. You can use the mouse, okay. Yes. So that, what happened in the post-independence, and we cleared a lot of landscape. We lost nearly about 85% of the green cover in the agriculture areas, and that really put a huge pressure on that. If you're not taken any effort, would have been reached almost like a disaster there. But some effort, what you call conservation effort, we have to reach to about +2 degrees. That is still, we call it as unsustainable way. But in order to make it a 1 degree cooler, we need to bend the curve. This is very clear on that. So in order to do that one, so by 2030, there's our target of India is about 33% green cover across the landscape, and 2047 Atmanirbhar Bharat, and 2070 net zero. That means everything we're doing, whether the food productions, cloth, agriculture, development, transport, that should be the net zero. That means there is no impact on the environment. Is that possible? So how best we can do that? So we have to ultimately have to go there, otherwise we are already crossed the offshoot of the sustainability boundary conditions. So when I map the entire India of the tree deficit landscape, so it's very clear that most of the agriculture areas and all the brown areas, you can see that they're the tree deficit areas. The required number of the tree cover must be there in order to be the environmentally sustainable, ecologically viable. That's not there. So there's our mandate is very clear that we are looking into the technological development, infrastructure development, all are required, but at the cost of the environment that can be reduced drastically. So we're looking at this in the main framework. So we talk about the functional production systems. In the past, we were looking more into productivity only, economic aspect, not into environmental aspects, so that you have to bring the Green Deal that has a diversified landscape, better food productivity, landscape management, and how that you can link it to the economic well-being. I think this is where we need to look into every aspect we are doing, whether the energy, whether the economic transitions, whether region, the agriculture, carbon, functional food systems, and it's all interlinked to each other. So this is where we need a technology, a sensor, either in the space, either in the ground, or in midway to monitor what is happening, right? So that's what you come into the Earth observation systems, a remote sensing the systems. That's what the India is pioneering into several satellites they launched. And our advances in the big data, remote sensing, geoagro, and ICTs enabled technology, so that we have to bring the technology everywhere, whether it's agroforestry, horticulture, river flow, hydrology, climate change, so that you can able to understand the Earth systems better. In the Pathfinder missions where we were earlier working in NASA, so it put so much effort, money into the studying the outer space, then they found that we not did anything enough on the Earth. So that's where the Landsat Pathfinder mission, they started looking into the Earth rather than the outer space. That's the remote sensing birth of remote sensing satellite. So that's where the series of the satellites launched for monitoring Earth space. And the change is happening, whether below the ground, we have what's called the gray satellites, gravity satellite, understand what is happening beneath the Earth surfaces and the water movement, to the toposphere, what is happening to aerosol particles on the surface, the ground cover. This is where we're looking at mostly in the Earth observation satellites. And this is my journey began with putting the different sensors, understanding the vegetation dynamics in the Midwest of the US, to understand that what is happening in the Cosmos rover in the soil moisture into the atmospheric temperature boundary conditions. So bring them together in the cognitive way, and so that you can understand what is happening in the Earth surfaces, whether water, whether food, whether temperature, whether climate, and even changing the land cover changes, how they're going to impact. So this is where, so we start looking into the satellite. Of course, a little bit on the aerial photographies, that is very early. Then, but when the drones became a very easy and economically viable and easy for carrying or putting a sensor, so that's took over the most of the aerial pictures. When earlier in the CG systems, when IITO wanted to do the hyperspectral remote sensing, we purchased a very expensive plane, then dig the hole, putting the sensor. That's become so pathetic, though we're not able to even fly the plane because of the aerodynamic changes. So that kind of the efficiency happens. So these are our team, and very pioneer, the professors, heads of the divisions, and the very pioneering people. Really, they put together effort. No, let's put something the very effective way to monitor the vegetation, what's happening in the climate change. That's in our lab in almost like 2012. We started setting up the passive active sensors on the ground and linking it to the remote sensing and satellite data and drone to see that how we can link the ground observations to the satellite, and drone can provide the kind of a well calibrations to understand the pixel variabilities across the scale. We did, in fact, a lot of the effort we done, so using the kites and small flights and air balloons and drones and sensors. Amount of the money we spend on that one to understand the quantify what is happening on the Earth's surface is enormous. So there is a journey of the 2007, 8, 9, 10, then equal to the 13. So that is this where I came to the CG system again back, the consultant group Intensive Agriculture Research, where we started the birth of the drone in agriculture, especially hyperspectral sensors, understanding the smallholder yield gaps, yield potential, and net value, worth of the value of the land. So that's where it started. And later, so we did the one very large scale experiment in Odisha, and in 15 to map the rice fallow dynamics and how best you can intensify the sustainable intensive agriculture areas. And this is where then for 22 we also did something with IRI. They're doing something the hyperspectral sensors and multispectral sensors. So this is where a lot of the variations took place from the how difficult we are getting the drone. Even at that time, we were not supposed to call the drone. We used to call it unmanned agriculture vehicles because of the permission issues, something that when you call the drone, it usually go to the militaries, and they're not giving the approval. So that we're taking the research-oriented, the research and research-specific, and specific to particular location only we're using the drone. That's how we used to acquire the drones. And it's very clear that you all already heard about these things. So the projected, the commercial drone revenues worldwide from the 16 to 25, it says $1 million. That is very massive. How the look at the growth of the drone is happening. In fact, that time I was presenting about 5 years ago in the big data committee across the globe, and at the Mountain View, where the Bill Gates invited the group of the scientists coming to the Gates office, where the Microsoft, looking into what are the potential of agriculture, how the technology, whether the software, whether the applications, whether the big machine learning that can help that one. That time the projected that it's similar to the kind of the smartphones. Everyone is going to use the drone in the one or other way. And among the industries, it's very clear after infrastructures, that what Suresh was talking about earlier, and the agriculture and forestry and environmental sciences, they are taking the very gain. And number of ways, where the crop incidence to the understand the disease and pest risk, are going to do the better way. And industry very big, right? That's what the studies, the figure I was searching on that one. So there's a massive industry growth is going to happen. But does that really help the society in the science and transition pathway for net zero for India? So that's where, so this is the future generations we're talking about. So by the way, this is the drone. So last the control is fell down, the villager took over, and the children were playing it. So this is how they took the picture of that. So this is the now very interesting the pathway. And now the children's, my son, they fly the drones more efficiently than me. So they have the very intrinsic value. So they think about what we drone for. I thought that the response is that, oh, maybe taking the pictures. They thought that they are a completely different way of thinking, the children's. I wanted to use the drone to go to school. I want to do something to buy something or pick the mango. So those are the innovative children's that thinking about ask the drone, right? That is the cognitive learning we have to inculcate among the children's. So that from the village level, children know the drone, what is now, what is the Google map is now, what is the Earth observation is, what is the geotagging is now. And that's really going to change the pathway. I just recalling about 15 years ago when I was in my village, so that my grandfathers, people, the panchayat, they're sitting there. So what do I do? They ask the simple questions. I said I work with NASA and ISRO and like a satellite mapping and something like that. They couldn't understand anything about the map, anything, because that time Google Map was not yet launched, right? So still satellite data, Google Earth, something no one is know that time, almost like a 20 years ago, 18 years ago. I told that no, we'll, that time I was also working with the TRMM, Tropical Rainfall Monitoring Missions. That's what you might have heard about that movie, Swadesh, or the same, the satellite mission. I told that we also help predict the rainfall Then immediately the one of the guys sitting there asked that, okay, it's going to rain tomorrow or today. I was just baffled. No, we cannot do that way. We'll just the long-term projections, so those things we do it. Then immediately ask the one person sitting there, hey Tama, so can you tell me the Mali Barta illa anta? So he asked me Kannada. That guy is he's the monk, sitting there. He looked at the sky. No, Babuji, it's not going to rain today. Then immediately Papa turned at me, look at whatever you study is useless. The guy know that the rain not going to today, you're not able to tell. That time I realized that one. So how really they think in the different sense. And this is where really what is called a local sense is very important. Same thing, we are doing that calibration of the sensor in Africa. The lady suddenly come and removing all their grains there by drying. They said there's going to rain. We have no clue of the rain, but rain happened. So this is the way that local sense, intelligence, how best you can tweak into what land use pattern changing, how that really going to help that one. That's the reason. So you might, so children's who have sense of that what's happening if they connected to the nature, and from that village level story to a global big, the guy coming to frequently to India to understand what the Indian drone mechanism is going on, so that. This is the Bill Gates visited the IRI so the year ago, and up that he frequently. So then a lot of the drone events happened. So that my focus is then how drone can really bring you to the green economic transition. So the year ago, so we had a very big the drone summit here in Bangalore. So there's a lot of people talking about that. So very clear that whether you can look into the global level landscape as India as a one subcontinent, or come to the farm and subspecies and individual species at genome level. The drone can help anyway. So yes, it is. So we started looking into someone I told that when mapping the satellite, what is happening in the cropping type, crop calendar, and change the dynamics, and even yield predictions is going to happen. But I say that even you should go further to the genome level, genetic sequence level. I said, how was possible? So that's where we started looking to the more depth of the spectral signature, biospectral signature. I'm sure you might in the last couple of days you went through very clearly on that. So when you put the hyperspectral signature in the full spectrum, and this is what you can see that what are the RGBs. I'm just talking about the little RGB here. You can look at the variations and look into the near infrared how much variation is there. And one species to the other species, it's like a rain-fed rice, you can see, and supplement irrigated rice and irrigated rice. So 3 crops of comparison, that one, what's called the biological, physiological condition in the plant and response to the stress condition in the water availability. Then looking into the water absorption points, when to irrigate, what is the critical point to irrigate. So this is where we started exploring very clearly. You can look at this one. So you may not see a big difference here, but the moment you can bring infrared, that is the sensitivity of the vegetation is much higher. And even see that which is the critical time of the gap is going to yield what's called the flag end of the vegetation cycles are really rapidly growing. So that giving the irrigations, maybe you can skip the irrigations somewhere in the early stages, but you cannot skip that particular the high atmospheric window, what you call the boundary conditions, as well as the water absorption, the point. So that you can avoid the irrigation, sometimes even crop stress conditions, but the antithesis period, a grain filling, shifting that irrigation there, yield will increase even the same amount of the water, right? So that kind of insight into the reflectance properties, what's happening with the leaf, as a self structure, as a pigments, as a water content, I think that makes a lot of the sense. So started looking into deep into this, the inherent properties of the sunlight falling on the leaf and absorption, reflectance, and that how best the energy absorbed by the sensor again. So that's make the huge difference. So started looking into the biophysical, spectral, and the genetic varieties within this one, and taking the common the sensor among the different platform, try to understand the Q about the vegetations, whether leaf area index or the leafy pigments or the LS water content. You can bring into the whole analytical framework, you know that how that scale of the pixel and the timing of the pixel. So that make a huge difference, along with the atmospheric boundary conditions and aerosol particle in the atmosphere and pollutions and sun angle. All that makes a huge difference. Now, so try to understand, standardize what is the best way to take a picture. So as you see, most of the satellite, they passes around 10:30 or something and 1:30 in the afternoon. And we have to design your experiment to pass the same time what the satellite passes. So then only you can calibrate very well. So it took a long time to understand that, how the atmospheric boundary can go to impact on the sensor calibrations. Then you started looking into all the Earth observation satellite. It's a massive load of the satellites sitting there. And most of them are even free. So how best you can use them to understand the Earth boundary conditions, data use applications. This is where we're looking into the digital augmentations, combining that big data and science and citizen science to bring them together. That time when we're not using the word AI, using the big data, the machine learning and deep learning. So this is where started into until we geo-reference what is our reference point, and remote sensing usually called nonsense. So that's the calibrations required, and started putting them together. And this is where the framework you talk about, that one like a systems research, sustainable framework and digital augmentations. How best you can connect the science, technology, and producer, consumers, and institutions in the framework so that you can address the sustainable development goal in one way. This is where we started exploring further into the hyperspectral, multispectral, thermal, and ultraspatial the data. And in fact, that research we started in the hyperspectral signature of the 20 wheat varieties and some medicagos and tomatoes. That's where my trigger is the one of the guys selling about 20 different types of the tomatoes. And he is supposed to bring to the market, and his granddaughter removed all the labels to play. And in US, because of without label, you cannot sell the tomatoes. He was so upset. I went there, what has happened to the Rob? No, my granddaughter removed the labels, I cannot sell this one. Then I said, can you do something remote sensing here? So I collected his one or two tomato plants, took the hyperspectral, AST hyperspectral sensing, I can plotted them. Very interestingly, they all are different. Even they look tomato same, but they are different in the spectral signature. So then went back to the field where the experimental, he's usually growing the tomatoes. We took the signature there. When signature matching we done, we identify most of the tomatoes. They are different. Of course, we failed some of them. So this is where really started interesting that can you use that one for the breeding and coming with the different traits. So we did something like different experimental cubes, and in fact, we put something like Ikada was some camera, we put a very huge, this room size balloon just to take a small camera, load up, but then to move to the hyperspectral signature to understand that how the field level, condition that what is the experimental field. So different trials are going, that how they respond to the varietal variabilities, so that we can bring it, invested quite a bit. At that time, when I bought this hyperspectral sensor, it's about $47,000. Nearly 45 lakhs. I don't know how much is it now. Small one like this. So this is where is birth of the digital platform, combining the satellite, the drone, and the ground observations, and a lot of the ground to thing data. So I come out to the different the machine learning algorithms and classify the on-the-fly demand-driven Korean clusters to make sure that what is the yield, the individual farm level. Why one farmer yield is next to me is so much differences. What is happening there? We're trying to understand, is a weed, is a crop, is a variety. So that's where a lot of the experience comes together. And this is where the precision mapping and resilience to understand what's happening at the ground level. Then there comes the question that always challenge is when you go to breeding and going to the politics and going to the policymaker. But you are telling this one, but you're spending a lot of the money. So is that worth to the spending on that? So I started looking into the economics of the drone applications, putting the different high resolution satellite data, multispectral satellite data, then looking into that one, finger fitting the farming systems. And guess what is this data? Anyone can tell? And what is the field? Can you be able to guess it? Pardon me? No. Yeah. These are all the rice fields. Notice it. And why they differ color? All the rice. Yes. This number of because staggered planting, Someone is, they are still not harvested full vegetation growth. Somewhere they left the fallow, somewhere they burned the field. So then also staggered planting, early rice, mid rice, late rice. So all the things, look into that for us as human beings, stand out, look at it, how is all rice field. But every rice field, when I took the signature of this individual farm, plotted, they all are different. That's called fingerprinting. Every rice field, every farmer, every field different in terms of the management, in terms of the soil condition, in terms of the weed management, crop they're growing, when they're planting, staggered planting. You pull them all together, agronomic and agricultural practices, each standout is unique. But can you design something that unique addressing that? So this is where I started looking into the, one is general mapping of all the rice, but when I started looking into what's called uniformity in terms of the biophysical conditions, in terms of the given inputs. So when I map that one, their complete picture is completely. So this cluster is become seems to be very informative in terms of the niche. It's called biological condition niche. And somewhere is even field is very big, but so much variability is there in the field because of the weed, the puddling, other thing activities. So this is where the kind of insight when you do the precision farming to understand also the niche specific mapping. Particular given location, what are the species can grow without inputs. That's called the niche mapping. And this is when I did some small experiment when the MP and UP is talking about that wanted to do the tree planting, right? So the Prime Minister announced the her made per paid and wanted to see that where the field is there. Then first answer was that, sir, you not any land to plant a tree. Then I started mapping the field boundaries like this. And the small district, Devas district in MP, the length of the farm boundaries nearly about 2 lakh kilometers. And trees on the bunds, if you plant the 4 meter, 2 meter this side, 2 meter this side, and at about 18% green cover. In order to meet our India's target of the 30%, we require just 1/3 of that plantings to be done. So look into all the roads and rail infrastructure, nearly the 6 million kilometer length of the major rivers and canals, that much of the length, and wastelands. So look at the land available to plant trees. So this is where you need to be looking. So the ground truthing of the data, the UAV and drones really help us to understand what are things happening in the ground, farm level, field level, condition, what is growing on that. So you can bring that together into the analytical framework, a real-time rice paddy mapping, what we did for the entire India as well as the Odisha, West Bengal, to understand what's really happening there. Right? You can look into the crop fallows, cropping intensity, phenology, and the length of the fallows, and start date, end date, when the crop start, when the ending. So understanding that variability is in the crop phenology, crop calendar. You know the window, gap window, how best you can best use of that window. For a rice harvested, most of the rice is left fallow, not using it. Even sometimes the second crop, but in between there's a window gap is there. Or how much window gap is there? Can you go the extra early lentils or pulses, the leaf vegetables. So that really helps us to bring a farmer income of hardly making 8,000 to 36 to 45,000, just understanding the land changes. So, but of course, there's a challenge again coming that what is the economics of these things. So I think these old figures, you maybe you have better figure now. And when you use the satellite data and what would the cost processing and like a sensor, spatial data, temporal, and processing in terms of how much of man-hour required, computer required, processing time, overall. So all things look at it, and the cost is comes to the UAV drone, it'll about $100 per square kilometer. It's quite expensive. Maybe is that better now? For the drone expert, Shreyas, how much is the cost per square kilometer now?
It depends on the resolution.
Depends on the resolutions you are flying, right? So that's
400 rupees is the ongoing market.
400. Yeah, that's quite cheaper, right? That's quite cheaper than the 5 years, 10 years ago. So, but still, we cannot, whatever the cost is there, but the amount of that return you are turning in terms of the electrical wire monitoring or the solar panel monitoring, the road development. Now, our colleagues, couple of this, I saw that the now Nitin Gadkari is our ministers asked that one to he wanted a daily report on progress of the road going on. So they fly the drone, they check this month to this month, how much is they gone, how much of the land is damaged nearby. So get the report on daily basis to understand that progress what's happening. I think this is what ex ante and the impact assessment of the things is going on the real time that makes a huge difference. You sit in the screen, big screen, look into all the project is going on that, so you know what is progress in the real time, you can see that. Something is stopped, nothing is moving, there is a dot comes that one, this progress is not happening in the last 3 hours or 1 hour or 1 day, you can immediately trigger that, so what's happening there. So that kind of the things are really happening in the real-time basis. And of course, there's a lot of challenges and opportunities comes in. And the scale you are looking at it, how details you want it, how frequently you want it, that makes the scale differences. And whether you can look into higher spectral signature, they're trying to understand that. Just want this simple RGB or infrared and understand the varieties of things. In fact, like one of the very striking this wheat, the sequestrations identifying the drought tolerant wheat, and we use this spectral signature to come out with that irrigated rice and wheat, the irrigated and the rain-fed rice, and we really strike out that there is the difference. The water stress condition, they're going to change that one. We pick up these rice varieties, then they do the DNA analysis. They found that those are the really good one. So rapidly we can able to do that. Of course, require some validation further they do it, but large scale screening, it's one of the the plant phenomics became one of the best things to do it. So this is what I'm bringing back. Also the growth monitoring, that's like so using the drone in the fixed point in the field, so you can taking there and taking the picture at different levels and see that how the progression happening that one. The looking at the plant growth, different stages, and how that growth is changing, and which particular the band changing, crossing across, and what time they're crossing, so that you can able to understand the critical physiological the barriers that can be addressed easily in the long-term basis. So there are a lot of the advances happening that one sensors and even spectral cubes, and all that 350 to 175 channels. In this one, like in the OCI one is we are about 2 sensors on the up to 100 and 1000, and these are individual the channels, what you call spectrum. Then see that understanding this cube also you can able to see which particular band you can able to make a big difference, so that you can apply into the field conditions. And this is where this is my friend Ravi from the IRI. So they're bringing it to the field phenotyping using the AI remote sensing. That's very, very fascinating thing that what's happening in the field conditions. Look into their different the reflectance parameters, all the germplasm and put in one locations. Screening, just take one snapshot, immediately you can do the 60 to 70% screening. Oh, these are the best, these are bad, something like that. And also the individual farm level yield gaps. So this one, the colleagues during our CZ level innovations in drone, and look at the simple RGB, and look into the when I understand that the multispectral and hyperspectral, how much the variation is there, right? So this kind of the really helps us to understand even disease and pest damages, volume of the damage happening that one. So look at the hopper, the burn spot, and that put in the 3D way, same picture, the assessment, you put in 3D, one crop collapses, those can be assessed. And to the now, carbon market is evolving so rapidly, and even the soil carbon and carbon in the vegetation, in the trees, in the regional agricultural practices, multifunctional forestry, how much of the carbon we are there. So we did this experiment in Haryana, so taking the different sensors and trying to map the vegetations and cover, canopy, total green biomass, dry biomass, total carbon sequestrations. So that individual tree level, how much of the individual carbon sequestration happens, and which is the most potential tree to sequester more carbon. Something like that can be done to do the for carbon farming assessment to the ecosystem level. I took all the India's the major crops, whether cotton, millets, and the sorghum, and how much the monoculture is there, how much the water losses happen there, how much the agroecosystem can save that, transforming to the monocropping to the sustainable agricultural practices, soil erosion, how much it reduces, total carbon sequestration by the individual crops and shifted from the monocropping to the multi-cropping systems. So I think these are the kind of assessment that really helps. And good thing about India is one of the most advanced digital country in the world in terms of the leverage of the technology, access to the rural level. Even US, some of the remote villages, they not have a optical fiber that India has. This is the real, the what you call a strength of the India. And our payment systems, digital pay, what you call UPI pay, I think that's one of the best in the world in terms of the accessibilities. Even small, that coconut farmer, coconut guy selling a coconut just outside the gate, he has the QR code on the coconut, the trolley, right? So that shows that how much is that. And we did recently the digital, the ecosystem for innovations agriculture, and the amount of farmers, but the farm holding is less than the 2 acres, 1.5 to 2.5 acres. And there is a huge, the good thing for us that is diversity is there, and how best you can turn. And while we're acquiring a lot of the data from the mobile and the satellites, everything, so that most of that is unstructured, and only structured at a very large, small amount that go to the JITA scales. Massive amount of the scales is coming up. So other day, so this guy, CEO of the GPT, telling that the Indians will always tell that, please, can you do that? Please, they're going to cost him like millions of the processing power. So that is the power of the what you call data flow happens. So this can be bring together the digital augmentations and the different levels, whether you can niche mapping or in-season practices and post-harvesting. Every level we need a data flow and make optimization for the using that, so that we can build an ecologically sustainable, economically viable landscape. I think that's the future of the drone and applications. During our last year is Vanamotsav, everyone planted a tree, right? So that why not you geotag the tree? You can monitor that one, where you planted the trees. We did a small app like a ChatGPT, things with this one. So then people can plant a tree, they can take a picture, then you can rate that one, then you monitor that who planted tree, where is planted. Then you can geotag, monitor that whether the tree is growing or not. So that 2 weeks ago, I was there in the campus. I saw that most of trees survived and doing well. So those kind of the real-time monitoring. When people plant millions of trees in the Vanamotsav or tree planting, are there any mechanism to trace back? Who's planted them? How much the carbon is sequestered? Where there's behavior, health, other things. So that all things can be really done. I think still you can work with people. You can scan this QR code. Any tree plant, you can do that. So also we did the training to all the forest officers, so that they can use geotag, monitor, but will they do it? That's the other question. So we are very clear that the drone applications, AI, machine learning, happening at land, soil, water, food, air, energy, trade, everywhere. But we need to come out to the kind of a meta-analysis, bring them together, so that inclusive process that you can addressing all them together, so that we can reach out. So I know that this is the other. Of course, it's happening in the last several years, but because of the seed, we are looking at like a cutting-edge drones for the regreening and the tree planting, so that you large-scale tree planting. Then now they're putting the pellet, they're throwing the pellet, the seed pellet, they're going into the ground. So it depends on the success rates of the quality of the pelleting they have done, the climate, the weather, all that matters. But really to increase the inaccessible area, so whether you can pelleting, you can plant large quantity of the seeds. And that also we can do a lot of this like a crop monitoring. In fact, like in the irrigated field, you're not able to walk in the field. You want to do the relay cropping or intercropping, we can use this one to plant. Of course, the spraying is, and there are huge applications. It's not only one chemicals, but also all the biopesticides and other plant stimulants. And also the spot application, they're going to drone, particularly what's happening in the field, so they can able to do that. But still, what I assumed about 6-7 years ago, that still is not viable to the farmers to do it. But within 3-4 years, we saw that in the village, the self-help groups, their ladies holding the drone flying. So that's really show that how much of the things. Looks like it is the big leaf, but certainly the way that's encouraging the local innovations coming up. So they're thinking about the drone spray came for nano spray, but now I see that they're applying for a number of other things, not just for the nano spray. So there's an innovation that they come to the local level, they bring a lot of innovations. And yeah, so that's the one, this field, who are doing something, greening the land in Central University. They send the picture standing Next to here, I saw a lot of green. Then I said, what do you want to do the green? There's already so much the green. Then I took the satellite, then I found that it's all empty. How we take the pictures in the ground, how this one, so that we are designing something that turn into the thick forest in the next couple of years. And they simulated the same area and how that looks like. So when you plan it systematically. So his vision is very clear, and we need to move to a more sustainable way. And what we are eating and consuming, whether clothes, food, water, everything, so that should be coming from the sustainable landscape. Right now we are less than 10% that is sustainable. We are surviving on that. We need to be by 2030, at least 30% of the landscape should be that one. And by 2050, at least half of that land should be under a sustainable landscape. So this is where I started this green growth. Is not just about the technology, about how best we can bring the innovations in everything we do. Whether we are food, whether agriculture, whether forestry, is climate, horticulture, and also the energy transitions, so that we can reduce their impact on the environment. We do need the green economic transitions, and we need economic development, but that should be the environmentally friendly, so that now the next economic shift, it's going towards that one. Anything you develop, or any education you learn, or how that your new technology is going to be, less impact on the environment. In the past, we never bothered about that. As long as making it profit, we are looking at the only profit cover. We are ignored the impact on the environment. Now, profit is not looking at this next decade, how much you are reducing impact on the environment. That's all about the green growth. This is the enabling the green economic transition for the tomorrow, make the India a self-sustainable Atmanirbhar Bharat, and become a model for the rest of the world. So innovations were coming in the drone technology, sensor technology, applications, and that can take the lead the world, that because of we are the 365 degrees, growing season means throughout the year do something you can grow, not like the temperate climate, only few months we can grow. Our activities spread across the year, 365 days, so that anything there is sustainable landscape, sustainable management, sustainable living style, mission life, that's what India can take to the world. And this is where production follows functions in the ecological terms. We need to leverage the technologies, science, and diversity, local intelligence, indigenous knowledge, wisdom to restore the lost glory of what the Bharat used to be, and that's what we're towards the Vishwaguru, what you call it as a Sarve Jana Sukhino Bhavantu. Whatever we do, that one is for everyone, and every species around us, we all live together. This is where the technology make a huge difference. Thank you very much. So any questions? Sorry.
Yes.
Wanted to ask.
Thank you very much, sir.
Yes, small, I can ask big also.
Sliding terrains also, like in the mid terrains when it is like
yeah, slopey terrain
yes.
we're talking about.
So
that's why I tell you the one technology is there, is also the seed, type of the seed, the local seed, it should be, and pelleting on that one, right? Now there's Stanford also want to bring the new technology that will, so they're putting the seed pelleting, there is a coiled the bamboo, and they hit the seed, it drill into the ground, right? That's one. Now they come with new pelleting, they put the lot of different pelleting, they hit the ground that like a bullet, so that they enter into the ground. Some they can't fill the surface, right? Now the kind of the surface like a chambal valleys, there's something we plan to try there. So that's where required the local specific conditions, and based on the soil conditions, slope conditions, aspect and rainfall pattern, you have to change the pelleting. It's not about the technology, it's about the pelleting of the seed. So possible there as well. That's what earlier the open seeding they did it, they fly away, then without the pelleting, the birds eat, rodent eats, that's not successful. Now we found that it should be coated in such a way that when the rain comes, only it will opens. Otherwise, open seed they take. This pelleting became more important, and also like a bulleting of the seeds, what they call it, so that so very speed they enter the ground. Sometimes the hard surfaces that can also do that. Yeah. Some people that's coming with directly planting the saplings. They throw sapling from the top during the rainy season. So when rain starting, that they plant there, so you can also do that. So it's slowly evolving, but that required in terms of the large scale
Yes,
the
sir.
planting?
Actually, that was observed in the demanding thing, because most of the farmers, their investment is mostly on the terrain, this thing. So investment mostly goes on that. So if something like this can happen and save the soil erosion also simultaneously like this,
Yeah.
that would be helpful.
That's one, we're encouraging that one, like often when come the trees, we're looking for the something, nothing can grow there. We try to put the trees there. So, but tree has also the more economic value than the crops. We need to understand that. Simple example I'm giving that in the 100 square feet area, this half quarter of that room size, 10 by 10, you go the rice, wheat, any grains, is about 1 kilo to 2 kilo. Take example of the rice. It's about 1 kg, it required about 2,000 to 5,000 liters of water. Even the average area, it produces about 100 square feet area, it's for about 1 to 2 kilo. Same area can produce jackfruit, 150 kilo. Guava, 45 to 50 kilo. So that we need to look into the different dynamics. So that's where often we put the trees as a marginal areas, then expect them to do well. Of course, we can do the good area, there also they do very well. So this is what we want to bring the more trees in the agricultural landscape with economic return and ecological inputs. So all the water fall in India, in the rainfall, 95% goes runoff. There are no trees to absorb them, send them to the ground. I think that's where we change our mindset. So we have to give the equal field for those high productive food trees, what we call. So that's what the interesting, the framework of, and go back to our ancient food systems. What you eat in when you do the fasting, correct? Fruits, nuts, and tubers, what's called. But that's how we used to be the food systems, not the grain. That used to come back. That's where the tree-based food systems is going to the big change.
Sir, in one of your slides, you mentioned GPR technology also for root capturing and the signature. Sir, in the slide you included GPR technology, ground penetrating radar for root extension and mapping also according to the stage of the crop. So currently, where the research is for using GPR and also hyperspectral integration for soil health or soil fertility analysis. So where the research and what is the next stage it would lead?
I did my master's in genetic engineering and tree genetics where we're trying to identify the suitable agroforest species, understand the root depth, so how much they're behaving, whether going the taproot going, the lateral is going, something like that. But in terms of this ground penetrations, radars, everything, so we've not done much here, but in a US lab, where the grazing research laboratory we are doing there, we have the active passive sensors, we are doing that one. And in India, I did most of the one, just the hyperspectral one. We not have that, cannot use that one, but of course, we have the ground radars, they are very good ones, so like I put that one, see that up to 60 centimeters. We did for the soil moisture sensors, but later also that can be used. Some people they're using it for now the plant phenomics people, they're using into the radar, they scans the entire the plant and the root systems. They will sense that how the roots behavior happening that one without even pulling out the plant. So this is happening already. Like in IRI, there's where my friend Ravi Sahu, he's working on the different plant phenomics, high throughput phenotyping, what they're doing the entire scanning of the plant.
Sir, one last question. That was great when you said drones are helpful in giving the calibrated the percentage of the zoom level for the satellite data to the realistic, almost realistic ground data. So how do you think currently the radars can be used? Because radar data sets also and especially for water management and the soil moisture things also, they would be helpful. So how the calibration, because the complexities would be very.
I'm sure when it comes to radar, active remote sensing, and this is quite a bit complex than the optical one, and but when it comes to drone, we will not have much on the radar side. You have, of course, there's a terrain mapping, they are doing it, but HH and VV, vertical and horizontal, the bands, those C-band, other things, they are not really much calibrated as done for the Pulsar and the Sentinel. So there can be done. But I don't know, so who is doing at the moment. Even like a Shak Ahmedabad applications, and they have some the thing that when history is the supposed to launch, some reason they're not went in the mission. There's a couple of the things that are coming up. Like now, recently ISA launched that one biomass mapping. So there's one more coming, very, very high precision, the very high satellite for the biomass mapping. So that's where that is the radars, they're using it heavily.
Thank you so much, sir. It was a great presentation.
Yeah, thank you. Any other questions?
So like many other domains,
Yeah.
you also have some simulation modules here where you simulate and actually see how it's going to grow.
Yeah, no, that's true. We did that one for like when we wanted to do the agroforestry expansion, right? So that not like a crops within 3 months, you know that whether doing better or not. But the trees, we need a longer duration, right? I took the same thing. I presenting that, that crops, right, simulation. So we did for the 1 to 25 years, how the tree growth is happening, the simulations. Why I come to my idea that one, like during in fact, the UROs is our professor, and Abdul Kalam sir also is teaching when I was in the Indian Institute of Remote Sensing. So that's the intrinsic idea that when they moved to the Wings of Fire, you might heard about the book, right? So they're spending a lot of the money on testing the missiles, right? So when the computers evolved so rapidly, when I went in the first my remote sensing that in the RS lab, the entire big room is sitting there, that big machine, just calculating, loading one Landsat satellite. Within a year, then after this big mission, they done that Silicon Graphics, they came to our lab, and we can able to load one satellite data in just one day, right? That's within just a year that the transition happened. Because of that, computational power increased. Now most of the missile testing, we're not going to the Pokhran or somewhere, the desert or ocean. We did everything under simulations. Simulations is 99% correct. Just final testing only go. Earlier we had to do series of tests. Same idea came to me, then I started, why not we do the same thing for the land value, the potential. We started simulating those things. That's really, really interesting. That's where we're doing it for the trees. That can be applied for anywhere. That's what now the genomics, they're looking at the simulations. First they do the computer simulations, look at the number of parameters. We are very clear about the plant physiology, how it grows. Given conditions, we can simulate. So that saved a lot of the money and time. Yeah, that's very interesting. You can do the same thing here. When you get the land, the fragmentation ratios, how it's happening, what is the crop type pattern is coming with the drones, very high accuracy in terms of the spectral signature, spatial, ultra-spatial. You can bring the spatial, spectral together. Then you can simulate what's going to be the land use pattern. Okay, that's a very interesting question. Yeah, please.
I saw the hyperspectral cube that you showed. Sir, just like if I were to take that one logical step forward, essentially if I were to do that for like one entire forest area, would it be possible for me to have, let's say, a forest census of sorts where I know that, this area has like these economically important trees. Just like if I'm doing any road project, then don't allow permission to go there. Right? Is that something that's possible using this?
Well, yeah, that's quite because of the, see, when we did that one, but because of the time they given 1 hour, I removed a lot of the slides. So one of the very phenology of the trees, they did very interesting work that they took the canopy. My one of the students in Stanford, the Siddharth, so that he's working on the mapping the tree species. Right, so Stanford, and also he's a very brilliant. A few more people are working on those areas. Right, we want to try to bring into the recently heard about that India lost about 50 million trees in the last, right? So that's because of they're able to pick up that high resolution data, the which trees we're losing, what are the age class of the trees losing, why it's losing. So that's now they're looking at the canopy level, how that particular canopy respond to different season. So then that's one. Then it comes to the species like a diversity. We did. I did my PhD in the mapping the biodiversity of India. So in the Indian Institute of Remote Sensing, then the DAS DBT, the very largest project at that time. So that's where try to look into the different canopy structure and diversity, those things. So they are very good actually. That if we come out with some high throat foot mapping of the tree phenology, we did. I'm not sure that one. We did something like mapping the agroforestry using the UAV. So I fly the drone in this campus in the GKVK and look into different species. Then also in the Kazari, there's a different like a neem. They have 350 types of neem, same variety. Moringa, like a we took the signal, fly the drone, and you can put the hyperspectral signature of that individual tree. We plotted that one, see that how that's adjoint content in the different names they can correlate it. So that's quite doable. What is required is your sensor calibrations. That's if you are very good on that. I think that's where the Indian new innovations should be investing that landscape. We all are busy in only spraying other things. Very menial things is there, but the platform is earlier the biggest challenge for us was the load capacity, right? What's called how much it can payload. That was the not we have to be struggling to reduce the hyperspectral sensor used to be like a 450 gram. We seem no drone able to handle. You have to come out to the like a the 300, 100, something like that come down. So because of the load capacity, now people looking, why not worried about the reducing my sensor capacity, and drone is carrying the capacity to load the 10 liters of the water. So that's where the shift in the payload and sensor aggregations and reducing that is now different levels now. Because the capacity of the drones, the battery is improved and flyovers is improved, and stability, everything is going very, very rapidly, so that we can spend more on the putting the much better, smarter cameras, sensor. I think that's where the new growth of the drone industry, massive amount of the applications there. Everything I see that there is an application from the drone. So I have to look into that way. Yeah.
I mean, we have received a lot of inquiries regarding this. Like, so every time, it's been getting a good sensor at a decent price has been the challenge. Right? Like in Northeast, like we have been helping out with road construction projects.
Oh, that's right, yeah.
Right.
Any shack, so that's why they're doing some work, Northeast Space Application Centers. So, yeah.
So there, basically, the species identification is a very important thing for them, because, and that's, I think, a very good challenge, speaking both from an economic as well as an ecological perspective.
It's very true, even like old trees, they're passing the road so that it's, you cannot replant that's 100-year-old trees, because surveyed all kinds of the weather and everything. So preserving that seed is, that tree is much better than planting 1,000 acres. So that kind of the critical identification is required. So diversions is, in fact, I saw there's the road they taken over because of this big tree, permanent tree was there. So that's required. That's where the mapping is, details required. Otherwise, what the general remote sensing, the map is a forest cover, but you don't know what big tree it is there, and what is the length, height of the tree, massive canopy, number of birds is supporting. There where the drone can do much better job.
Thanks, sir. Very insightful session. Thank you so much.
Thank you, so thank you very much. Any more questions? If not, so in order to be like what you learned from the one very critical new idea you're thinking about. So you came to learn the drone and UA in agriculture and allied subject. So did you thought something in the last 3 days lectures, some very bright idea that your children or your student or yourself can carry forward? Can anyone able to tell that one thing? Where you think about out of your box, like so all you learn about things that something like I want to use the drone like this. Yes, please. Yeah. Yeah. No, they don't worry about the student capacity. The faculties, yeah, because never underestimate students. Give the ideas, they will do it.
Yeah, on ground it's quite different, just like
yeah.
So we were thinking, why not look into urban planning or environmental planning aspects.
Yeah, interesting.
From drone perspective, with respect to policy or on ground, studying the ecology in the urban area.
Oh, that's fantastic. Oh, that's very great. Right now, so that we are relaunching, that's called regreening the Bangalore, right? So that how much the roof areas, there's a tree, there is no green cover. How much the empty roofs are there?
Yes.
I can fly.
So they are trying to do tree census and everything, so species related study. So that has to be done at a larger scale because Bangalore is now growing.
Yeah.
So
something you need to do the automatic, like take the drone shot of your particular area or what's called the particular layout, and take one snaps in the same time and like every month, and take next and with automatic change detections. Yeah, this tree is disappeared here. So something like that trigger the
Yes.
the people,
Yes.
like what's happening. We are losing one tree here,
Yes.
something like that. That's
Yes.
very good. And as per the city's the green policy, we need to have at least 15% green cover to
Yes.
35% green cover.
Yes, sir.
So, but we not have. Bangalore is 95% green cover we lost.
Yes.
And flood is happening because of that's one. Then heat island effect is too
Yes.
high. So look, understand the heat island, how much the heat, like thermal, we are talking
Yes.
about that. How much the given day, which building is emitting the more heat? Are that building? So for example, simple like there no insulation is not there. Even very striking that when people talk about, oh, we are doing the saving, something that you can close the tap, something that water wasting. You know that what is the biggest water waste in household and hotels? Which one can you guess? Anyone? Yeah? Flush? No. No one you think about that. Massive amount of the water wasted happens. We go to the hotels, when you turn your bath, you wait for the hot water to come, right? Because sometimes it takes 5 minutes, 2 minutes, 10 minutes. Until hot water comes in the winter, you're not going to touch the water. Because the amount of the bucket of water goes until hot water comes, just because of the lack of insulations in the heater pipe. So what else people, they didn't understand that, why the water is going so much in the winter. Because of the insulations, like I told some of the couple of the ITC hotels, some of that one. And one time I went there, it's very cold, even like in Manipur, then otherwise in Nepal. There's one of the very good hotels. I saw that open the tap, keep on, it's like a water, no hot water is coming. So I was not feeling well, I not wanted to take cold water. Then just calculate the amount of bucket. If 15 buckets of water, 16th bucket, warm water came. I put my timer and waited until how much water. I went to the manager, so how much water is happening, wasting you are. He told, sir, both, it's last water going. You know, where it's going? He didn't realize. Because of you not have insulations from the solar heater to the bathroom connections, we just changed that one. I'm so glad I last visited that one Nepal again after 3 years. And he invited me, sir, come to the hotel. Then I went there, opened the tap, hot water came. I said, what he did? He said that he insulated the entire pipeline. So amount of the water saying that, sir, the amount is now reduced drastically. Earlier he was like every day 2 tanker coming to fill. Now he comes once in 3 days. 6 tanks of the water, 5 tanks of water saved. That amount. That's the one I'm telling that. You can monitor from your thermal sensor amount the heat generating, cold generating. So there's so many applications are there. Yep. I know time is up. So Umesh is waiting here.
Another 10 minutes.
Yeah. Okay.
We'll leave for. Thank you very much, sir. A round of applause to Dr. Chandrasekhar Biradar, sir. So now we'll have a 10 minutes quick tea break. After that, we will be having a valedictory function. So we are waiting for our chairman, sir, to join this valedictory function. During that, we will have presidential remarks and certificate distribution. After that, we can depart from this. So we will have 10 minutes quick tea break. Thank you. Thank you very much, sir, once again.
Oh yeah, please.
Sir, some time.
Available so that they also some fresh up time. Huh. Ah, okay. Yeah, that's true. That's very good.
have to submit it. Sir Kantaraju. Kantaraja J, Office of a Senior Assistant Director of Horticulture, Shimoga.
Sir, Morena. Sir, Nodi.
Shimoga.
Ramesh sir, Rasab sir, Morena.
Apart from this place, Shimoga. 250, yeah? 250.
Kodi ಇಲ್ಲಿ ನಾನೇ ತೆಗಿ.
Chandrasekhar also from Shimoga.
Just I wanted that background.
Okay.
You know something. Thank you, sir. Thank you, sir.
Thank you.
Thank you. Feedback ಅದು fill ಮಾಡಿಲ್ವಾ? ಭಾಸ್ಕರ್ ಸರ್
ಅದು ಫೀಡ್ಬ್ಯಾಕ್ ನೀವು ಫಿಲ್ ಮಾಡಿ. This is separate. This is another pure. Username is your registered email ID and mobile number. That earlier you have registered, no? Using your email ID and mobile. Sir, it is. Yes, sir, you will keep another box. TP number and mobile number. Mobile number. Correct. TP number 63. 63. Seeing that I remember everything now. TP number 63. Mobile number. The vehicle ID. अच्छा ಎಲ್ಲರಿಗೂ ಶುಭ ಸಂಜೆ. ವೆರಿ ಗುಡ್ ಈವ್ನಿಂಗ್ ಟು ಒನ್ ಆ್ಯಂಡ್ ಆಲ್. ನಾವು ಈ 3 ದಿನಗಳ ರಾಷ್ಟ್ರೀಯ ಕಾರ್ಯಾಗಾರದ ಅಂತಿಮ ಘಟ್ಟಕ್ಕೆ ತಲುಪಿದ್ದೀವಿ. ಈಗ ನಾವು ವೇದಿಕೆಗೆ ನಮ್ಮ ಗಣ್ಯರಾದ ಅಧ್ಯಕ್ಷರು ಪ್ರೊಫೆಸರ್ ಎಚ್ ರಾಜಾ ಸಾಬ್ ಸರ್, ಹಾಗೆ ನಮ್ಮ ಸದಸ್ಯರು ಆದ ಡಾಕ್ಟರ್ ಚಂದ್ರಶೇಖರ್ ಬಿರಾದರ್ ಸರ್, ಹಾಗೂ ಡೆಪ್ಯೂಟಿ ಡೈರೆಕ್ಟರ್ ಫ್ರಮ್ ಮ್ಯಾನೇಜ್ ಡಾಕ್ಟರ್ ಭಾಸ್ಕರ್ ಗುಜ್ಜಿ ಸರ್, ಹಾಗೂ ಡಾಕ್ಟರ್ ರಮೇಶ್ ಸರ್ ಅವ್ರನ್ನ ವೇದಿಕೆ ಮೇಲೆ ಬರಬೇಕು ಅಂತ ಕೇಳ್ಕೊತೀನಿ. I request all the dignitaries on the dais to come. Now I request our colleague Shri V.K. Srinivasu sir to welcome all the dignitaries on the dais and delegates.
ಎಲ್ಲರಿಗೂ ಶುಭ ಸಂಜೆ. Very good evening to one and all. Today we are in the last stage of this 3 days national workshop on drones, their importance and applications in agriculture and allied sectors. So today in this valedictory function we have our Honorable Chairman of KSTA, Professor H. Raja Saab sir. So on behalf of Manage, on behalf of all of you, my own behalf, hearty welcome you sir for gracing this occasion. We have another distinguished scientist, Earth System Engineer, Professor Chandrasekhar Biradar sir. He is also an honorary member of KSTA, and also sir gave wonderful talk on the just last session on drones and its applications in agriculture, precision farming. So on behalf of KSTA, my own behalf and all of you, hearty welcome you sir for gracing this valedictory function. And we have a sponsor for this 3 days national workshop, Dr. Bhaskar Gujji sir. He is very humble personality and he was staying here only in Academy guest house. So thank you sir for our sponsor the program. Hearty welcome you sir. And also for this program, the main man behind this program, so our CEO Dr. M. Ramesh sir. So on behalf of all of you, my own behalf and KST, welcome you sir for this wonderful program, for your all support and kind cooperation. So once again for this valedictory function, hearty welcome you to all of you. So thank you.
Thank you Srinivasuji, also welcome to you on behalf of all of us here. So now I request our chief guest Dr. Chandrasekhar Biradar to give few remarks on this event.
Thank you, Umesh ji, and thank you all, and the dais, our chairman, Professor Rajesh sir, and the man from the rally took 3 years efforts to bring these people together and work on this one, Bhaskar ji. So from the manage really, he's really managing the bigger role on the capacity building for the scientists and young entrepreneurs. And of course our coordinator, our good friend and a colleague, and Dr. A.M. Ramesh sir, and Umesh ji, and all the KSTA efficient team, and all the faculties or participants. And it's such a pleasure here. I think I don't need to give any chief guest address here because I just finished my talk just a while ago. And only one request is that one, so every time, everywhere I go, that they give the rose, beautiful rose on the plastic, right? Don't give the rose in the plastic, just give the rose, right? What happens, you give the rose, people they take it and put like this, so it will be a beautiful way. So just give that, so that you're reducing the one plastic. So this environmental day, get rid of the plastic is our motto. Yeah. So next time, it's no one mind giving the just beautiful rose like this looks much better than the plastic. So just request, so that everyone can sit in the stairs. They put like this, so it looks beautiful. Okay, Chacha Nehru. So it's such a pleasure that I look into the entire different lectures and very keynote speakers and very really practical people that spoke on these things. Of course, I missed all the lectures, but looking into the name of the people and the presentation I've done, I think this is wonderful. I think this is very need of the hour, the drones and UAV in agriculture and allied subject, because of we have the nearly 68% of the country's landscape comes under the land use category, there's agriculture. And what can do much behind that one? I think as you spoke a while ago on that drone behind the sprays. Amount of the massive applications is evolving on the drone, including their market segment and the share and applications. As you are using the phone, smartphone, they come, it killed all the other gadgets. Earlier when you go to our excursion to the sampling into the Himalayas, we're carrying so many equipments. We have the camcorder, we have the batteries, we have the data recorders, and there are the files. So many equipment is there. Right now, just one smartphone, you can kill nearly 175 gadgets. Right? So that is the versatility of the smartphone evolved. Same thing, the drone is going to happen in the decades, in the years to come. Other than just I'm testing with my children that what do you think about the drone? Is how best we can help you? He told that I can use it for. I thought that he's use it for something like the spraying or something like that one. They are completely in a different area of the thinking. They think that's what so small things I not want to do that one like and let the drone can take care of their jobs, monitoring and something that one calculations they can do it. So those are the real the evolving the things is coming up. I think this is where we need to put into the the professor telling that we give the ideas to the students, they find the way to get it done, right? So that you give the cultivating that a better idea for that. Same thing in the agriculture and you learning these things. Think behind that one. Like I learned something I want to apply. No, what I can do better than this. Usually when we go to the capacity building programs, we try to copy that. Oh, it's using that one for this we can do. No, that is not the way. So we have to do much one step ahead of that. While doing this one, I found this particular limitation, this technology is drone, I'm going to address that, fix that. That's what's called the science and evolution of the science. Do something better than that. When looking at all the technologies, we are India with AI, machine learning, big data, remote sensing, we are the end users. We shouldn't be end users. We should be generators, new technologies, new innovations. That you can do to the rest of the world. Okay, it's come from that. I was in US, look at NASA, large number of the scientists sitting in the NASA. And all the multinational companies. The most of the Indians, they're in the tech savvy. In Indian, someone Indian, you can say, oh, this must be the software guy or something like a science or mathematicians or doctor. So that's the imaginations are like people think about that one Indians. But when it comes to technology ownership, number of the patents, number of the international recognitions and awards, Nobel Prizes, we came very low, bottom. Despite of the 16% of the world populations, 1.45 billion people, amount of the technology we are introduced in the world as compared to Scandinavian countries, compared to our neighbors, China, we are very rock bottom. So we need to change our perspective, think what I can do better than what existing rather than copying it. Of course, you require use applications. Think behind that one, I think that's what the take-home message from today. So all the training programs, manage directors, I'm just talking about that one. You can also tell them about, we are teaching the people to what is giving the exposure to the technologies, but you use that one to do something next, what you can do that. So that's what the take-home message. Thank you once again, KSTA Manage for the organizing wonderful event, and everyone, the wonderful spectators, our audience, or the trainers, they're going to be the next big level trainer. Thank you.
Thank you very much, sir, for giving a takeaway message that not only learning, but we should learn to how to implement it and execute in the field as well as giving back to the society. Thank you very much once again. Now I request a few of the participants voluntarily to come and give your feedback about the event. Voluntarily, quickly, we are running late of time. Yes, please. Please introduce, sir, and you can come here on the desk.
Yeah. Very good evening. It was a very scholarly experience with so many experts, starting from the drone construction all the way to the gamut of applications. It was a wonderful experience for us. And moreover, it was a very good networking opportunity. That's why I always look into. And I'm a computer science and AI person, but we always solve agriculture and other problems without even talking to them. Take some data set and treat it as if it's one more data set. It can be anything. So without any domain knowledge, this is where we could network with many of the experts here. This is a wonderful opportunity. And I'm very sure some bigger things are going to come because of this one-on-one interactions. Thank you so much.
Thank you very much, sir.
Thank you for the wonderful training that we had for the last 3 days. As sir mentioned, starting from the basics of drones to the application part of it. Probably one part, I'm an agricultural expert, and one part they missed to touch is basically the drones can also be used for what is called supplementary pollination. I think sir was asking, where you can just increase the thrust through the airflow, and then particularly in a crop like rice, which is genetically a self-pollinated crop, and we are trying to make it a cross-pollinated crop. And there are studies which says basically you can increase the yield by 5 to 8% just by the supplementary pollination. Probably that is one part where there was no mention, but overall wonderful training. And thank you, Umesh ji. I think you all alone, you was single-handedly managing the whole thing, coordinating. Thank you. Thank you, KST, and all the speakers. It was wonderful 3 days.
So that's good.
Thank you, Prasanna sir. Thank you.
The pollinations in Saudi Arabia are using the drone for the date palm pollinations, but for agriculture crops,
Yes.
are still a lot of these.
Yes, please come.
Thank you, KSTA. I was impressed last years they have conducted the drone applications for, remote sensing applications for agriculture. So this time I was inspired by last year, so that's why I came here offline. So it was, that was online. I attended there. I attended during on my field visit, so I couldn't concentrate much. But this time it is like very good. Being offline here and interacting with many of you here with different streams. So of this 3 days, it would I sense like there are different components of drone, right from manufacturing, how it flies, the dynamics, the principles, the rules, the cameras, the data, and the upcoming, the applications. And good that drones can be used in other sectors as well, like a flash of light, like in smart cities, and also drones can be used in ocean cleanup activities too. So it is because it's very difficult in that remote areas. How do they clean up the oceans because of the loss of plastic is there. So it's been very great. That gives the flash of light also in different fields, so we could think. Thank you so much for organizing, and please invite me also every time you contact. I'm from Hyderabad, so I'm a data processing expert, so I deal with drone data sets and also for the application oriented things.
You tell sir, he's also from Hyderabad.
Yes, sir. Yeah, I have been to manage couple of times when I was working with Vasan. So we knew manage and the team. So I have seen people manage last year also. So it was great. Thank you so much for conducting, and please be doing the same next year also.
you did a very good summary, so that you made job easy.
Sure.
Thank you. Thank you very much, sir. Anyone else, sir? Madam, please.
A very good evening to all the respected people on the dais and of the dais. So this training program for last 3 days I have been attending here. Actually, it's the first time like I have little like whatever we know generally about the drones and UAVs, but as such as any structured any training program I have not attended in related to UAVs. So it was really very good exposure for me. I could understand the basics and applied section we keep seeing like through videos or in the in the field how we have been using it for last few days. And the best part I feel is it's good to know about the basics of drones and all that. Because I'm not from that field, but from my field for the allied sector, whatever we could get to know from the practical aspects. Like we had a progressive farmer yesterday, then today also we had very good lectures. So we could know like in agriculture when we are using, so what are the benefits we're getting and what are some aspects where this technology has to be improved further. Because he also explained yesterday, Dr. Nagraj, like he's a person who's into academics as well, and he's giving services, drone-based services to the people, and he was telling that he was very enthusiastic when he started, but there are some aspects where he's not able to, maybe that breakthrough point he couldn't achieve even after the 5 years into the venture. So I think, means what I could understand, there is something which still has to be there for further application part, and it has for this to become practicable. And like sir mentioned, that was a very good platform where we could meet people from different areas. And like sir, he told he's into AI. We are in agriculture department. I'm from College of Horticulture. Sorry, I couldn't tell earlier. So we were talking to sir how we can collaborate, where we can make use of the informations and the expertise that they have, and we can put forward our requirements. So that way it can be made actually to be put to the use. So with these words, again, I would like to thank KSTA, Manage, and all KSTA team who have given chance to us to attend this program. Thank you.
Thank you very much, ma'am. So anyone else? Madhavaya sir.
Thanks a lot, sir, for inviting me, because I am from mechanical domain. Of course, I had this experience of dealing with different departments while I was serving in Government Engineering College. If you look at whatever the domain, like drones are applied for here agriculture and allied sectors. We have a greater focus on agriculture because it's a big area, and India is basically an agricultural country. And allied sector, as sir said, that we can actually take a cue out of this program and apply to your own domain or your own thought process. Probably innovation will happen then, because we are actually thinking in a framework that drones can be applied only for these kind of things. So only when we get out of that framework, probably drones will do fantastic. Probably n number of sectors where we can actually start using drones and take it to an entrepreneur level. So that is the cue out of this program. And for all those things, we need technology. If you don't understand technology, you cannot apply it to anything else. So the digital technology and the AI technology is the fundamental. So I request Ramesh sir and the team to focus on the fundamentals, because many of you are not from the technology, few of us from technology. computer science, electronic guys can understand a lot of things, but other guys need not understand the completely technology. But they may fly. That is not the whole idea about drones. So what you can do with that, and how can you program? Because I have seen a while evaluation of the student projects at engineering colleges. So they bring some components and build the drone. They could able to fly because the latest generation is very good at it. They play a lot of video games, so they can easily fly. But if you look into the fundamental aspect, first principles, they lack totally. They do not know what is it. So I was talking to Dr. Srinivas about the same thing. So fundamental is the crux of the program. So once you understand, you can take it to the next level. Otherwise, you cannot do much more than that. I would like to quote one aspect of this idea about having fundamentals pakka or exploring deeper into it. Probably 10 years back, I was attending NVIDIA conference, and where they were talking about all the GPUs which actually run behind the scene a supercomputer, which actually takes millions of data inputs from the machine. So Schumacher was in the forefront, and his Formula 1 race car will have thousands of sensors which will be giving the input in real time. And these are all done by behind the scene NVIDIA processors. And who can drive at most? Schumacher is capable of understanding each and every bolt and nut of the Formula 1 race car. That means one who understands the bolt and nut of every system can do something miracle in whatever the domain they choose. So this is what I understand. And thanks a lot for KSTA and Ramesh sir especially, because he forced me to come along with my friends, and I attended. Of course, this workshop has gone beyond my expectation, and thank you all for organizing such a wonderful event. Thank you, sir.
Thank you very much, sir. So if anyone would like to give feedback. So tribal youth, one person can come from Magadi. One youth can come and one youth can speak. From Rotary Club Bangalore, they have been deputed here from Magadi, sir. Madam Mundila, sir.
ನನ್ನ ಹೆಸರು ಪ್ರಕಾಶ್ ನಾಯ್ಗ. ನಾನು ಮಾಗಡಿಯಿಂದ ಬಂದಿರೋದು. ನಮಗೂ ಇದಕ್ಕೂ ಏನೂ ಗೊತ್ತೇ ಇಲ್ಲ ಅಷ್ಟೊಂದು. ಇಲ್ಲಿಗೂ ಇದೇನು ಹೇಳ್ಕೊಡ್ತಾರೆ ಅಂತ ಏನಂತನೂ ಗೊತ್ತಿರಲಿಲ್ಲ. ನಮ್ಮ ಸರು ಇಲ್ಲಿ ಕರ್ಕೊಂಬಂದರು. ಅವ್ರ ಸಂಸ್ಥೆ ಇದೆ, ಎಲ್ಲರಿಗೂ ಧ್ಯಾನ ಮಾಡಿಸೋದು, ಮಿಕ್ಕಿದೇನೇನೋ ಮಾಡಿಸ್ತಾರೆ, ದೇವ್ರ ಬಗ್ಗೆ ಎಲ್ಲ ಹೇಳ್ತಾರೆ. ನಮಗೂ ಡ್ರೋನ್ಗೂ ಏನೂ ಸಂಬಂಧನೇ ಇಲ್ಲ. ನಾವು ಓದ್ತಿರೋದು ಕಾಮರ್ಸು. ಏನೋ ಹೇಳ್ಕೊಡ್ತಾರೆ ಅಂತ ಕರ್ಕೊಂಬಂದರು. ಅದರಿಂದ ಡ್ರೋನ್ ಬಗ್ಗೆ ಗೊತ್ತಿಲ್ದಿರೋದೆಲ್ಲ ತಿಳ್ಕೊಂಡ್ವಿ. ಮತ್ತು ಡ್ರೋನ್ ನಾವು ಅಂದ್ಕೊಂಡಿದ್ದು ಬರೀ ಫೋಟೋಗ್ರಾಫ್ಗೆ ಮತ್ತು ಸುಮ್ಮನೆ ನೋಡೋಕ್ಕೆ ಎಂಟರ್ಟೈನ್ಮೆಂಟ್ಗೆ ಅಂತ ಅಂದ್ಕೊಂಡಿದ್ವಿ. ಅದು ಕೃಷಿಗೆ ಇಷ್ಟೊಂದು ಇಂಪಾರ್ಟೆಂಟು, ಮತ್ತು ಇನ್ನು ದೇಶಕ್ಕೆ ಡೆವಲಪ್ಮೆಂಟ್ಗೆ ಇಷ್ಟೊಂದು ಇಂಪಾರ್ಟೆಂಟ್ ಅಂತ ಇವಾಗ ಗೊತ್ತಾಯಿತು. ಸೊ ಥ್ಯಾಂಕ್ಫುಲ್ ಇಷ್ಟೊಂದೆಲ್ಲ ಹೇಳ್ಕೊಟ್ಟಿದ್ದಕ್ಕೆ.
Thank you. So I request the rest of the people to give feedback in the online. And now I request our Dr. M. Ramesh sir to give Chief Coordinator's remarks.
Good evening, ellargu namaskara. Honorable Chairman of KSTA, Professor Raja Saab sir, Dr. Bhaskar Gujji sir, my friend Dr. Chandrasekhar Biradar, my colleagues and all participants. First of all, I must compliment all the participants for being with us for all 3 days. You have set an example for youngsters right from morning to evening. All seniors who are here, my friend Professor Madhavaya sir, although he is an emeritus professor, he has been here since last 3 days. That is the take-home message for youngsters. You have to be in the workshop at right time, and you have to attend all the sessions. We have planned the sessions in such a way that it is interconnected, so that students can learn better and they can apply in their own field. I take this opportunity to thank Dr. Bhaskar for giving us this opportunity to host a small workshop. In fact, when former DG Chandrasekhar sir had come here, had asked for a big conference here. Of course, he could not give. He granted only 3 online conferences. Now that Dr. Bhaskar is here, we would like to organize a national conference on drones. Please try to help us so that many students will be benefited by the conference. And the program schedule, as you see, I am sure all of you would have appreciated. And yesterday, my friend Dr. Harish, day before yesterday night, called me and asked whether a progressive farmer could be included for a talk. Immediately I said, okay, but the slot we were searching, and fortunately one slot was there. He could come and give his practical experience. We have invited mostly the experts who have practical experience, not just theoreticians. Dr. Omkar sir, he has developed many applications of drones in IASC. I am sure he would have presented it today. And Bhaskar sir would have appreciated all the presentations that were held. And Dr. Chandrasekhar sir was talking about patents. In fact, India is in 42nd rank in the world in number of patent applications. But our aim is to rise to $5 trillion by 2025. I am sure we are nearing 5 trillion, but it is possible only through youngsters. Youngsters with the innovative mindset can certainly bring many applications which could be used. If you take America, it's around $25 trillion. And most of this GDP is from innovation. 40 to 50% is from innovation. India has to reach up to that level to become a advanced country. I'm sure many youngsters are here. I'm sure you will take a lot of take-home message from our training and develop many more applications. And next time when we organize, we'll be inviting you as a resource experts. Okay? And our person from Magadi told that the organization was teaching about ದೇವ್ರ ಬಗ್ಗೆ ಹೇಳ್ತಾರೆ ಅಂತ. ನಾವು ದೇವ್ರನ್ನ ಹೆಂಗೆ ಕೇಳ್ತೀವಿ, ಮೇಲ್ಗಡೆ ದೇವರೇ ಅಂತ ಕೇಳ್ತೀವಿ. ಅದೇ ಥರ ಡ್ರೋನ್ ಮೇಲ್ಗಡೆ ಇರೋದ್ರಿಂದ ಯು ಕ್ಯಾನ್ ಕನ್ಸಿಡರ್ ಡ್ರೋನ್ ಆಸ್ ದೇವರು. ಓಕೆ, ಸೊ ದೇವ್ರ ಬಗ್ಗೆ ಸ್ವಲ್ಪ ಅರ್ಥ ಆಯಿತು ಅನಿಸುತ್ತೆ. ಸೊ ನೆಕ್ಸ್ಟ್ ಟೈಮ್ ಇನ್ನು ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಜನ ಕರ್ಕೊಂಡು ಬನ್ನಿ, ಸೊ ದಟ್ ಅವ್ರಿಗೆ ಹೆಚ್ಚಿನ ಒಂದು ಅನುಭವ ಸಿಗುತ್ತೆ ಡ್ರೋನ್ ಅಥವಾ ರಿಮೋಟ್ ಸೆನ್ಸಿಂಗ್ ಅದ್ರ ಬಗ್ಗೆ. ಐ ಆಮ್ ಥ್ಯಾಂಕ್ಫುಲ್ ಟು ರೋಟರಿ ಕ್ಲಬ್ for sponsoring 5 of them for this program. And as Onegoda sir was telling yesterday, imagination is the limit in drone applications. Applications are many, and many people have to work to realize the imaginations. And sir was telling about collaboration. So collaboration is right. It is you have to have a collaboration with other discipline. Otherwise, you can't progress. An engineer has to collaborate with an agriculture expert, and agriculture expert has to collaborate with a data scientist or AI. So that they can collaboratively develop many applications. No one can be in silos in this era of technology. So I am sure it has helped you in networking with experts from other domains. Further, it will help you in developing many more applications in other fields if you collaborate well. I'm sure all of you will have a WhatsApp group and chat about how to use drone in future applications. Okay. With this, I am very thankful to all of you. You have given all good feedback. If there are any flaws, we don't mind if you can tell, and we will improve next time. Okay. With this, I wish you all a great future. Thank you.
Thank you very much, sir. Now I request Professor Rajasab B.H. sir, Chairman KSTA, to give presidential remarks on this event.
Good evening, everybody. Not much for the President. I have been here last 3 days, just coming for 1 or 2 hours and going back to other work. I have been observing you all people. I went through the program of this workshop on drones, and I was very much appreciative of the organizers. They have done carefully well, organized everything very diligently. And this drone technology is a technology of infinite applications. Imagine anything, drone can be in there. So that is the wonderful thing. Long before I saw drone for the first time when my son from America brought it here to India. Then I asked him, what for is this? What he told I don't remember, but he demonstrated its flight. He took me to the top of the building and then operated it, and up to about 500 meters from our house he operated it, and then there were no much restrictions. It was free. And now you can't do it. Then I thought it is a wonderful, very maybe recreating also for the youngsters technology. And afterwards one big news appeared, especially in Karnataka, one drone Pratap. Have you heard? Many of you might have heard. He is a very, very wonderful storyteller. If he takes coffee, he will say that I ate just biryani and came. Such a wonderful, he synthesizes the, that's also a tactics, a good imagination capacity. Then everybody was sensitized about drone. He built a very good story. Of course, where is he and what is he, I don't know. But I remembered that there was one person in Karnataka. That's another thing. I belong basically to agriculture, especially plant pathology domain, and for my research in Mysore University. During our time, there was nothing like this. Now, drone technology can be applied in that field also to diagnose the diseases of the crop plants, to measure the intensity of the disease, and also soil conditions, and also to apply fungicides or whatever chemicals, biological pesticides, etc., biocontrol agents also. And in forest pathology also it plays a big role. And now I heard from one of the delegates here about pollination. That is a very good thing to hear. If you can increase the pollination receptivity of the plants as well as the effect of the pollination to increase its percentage, it has greatest advantage in different crop species. Like that, there may be many more drone applications. Then with regard to my friend rather, Dr. Chandrasekhar Biradar, we know one another last 20 years. I was dean and professor in Gulbarga University, which is very near to Hyderabad, Andhra Pradesh border. I don't remember, maybe it was 2003 or 2004, we organized a National Phytopathology Conference in that place. I invited Dr. Biradar, Chandrasekhar Biradar. He was very young at that time, even now also, that is another matter. He was working in University of Oklahoma, State University. He happened to visit India at that time at his cost. I made use of that opportunity and welcomed him, invited him to our university to inaugurate plant pathology conference. He talked about resource mapping. He is expert in that field also, natural resource mapping. This is what I remember. Since then we are good friends, and again he has come back from USA and dedicating himself and also his knowledge to the welfare of the people of our area. That is good, and we are making best use of him in our academy. Like that, there are many more good professors in our board, and I am fortunate to be with them as their chairman, because the people who work are the really who are employed here, Dr. Ramesh and his associates. Each one of them is expert in their own field, and they are working very excellently. You may not believe, today is 13th, right? 12th. 17th we have another conference, just after 5 days. What is that? Dr. Srinivas is organizing that. Data analysis. That is also a wonderful field. Artificial intelligence, machine learning, artificial intelligence, data science, and so many things we are hearing nowadays. So they have chosen data analysis, and one of the former vice chancellors of VTU, Vishweshwarya Technological University, he is the guest, going to be guest. And many more good speakers on data analysis. I think like drone, that word also is a very catchy word. Data analysis, very important. Like this, our academy is doing its best to reach the people, involve the students, involve the researchers, involve the scientists, bring them here and expose them to the newer ideas, newer technology. That is the main goal or motto of our academy. We are doing our best, and our officers take the credit rather than myself or the chairman. No, it is their work, and I should appreciate them for their good work. And you have come from different places, and you must have got some insights in these 3 days, and you must have developed good communication, friendship with your fellow mates, new contacts, or you might have strengthened the earlier contacts. This is what should happen in the workshop or conferences. So we will be holding several conferences, workshops, seminars like this, and we will be honoring the best students, best scholars, best scientists, and also those science scholars who communicate in the local language. We will give, at the end of the year, we give awards. Like this, our academy has its own way of working. Our aim is to see that our academy reaches the people. We should carry the fruits of science to the people and learn from the people as feedback, and again help in development of the science. This is the goal of our academy, and our government is supporting us in all respects. Even the volunteers, private organizations, industries, they are also helping us. And one of that is worth to mention is Dr. Bhaskar Ujji from Hyderabad Institute of Management. They have been helping us since long, and we will be looking towards them for still bigger things. We will collaborate with good scientists, good officers, especially to promote science. And I thank all of you for your for taking trouble of traveling and spending some time here. Go back with good memories and improved knowledge. Try to apply them to in your local area, and overall aim is to serve the people at last, serve the people in different capacities. So I wish you all the best. Thanks for coming.
Thank you very much, sir. Now, before giving certificate to the delegates, I would like to show 1 minute video of this 3 days events glimpse, which is prepared by Mr. Anthony and his team. Bhaskar sir, would you like to speak, sir? Yes, yes.
Thanks to Anthony and his team. Now I request Dr. Bhaskar Guji sir to speak few words. Sir, 2 words. Sir, good evening to all respected dignitaries on the dais and friends. Already the last 3 days we have been covered a lot of things, and thanks to particularly KSTA for collaborating with Manage for conducting this exclusive program on drones and UAVs. So definitely sir, we'll try to collaborate in future also. So you may, whenever a new team comes, I think we'll on science and technology definitely will be parting with the KSTA. So I will thank you very much. Thank you very much, sir. Now I request dignitaries on the dais to give the certificates to delegates. Participants.
So everybody is waiting for this, I think. Virappa Arakeri, Akka Foundation Trust.
Yes.
I request all the dignitaries to please.
They are here. Please raise your hand. Otherwise, you will skip. No.
Nagendra Rao, Swifter Creative Services.
Sir, please.
Please.
Next.
Basavaraj Allikeri. Nischala Mrinal. Nischala Mrinal. Devraju, Assistant Director of Horticulture. Meenakshi Sood, College of Horticulture, Bangalore. Shimi Bali Mishra, Rewa University.
Shimi Bali is not here.
Kishore SM, Shivamogga. Bhavya KV, Kavana SC, Kavana, Horticulture College. S. Srinivas, RNS Institute of Technology. Yashwant HR, University of Agricultural Sciences, Dharwad. Shruti U, RNS Institute of Technology, Bangalore. Ambika DS, College of Horticulture, Bangalore. Nirmal Basil, Rewa University. Sanoj Rai. A. Anand Kumar, Director of Agriculture, Mysore. Vaidehi KV, Rotary Skyway, Magadi. Punit Nayak V, Rotary. Sir, Punit Nayak. Chidananda R, DATC, Chikkanhalli, Shira. Prasanna Kumara C, Bayer Group, Crop Science Limited. A.T. Kishore, Dhanvantari Institution, Bangalore. Banda Tejashwari, Deloitte Touch. Bhartisha SM, University of Agricultural Sciences, Dharwad. Bhartish. Raghunath Reddy sir, UHS Balkot. Jagdish Babu, BS URL Satellite Center, Bangalore. Bolledula Sainath, Rewa University. Meghana KG, College of Horticulture, Bangalore. Meghana. Manasa SR, US Dharwad. Tarakeshava, CR.
Clarity.
Mahadevaya, Clarity, Bangalore. Clarity, ಮೂಡಲಗಿರಿಯಪ್ಪ ಅವರು ಬರಲಿರುತ್ತದೆ. ರೇಣುಕಾ Shrikant HS, College of Horticulture, Bangalore. Amrita Das, Reva University. Deepak M, Veda Prakash, Clarity. Vaishnavi V, Rotary Skyway, Magadi. Rohini N, Environment Planning, Bangalore. Manjunath BB, Sambram Institute of Technology. BR Ellikeri Nursery. Ellikeri. Ashwath Narayan Reddy, Horticulture Research and Extension Center, Kolar. Prakash Nayak S, Rotary Skyway, Magadi. Lasya Gopal, Invotech Private Limited. VS Iremat, Daivi Ventures, Dharwad. Thank you also. Yes. Thank you also. Now is the time to propose vote of thanks. The coordinator of this 3 days national workshop, my colleague, Mr. Umesh Gatiki, scientific officer, I request him to propose vote of thanks on this occasion.
It's already delay. Very good evening to one and all. Ellarigu Shubha Sanjay. I won't take much time. First and foremost, I would like to express my gratitude to our chairman, Professor A.H. Raja Sahab sir, for his encouraging words and support for the organizing such outreaching programs and as well as this national workshop. Thank you very much, sir, on behalf of all of us and manage. Also, I would like to thank Dr. Chandrasekhar Biradar sir, whose mercurial participation in this workshop, starting from inaugural event to the technical session as well as joining in this valedictory function. Thank you very much, sir. Since it's very closely connected to your area of expertise, on behalf of all of us, thank you very much once again. Also, I would like to thank, I am grateful to Dr. A.M. Ramesh sir, who guided us for this program, for meticulously planning and enforced us always to make sure things are going well in communication with the officers of University of Agricultural Sciences, University of Horticulture Sciences, and government offices, UAS and UHS, Lalbagh, and other government offices. Thank you very much, sir, on behalf of all of us. And also I would like to thank Dr. Bhaskar Guji sir. On behalf of KSTA, DST, it is my privilege and heartfelt duty to extend our deepest gratitude to you. Your unwavering support, timely guidance and generous encouragement have been instrumental in the success of this program. You have not only shared your expertise and insights but also have walked beside us as a mentor, inspiring us with your wisdom and clarity of thought. We are truly honored to have had your presence and backing continuously from day one to day last till this concluding remarks of this event. As a token of our appreciation, we would like to facilitate you today. Please accept this humble gesture as a symbol of our respect, admiration and thankfulness. Thank you for being pillar of strength. I request dignitaries on the dais to honor our Dr. Bhaskar Guji sir. Thank you very much, sir. Thank you, sir. Also, I would like to thank all the resource experts from institutes and private companies who have joined with us, like Dr. S.N. Omkar sir from IISc and from Skylark Drones, Shreyas, and Progressive Farmer Nagarjuna SK, and from Dhanvantri Academy, Dr. A.T. Kishore sir and Dr. Honnegoda sir from Multiplex Drone, and Dr. Chintamani Pai, as well as Dr. Nakul Ramanna from Presidency University. And we have invited a few of the company people, other like Garuda Aerospace and other Info Aero Solutions, which they last minute it was not difficult for them to come here from outstation due to inability to come to Bangalore from Jaipur and Delhi. We regret for that, and hence we have included few more talks, and one session was missing. But I thank all of them for informing us with their valuable experience and sharing their thoughts in this workshop. And last but not least, I would like to thank our KSTA staff, technical team, non-technical team, senior officers and administrative team and accounts team and supporting staff and all the team who have helped in the canteen and took care of hospitality. And last but not least, I would like to thank all the delegates without whom this program would have not been possible. Thank you one and all. On behalf of all of us, manage and all my colleagues, thank you very much.
And thanks to the Anthony Lobo team, they are from Reva University, they have covered and also made a nice 1 minute video. So thank you all of you. And so please, I request all of you, please join the group photo with our dignitaries in front of our office. And after that, we have a national anthem now. Please, I request all of you, please stand up. Thank you.
I request to join all outside.
I request all of you, please join for group photo outside of our office.